have quite as many as NDC. We only have 4 slots, 4 sessions. So you're either first thing before lunch, probably before lunch on the first day is a good slot. That's probably the best slot for a first timer. But then because we stack the program so heavy and we try to make a flow, so like if you're an architect, you can go this line and right? So not have all the architect talks on at the same time. So then, unfortunately, sometimes you do end up with someone who's not super well known next to someone super well known, and yeah, they just get who they get. No, that's our main thing. We either have to have seen them in person or share a video, preferably both. But the personal recommendation goes a long way. But that's why I wanted to make sure you did really well because I said she's good, and they were like, "All right, we trust Adele." It's like it's very like relaxed, let's say. So it's a lot on personal recommendations. Yeah, I do a good enough job doing that myself, so don't worry. Anything you do would be inconsequential. Yeah, yeah, yeah. The Techorameter did alright. I got about 100, I think. So I got more yellows than I want. I got like 20 yellows, but Hi, welcome everybody. I think we still have a few people coming in. It is the second morning, and this talk won't fill the full hour. It'll be close, but it won't fill the full hour. So we've got a little bit of time. Got a few people coming through. Excellent. So how did we enjoy the first day of the conference? Only, yeah, okay. I wasn't here, so I need your opinion, all right? So I will be here for the next 2 days, but I wasn't here yesterday. So far that's only a moderate endorsement. So how did you enjoy the conference yesterday? Great, all right, excellent. Now I know I'm in the right place. Okay. So, good morning. My name is Adele Carpenter. I'm a software engineer at Trifork Amsterdam. I spend my day building and maintaining Java and Kotlin applications for the educational sector, although more and more you will find me trying not to cause too much damage with React in the front end. So, has anyone here seen a talk from me previously? We have one? A couple? Oh, great, excellent. So I'm a relatively newcomer, so if you haven't, that's totally fine. I really do thank you so much for supporting my work by being here today. And to the people that I have returned, welcome back. Okay, and so I do really hope that you enjoy this session as much as I enjoyed writing it. So I have spoken before about rewrites, and I use the example of Lika here, our junior engineer who just joined a team working on a large and aging Java project. And she's feeling overwhelmed with the sheer enormity and complexity of the project and feels that the only way out of her current situation is a rewrite. So luckily she is surrounded by an awesome team, and they help her see that a rewrite is rarely a good choice. And as a team, what they do is they decide that they are going to move the project forward by taking small, consistent steps in the desired direction. And I do 100% stand by that talk and that advice, but it did get me thinking, is there ever a time that a rewrite or a port is a good idea? And it turns out that this was a little bit serendipitous because around the time I started thinking about this, my team and I were presented with that very question on a customer project. So to give you a little bit of a background on Trifork, we are a project-based consultancy. The team that I work with are a little unique in that we have a product as well here called the Assessment Delivery Engine that we deliver to a small number of consumers, each of which have a custom implementation on top of our core product. So basically what it can do is it can pass assessments that comply with a certain specification and then play the assessment for the student or candidate. So it renders the questions, manages the time remaining, selects the next question, calculates the results. So we have the product part, and the custom implementations are the project part. So recently, one of our customers, the one with the most custom of the custom implementations, was starting to get a little bit frustrated with one of our applications. And to be honest, we completely shared their frustration. So I mentioned that one of the features of our product is that it selects the next question. So that seems really, really straightforward, right? You go from index 2 in a list to index 3. Well, no, not in all cases at least. So for this customer, we actually have a dedicated web service for selecting the next question. And at the core of the service is a C++ service written by a top researcher in the field of automated and computer-based student assessments. Her profile actually says automated testing, but I think for this audience, that language is a one-way ticket to a misunderstanding. So the service that she wrote is an implementation of item response theory. Now, item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. And the models of IRT are used to design, analyze, validate, and score assessments. And to make things a little bit more concrete, you can think of an item as a question of a certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a number of questions or a selection of these items. And the point of the assessment is to determine the student's knowledge of or their ability related to the topic of the assessment. Now, in a standard assessment, which I think you would be mostly familiar with, everyone gets the same questions. And for an average student, some of the questions will be way too easy, and for others, some will be way too hard. You could even have students where all the questions are too easy or all the questions are too hard, which actually makes the tool of an assessment pretty useless for them. So one of the cool applications of IRT is that you can estimate a student's ability or knowledge on the fly and to deliver a question that is at the right difficulty for them in that moment. And this can make the results of the assessment more meaningful. It also makes the assessment appropriately challenging and hopefully more interesting for the student. Now, I want to make really, really clear at this point that this C++ service wasn't bad. The researcher that wrote it will forget more about IRT and statistical validation methods than I will ever know. But we did have some problems running and maintaining it. So the service, while reliable and fast, was essentially a black box. So we sent it data and it sent data back. And we did not have the skills in our team to verify the results. We kind of just trusted that it worked and selected an appropriate next question for the student. Initially, there had been some simulation testing and validation done, but that was done by an external party. So adding features was just something that we didn't do out of fear that we'd ruin the validity of the underlying algorithms. And that was a key source of frustration for the customer, that the service, while useful, was essentially stagnant. Now, of course, we could contact the researcher that built the app in a pinch, but she's a busy woman and maintaining this service just was not her highest priority. Now, adding to this, the service itself was not a web service. So years ago, there was a developer in the team brave enough to write a wrapper around the algorithmic core to give us 4 endpoints that we could call. But our only options, if we got an error, was to basically just check our request and to retry. So adding to this, the logging in the core model was non-existent. So for example, if we had an item with an unexpected difficulty, which could be as simple as a typo, there was no logging to tell us what was wrong. And finally, since the core model dealt primarily with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, which left our requests essentially meaningless. So if there were any issues with a particular item, it was impossible for us to figure that out. And because the service was stateless, we needed to send the entire item bank in every single request, so 60,000 lines of JSON or so. So 60,000 lines of integer arrays is not something I recommend for fun. Maybe a cure for insomnia, perhaps. So then if you did decide to be brave enough and open the code base, you were presented with code that was written in the language of the academic domain. So we had some wonderful names like these. So let's go through them very quickly. So we have APAR, not too hard, a parameter, but what does that mean? Item difficulty, obviously. BPAR, B parameter, real terms, item discrimination. So how well does the item help estimate the student's ability? CurSeg, current segment, not too bad, still not explicit enough for my liking. And theta, another one from academia. Theta is the ability of the student, the thing we're actually trying to estimate. So now that you know theta, could you please yell out your best guess for warm theta? Yeah, so you could be correct, but what I wanted to say is that it's actually called warm theta because warm was the last name of the guy that proposed this method of estimation in a paper. Not because it's actually a close guess, which it actually is, so it's just one of those cool little coincidences, I suppose. And then we round out the naming with cluster and category. So again, they're academic terms, and within the team, we use the terms friends group and domain, respectively. So I hope I've made it pretty clear at this point why the current service is problematic. So it's a black box, it's hard to reason about and debug, and trivial changes take a long time and they include a steep learning curve. And maybe not so obvious though is what makes the service a good candidate for a rewrite. Does anyone have any ideas on why it might be a good candidate? Excellent. That's one of the things we thought through as well. So I've got these in order, but I think yours is coming. All right. So firstly, we had stateless. So it receives and returns data, so we don't have to worry about a data layer or a front end. And as someone that's currently working a lot in the front end, I miss this project so much. Okay, so it also has a well-defined scope or footprint. So we need to expose 4 endpoints to one service only. So it's quite well contained. And it is a small part of the entire project. So this reduces the risks or potential downside of a rewrite or a port attempt. So this brings me to what, in my opinion, are the 3 most compelling reasons to entertain the idea of a rewrite. Personally, I do think you need all 3, but you'd want at least 2. And the reason I would want all 3 is because they each look at the question of should we rewrite from a different perspective. But first, I want to start with the reason 0 because, well, we're all developers, so we are 0 indexed by design. But also because without this reason 0, then all of the other reasons are irrelevant. So reason 0, there is a desire to functionally change the application. So if an application is running reliably in production and there is no desire to change the functionality, then I would be hard-pressed to come up with a reason on why a rewrite is a good idea. So you might see odd behavior here and there, and investigating that when it happens is the absolute bane of your existence for a day or 2. But if those are few and far between and there is no desire to change the functionality of the app, then it's probably just a reasonable cost of running it in production. As long as you can do the bare minimum to keep it running, so like bumping versions wherever necessary, using long-term support versions where possible, the status quo is probably fine. But if this is the case and you still want to rewrite, you probably need to dig down a few layers on why you actually want that. Because it's probably about you and it's not about the application or the project at all. So for example, you're just not comfortable being responsible for something that you don't understand well. So, on to the first reason why you might entertain the idea of a rewrite. And we're going to start by looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. So I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to evolve your application. And there's a big implication here though, which is that the small steps are in fact small. So let's take the example of the bad logging in my Teams project that I mentioned earlier. A great quick win would be add some logging, right? So in this case, given that we are a JVM-based team working on a C++ service, that would require us to run the project locally, learn how C++ works, actually learn about a lot of stuff that the JVM abstracts away, like memory pointers, identify an appropriate library, add the dependency, learn how dependency management works in C++, learn the basics of the build tool, and then pray that it runs again. So for some teams, adding logging to this application is indeed a trivial change. But for a team that lives mostly in the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to being a large undertaking? And I also think it's a little bit simplistic to say that adding logging is always a small step. And this is the same that goes for other small steps such as improving test coverage, renaming, extracting methods, improving abstractions. Whether or not they really are small is up for your team to decide. It's not up to me or to anybody else. But what I can do is I can offer you some advice on how you might approach these discussions. And that is to be aware of your bias and to look for evidence that proves yourself wrong, rather than by having a wish and then trying to prove that it's a good idea. This will help you minimize the impact of confirmation bias in your decision making. So, for example, if you are currently feeling the pain of a legacy code base, you are likely biased towards rewriting the application in a way that is more familiar to you. So in this case, I would advise that you look for reasons on why keeping the current application in production is a good idea. So ask yourself questions like, why should I keep the existing code base? What opportunities exist to improve it? In our case, being the skeptical Dutchies that we are, we were the opposite. So we really saw a rewrite as a last resort. So our line of questioning was more around what pain are we experiencing now that can only be resolved by rewriting the application? Are the opportunities to improve the application really there? And how much work are they really? And is this really less work than a full rewrite given the makeup of the team? So this brings me on to reason 2 on why you might consider a rewrite, which looks at the team in the context of the organisation. The skills are not in the team and you do not wish to acquire them. So does the team have the skills to consistently improve the service? And if not, does the company wish to acquire these skills? So we've already established that one small step for one team could be a big step for another team. So you could be forgiven for thinking that this reason is basically the same as the first. But the key difference here is in the last part of the sentence, and that's what I want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that are in line with your company or your project's tech stack. And this is a completely valid reason for considering a rewrite of your application. And it certainly was a big reason for us. So at Trifork Amsterdam, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. We incorporate tools and technologies that are within that ecosystem, or at least closely related. Of course, we're all made up of individuals with different backgrounds. So there is some .NET experience, and if you do go wise and grey enough, you will get some C++. But our bread and butter is Java Spring, and that isn't going to change for this foreseeable period. And we're a small company and we run many of the applications that we build. So keeping the tech stack manageable is actually a strategic advantage for us. That doesn't mean that every new service that we write is in Java, especially if startup time, memory use, or application size are priorities. But it means that while we do believe in the right tool for the job, we also know who we are and what our strengths are. And we look for good enough tooling that is complementary to our existing tech stack. So digressing a little bit here, but it also helps us avoid the pitfalls of resume-driven development. Considering a rewrite is actually a time when you can really see RDD come out in full force. Now, as the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. It often manifests as wanting to play around with the newest tech, even if that technology is completely incongruent with the rest of the project or company's tech stack. So if you're considering a rewrite and your eyes just light up at the possibility of doing something completely new with an unfamiliar but exciting technology, then that's a moment to just take a minute and ask yourself, do I really need a rewrite, or do I just want a playground for new toys? Or to keep the analogy going, a kitchen for new desserts. So by now, we've looked at the service in the context of the team and the team in the context of the organisation. And that brings us to looking at the service in the context of the entire application. The service is small and the scope is well defined, or it can be broken up in such a way that this is true. So earlier we considered whether there are opportunities to improve the current code base as it is. Here we are looking at the suitability of rewriting the application in deployable chunks. This is all about minimizing risk and not wasting resources building something that's never going to see the light of day. In our case, our rewrite candidate was already pretty well defined. It was a stateless service that had a very small, albeit important, role in the context of the entire application. However, we still ended up with 3 deployable chunks. It absolutely was not a 3-2-1 Big Bang cutover. So if the application you would like to rewrite or port is larger and more central to your system, then it's even more crucial to plan how you will break the rewrite candidate into smaller deployable chunks. So having a small and well-defined scope for the rewrite is crucial so you can start to see the benefits from your rewrite as soon as possible. Among other things, this just reduces the risk that of your program sponsors pulling the plug on the project too soon. So back in 2004, Martin Fowler was actually the first to coin the phrase strangler application. And as an Australian, I find this really, really cool, as Fowler was inspired for this metaphor during a trip to Australia where he encountered the strangler figs. And you can see it here on the right in this photo. So strangler figs are a parasitic plant that seed in the upper branches of a tree, eventually making their way down into the soil. And in this process, they envelop the host tree, essentially strangling it, after which the fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. Paul is an ex-thought worker, contributor to Selenium, and strong voice in trunk-based development and branch by abstraction. And before we do discuss the image, here is the QR code to Fowler's original article, which you can take a picture of while I take a sip of water. So Paul's blog also links to a couple of resources as well, including an excellent paper by Chris Stevenson and Andy Pulse. So the rabbit hole that you can go down from Fowler's article is actually well worth it. So back to this image here. So this shows a simplified evolution of a strangler fig web application. And while it is harder in practice than in theory, essentially you rewrite a small piece of the application and run it alongside the original app. Slowly over time, you rewrite more and more of the app until eventually all traffic gets routed to the new app. So taking this approach makes it possible to weave in and deliver new functionality as you go, which can help keep the stakeholders happy and build trust in the project. And as an extension of that, it can help you keep the rewrite projects alive. Who has worked on a rewrite that got started but never made it to production? Yeah, a few hands. So So how you go about carving out a piece of your application to rewrite will depend on a lot of factors, and it might be tricky to know exactly where to start. And this is where it can actually be really handy to use a concept from extreme programming called a spike. So essentially, a spike is an experiment to explore a possible solution to a new problem. And it's so called as a spike because it is end to end and very thin. Now, a spike can be functional or technical, but it's usually best to start with a functional spike. So identify a pain point for your users in the current application and then build a proof of concept to tackle that pain point. Now, ideally, you would get this pain point from your users directly, and it is like bonus a million points if you do. But it's also just a sound approach to nominate a member of your team to act as a customer proxy. So in our case, our first users were the researchers at the customer. Together, we decided that the first deployable chunk would actually be a number of APIs, so that it would be possible to interact with early versions of the item selection models. The final application would actually combine 3 internal steps into one endpoint, but by exposing the internals like this meant that the researchers could query the model directly, run simulations, and then verify that the model did what they expect it to do. And if it didn't, they could provide feedback. And so delivering this value early, even if it was not production ready, this was really, really important in building trust and keeping the project alive with full support of the stakeholders. Further, it provided us invaluable information on how to get our first chunk to production and what the scope of that chunk would be. So, finally then, when the question came up in my team of, do we dare to rewrite, despite our strong bias against not rewriting, when we considered these 4 reasons, the answer actually became pretty clear. And I am happy to report that not long ago we decommissioned the last instances running the old application, and we are 100% running the new application in production. Thank you. We did it. So I do think that that's a pretty cool milestone, and I would like to share a little bit more about how we approached the project and what we learnt along the way. So the first step was an audit of what the current model actually did. Along with many discussions with the customer, the audit included meeting with the researcher who wrote the original application, simply to learn more about what the app does and how it does it. And on the slide here is a brief version of the results of that audit. So the audit was actually really enlightening because we discovered how many features the application actually had, and interestingly, that we weren't even using all of them in production. So for example, there was a feature called content balancing, and what that means is that if you have questions or items from different topics in the same item bank, then you can make sure that an even number of questions from each topic or category are shown to the student. Basically, the model would determine what category needs to be shown next, and of these items, which is the best match for the student's ability. However, in production, there was currently a separate item bank for each category, so we actually didn't need the content balancing feature. Now, the customer did express a desire to use that functionality in the future, so we added it as a potential requirement for a later release, but we left it out of the planning for V1. And this phase of the project was actually quite interesting as we uncovered how powerful the original model really was, and actually how little of it we were utilising in production. Because had we uncovered all of these layers and learned that we were indeed using all of them in production, then this would have been a really good moment to go back and reconsider whether a rewrite was in fact the best idea. Because you remember point 3, right? The scope is small and well defined. that's not just something you think about up front. That's something you need to keep in your mind as you go. Because I do think that this is a huge trap for developers, especially if we've just joined a project, say less than 12 months ago. It's actually a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, ugh, why is this so complicated? If we could start over, simplify the data model, abstract over there, use some newer technologies while we're at it, wow, we could move faster and enjoy working this project much more in the process. But the truth about many production systems is they are the way that they are for a reason. You are not more insightful or knowledgeable than your predecessors. I know some of you might want to fight me on that, but sit with the thought. So sure, things do evolve over time, and decisions may be made in the past may be suboptimal given today's context, but often there is much more to architectural and design decisions than what is immediately apparent. So I would say that if you do decide to pursue a rewrite, treat the first phase as a discovery or feasibility phase. And this applies even if you are writing code already. Prepare yourself mentally to walk away, and if things do turn out bigger or more complex than you expected. So after the first few meetings, we had an overview of the features and the requirements for version 1. And it was decided that the new system as a whole would be a drop-in replacement for the old system. But in addition to that, the underlying statistical models would change. And this was for a couple of reasons, but the main one was to make the model extensible in the future. So, for example, the old model only used one item quality or parameter to estimate the student's ability, that being the item difficulty. However, under item response theory, there are at least two other parameters that can be used to get a more accurate or reflective estimation of the student's ability. And the other key reason for the change in models was, as I already mentioned, that there were other features that weren't being used at all. So the combination of unused features plus the desire for future extensibility led researchers at the customer to decide to rewrite the underlying statistical models as well. And that decision also impacted our approach to testing a little bit. In the end, it was the role of the researchers to validate their new model against the old service, and they just provided us with a list of inputs and expected outputs to add to our test suite. And overall, it was actually a really, really nice collaboration as we both analysed the existing application from different perspectives. So at Trifork, we looked through like inputs, outputs, exception handling, edge cases, whereas the researcher was actually really concerned with the mathematical mathematical methods and the psychometric validity of the model. And when we at Trifork were ready to start development of the application itself, we were provided a model from the researchers that was written in R and accompanied by mathematical notation. So this meant that the team members could work on understanding the model in a way that was the most natural for them. Personally, I preferred the mathematical notation. It's a lot more natural to me, and that helped me figure out the R code. However, for some of my colleagues, the opposite was true. And I really want to clarify here that when I say we were handed a model, really it happened in stages. It wasn't like the researchers sat in a room for 6 months and then said, here, put this in production. The researchers were actually fully aware that we planned to use Kotlin, and they did their own investigations of what libraries were available and discussed them with us. So, as for the reason as to why we chose Kotlin for this project to begin with, I hope that you already have a little idea as to why. So, as I mentioned earlier, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter, it's what we do. In my team in particular, we have a strong preference for Kotlin. Believe it or not, I actually learnt to program in Kotlin. So that's how fresh of a developer I am, I guess you could say. So, in my opinion, choosing Kotlin or Java within the context of a Spring Boot application is little more than a personal preference. Sure, your preference is wrong if you choose Java, but everyone's entitled to their own mistakes. Now, as for the downsides of Spring Boot, as for the choice of Spring Boot, the downsides of the framework, which are namely size, startup time, they were going to be a non-issue for us. This is a good enough choice in the context of our company and our team. So, having made the language choice of Kotlin, and together with the researchers, we actually looked at the numerical packages that we had available to us to see whether they would be a good fit for helping us to build the model. So JetBrains have been pushing Kotlin for data science a little bit, so we knew that there was plenty out there. So 2 options came up during our search, which were multi-K and Smile. Multi-K is a multi-dimensional array library, and Smile stands for Statistical Machine Intelligence and Learning Engine. So immediately Smile, just with that name, seemed overpowered for what we would be doing. However, multi-K was a solid candidate. So at Trifork, we went back and we did some small experiments. And what we found was that while multi-K would do a fine job, it didn't add anything extra for our use case. It made light work of calculations on multi-dimensional arrays, and we'd certainly be doing that. But after a bit more consultation with researchers, what we found out was that the arrays in the final model would actually just be 2-dimensional. And this is a very important distinction. 2-dimensional space is actually very straightforward. 3+ is where it starts to get tricky. Because another way to think of a 2-dimensional array is just as a list of multi-parameter objects. So let me show you an example. So here in Kotlin, we can simply define a data class of multiple primitive types. So this is a very trivial example using sales at a waffle store, just to keep the domain as simple as possible. The very first time I gave this talk, it was in Belgium, so it has to be waffles. And I was going to change the example for a local audience, but I decided that it's actually just fun to blame the Belgians for no particular reason. So if you don't like the example of waffles, blame the Belgians. So let's say you do have 2 kinds of waffles for sale at your waffle store, Stroop and Belgian. And each of them are for sale at a different price. And I know I just came for Belgium pretty hard, but that's my right as a Dutchie. To be fair, I have made the Belgian waffles more expensive in this example because they are more delicious. I know I'm a traitor to my adopted country. Please don't tell them they won't let me back in. So anyway, after you have the data for each of your products, you can define the weekend sales data of your waffle store as a list. And to upgrade this code a little bit, you could lean into the type system and define separate types for quantities sold on each day of the week, for example. And we use this pattern a lot. It means that you never confuse the sales of Saturday with the sales of Sunday during your calculation, as they are different types. The compiler will tell you right away if you try to use a Saturday value where you should use a Sunday value, vice versa. Now, here the distinction doesn't really matter because the waffles are the same price on both days. But this extra type safety, this saved our butts more than a few times. So to give you a little bit more of a concrete example, in our model, the item discrimination and the item difficulty, they're both doubles, and they're used side by side in the code base to determine what item is the best fit for the candidate at this point in the assessment. So by declaring them, though, as separate types, we could be confident that we were doing our calculations on the intended parameter and prevent erroneous results. You don't just swap 2 doubles, they're 2 different types. So filling out now the rest of our waffle example, you can calculate the daily sales of your waffle store by using this syntactically beautiful sum of function, and you end up with €105 of sales on Saturday and 94 on Sunday. Now, you might have a different preference, but for our team, using the features of the collections library on a list of type-safe objects was much more natural for us than manipulating two-dimensional arrays or matrices. And it actually turned out that we could do everything with the Kotlin standard library, and the researchers' model in R was written with that in mind. They still did use matrices or two-dimensional arrays in their models, but we could easily rewrite those as lists of multi-parameter objects. And so with respect to the calculations themselves, the researchers stuck to approaches that relied on basic scientific methods. In the end, there was nothing more scary than Euler's number E and the natural logarithm, and the Kotlin math package had us covered there. So just a quick example, and as a little refresher, I did promise in the abstract a little geek, so let's geek. Euler's number E is the base rate of growth shared by all continually growing processes. That gives it a central role in many domains, from investing to probability to radioactive decay. And just like pi, E is an irrational number with a set value. Irrational meaning that there is no limit to the number of decimal places it has, and there is no recurring pattern in its numerical value. So here I've got E written out to 150 places. I hope the first 3 look familiar, unless you're asleep in high school. The other cool thing that I want to mention, though, about E is that it's its own derivative. So the gradient of a function of E is the function of E. And this isn't just like pointless trivia either. It's actually a really important property that we exploited in our model. So if we go just a level deeper now, the value of E is the limit of the following expression here. So if you keep adding these fractions, as n approaches infinity, you get closer and closer to the true value of E. And the last tidbit before we move on, given the exponential properties of E, Euler used the letter E simply to refer to exponents. But by one of those cool coincidences, like how Thomas Crapper is known for his work on toilet-related patents, the letter is just now associated with his name, E for Euler. So in terms of working with E in code, in most worthwhile languages, yes, even though I'm a Java Kotlin developer, I would consider C# a worthwhile language. You do get a convenient function exp, which is e to the power of the past value. So here you've got x to the 3, e to the power of 3 is 20.08. And you also get the natural log function, which is the inverse of the growth function. So the natural log of e to power is approximately equal to 3. Now, these two functions, combined with other basic stuff like to the power of, absolute value, square root of, they ended up being the core of our model. So while the maths involved was far from straightforward, the researchers were able to come up with a valid solution using pretty straightforward mathematical expressions. And this meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I think is pretty cool. And it also validated our choice to pick the stack based on what was a good enough choice in the context of our team, rather than trying to find the best language packages for modeling item response theory. So I'm going to do a little bit of a hard pivot now, I suppose, but if you did read the abstract all the way through, then it shouldn't come as a surprise. So I do want to shift our focus now and use the last part of this talk to shamelessly throw in some pictures of a cute dog while I reflect on taking my first steps into a leadership role as a junior dev. So one of the things that I really like about working at Trifork Amsterdam is that we don't really have fixed titles or roles enforced. We like to focus on the individual, and if there's an opportunity that comes up that matches your skill set, have at it. So even though I only had a couple of years' experience working as a developer when the project came up, I ended up taking a bit of a leadership role in this project in some areas. And spoiler alert, it had mixed results. So in my study of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages like MATLAB and Mathematica. And I am by no means a mathematical wizard, but it is a solid enough background, and at the time it was the most maths experience in the team. Adding to that, I had been working on a customer project for about 2 years, so my domain knowledge was pretty solid as well. The planets had seemed to align. And having suffered mega imposter syndrome for the last 2 years, mostly fueled by my insecurities related to not having studied computer science, I jumped at the chance to show off these different skills that I had picked up along my unconventional path to becoming a developer. And I came to those first planning meetings with much enthusiasm and lots of questions. Oh, what model do you want us to use? Where do we get this number from? How do we go about solving for this parameter? Do you have any papers I can read? To be honest, I was probably quite insufferable. But just like an excitable puppy accidentally knocking over a pot plant with a stick that is much too large for her, I got a little bit of a free pass and most of my questions were answered. And even though I didn't understand everything all the way through, that didn't matter. I could get my head around the basics. We had a probability function, which we couldn't solve directly, but we could estimate it iteratively using the boundary closure approach. As I already mentioned, the customer was kind enough to provide a working example in R. Now, R is not a language that I know well, but given enough time and Googling, this is pre-ChatGPT, I could figure it out. I also had access to the service in C++ that we were replacing. Again, not a C++ developer, but by taking my time and annotating as I went, I could understand just enough to ask the right questions and get the right feedback and form a sound understanding of the domain. And it was pure joy for me figuring out how to turn mathematical formulas and R code into production-ready code. You know, the kind of joy you see in a dog when she starts to play with her favorite ball at the lake. And while we are a small team, so in the beginning, it was largely my task to put the proof of concept together. And that worked for a while, until it didn't. I was having so much fun that I just didn't include as many people as I should have as early as I should. Now, don't get me wrong, the project absolutely was a team effort, but the proof of concept of the core model was a pretty important chunk of the work, and I kept too much of that chunk to myself early on. I had documented some stuff, but what I hadn't documented was all the loose ends I still had in my head of exactly what needed to happen before we could go to production. And well, it was summer by now, so like a good European, I went on holiday. Now, I'm a firm believer that timing is everything in life. So you guessed it, while I was on holiday, external pressure started ramping up, pushing us to get the first deployable chunk into production as soon as possible. All those to-dos that were in my head were still in my head, and only in my head on a beach in Greece. And I came back to work, and it'd be a chaotic 2 weeks, apparently. The worst part was that some of the main issues the teams faced were non-issue to me. I felt awful. Sorry, guys. So yeah, that was a big lesson. Leadership is more than knowing what's going on and being available to answer questions. I don't like to assume that others don't know things. I know that my colleagues are smart as hell, and I don't want them to feel any other way. And I do think that this comes from my own feelings about my intelligence and my identity, that like if I'm not smart, then who am I? But that philosophy is ultimately unhelpful and it's unfair to others. If people get offended because you want to keep track of the details, that is on them. So definitely, if I had my time over, I would be proactive in keeping the lines of communication open within the team and set an example by documenting everything as I go. Even if it's just brain dumping in a ticket, as my Uncle Fred would say, it's better out than in. And one final note on this because I think it's important to hear, even if it's just from some rando on stage. Even though I did make mistakes during my first toe dip into leadership, I am happy that I did it. I learned a big lesson, and it's been invaluable as I organically take on more leadership responsibilities as I progress in my career. So I want to make sure that you hear that message. If an opportunity comes up to extend yourself just a little bit, go for it. What are some qualities or experiences that make you a good fit, even if you don't have any direct experience in this exact task? And who can you ask for support, either inside of your team or outside of it? So speaking from my own experience, imposter syndrome never goes away, but you do get better at shutting it up. And the way you get better is by proving to yourself that not only can you do hard things, but that you can dust yourself off and try again, even if things don't go to plan. So, to wrap things up, let's revisit the title of this talk. Are rewrites always a bad idea? Yella, what you think? Come on, don't be shy. Yes, well, I set you up here purely just based on the way I phrased this question, because it has to be no, right? Like, simply because there are no certainties in life, sweeping generalizations are always wrong, at least some of the time. So maybe the question that's better is, are rewrites generally a bad idea? And here I give a resounding yes. But they can be a good idea sometimes. So in this talk, I provided you with the top reasons to entertain the idea of a rewrite. Ideally, all of them would apply to your rewrite candidate, but personally, I would like to see reason 0 and at least 2 others. So, reason 0, so called because without this one, then all others are irrelevant. There is a desire to functionally change the application. If you're not touching the application in any way and it's running reliably and securely in production, why does it need to be rewritten? On to reason 1. There are no small steps to be found. You've determined the application does require some ongoing development, but the code base is in a state and there are no quick wins for your team to start improving it. The skills are not in the team and you do not wish to acquire them. In other words, improving the application requires a steep learning curve towards skills and knowledge that the company does not need or does not want. 3, the service is small and the scope is well defined, or it can be broken up in such a way that this is true. This means that you can deliver value and get buy-in early, and the potential downside is small. If despite the odds, you have determined that your application is indeed a good candidate for a rewrite, then you can take some small steps towards reaching that goal. So, start by conducting a thorough audit of what the current application does and what you will be rewriting. Keep it small and specific, with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so please be curious and not judgmental. Treat the audit as a feasibility study. If there is more scope or complexity than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you have already started writing code. So in our case, our project was more complex than we first thought, but a lot of this complexity was in unused features. The audit helped us make sense of this and to get to a bare bones version 0.9 implementation. When it comes to the tech stack, make a good enough choice in the context of your company and team. Rewriting an application comes with enough risk as it is. Adding a new or familiar technology into the mix is just adding another layer where things can go wrong. Add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point for your users. Put it in their hands. What do they think? Lastly, Don't be afraid to step up and do something scary. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time. If you'd like to ask me a question, I'm happy to chat always. Thank you.
Ooh. Hello, everyone. Good morning, and thank you for being up so early on Thursday. Not as early as me. Sorry, Pete. Missed your talk. So my name is Jessica. I am a senior principal architect at New Day, a company in the UK that does cards and credit. All very interesting, I'm sure. I won't be talking about that today, though. I am also an MVP, as are most people who are speaking here. It's not really a claim to fame anymore, is it? Everybody's an MVP, really. And I'm currently on the board of the .NET Foundation. My term ends at the end of the month, and if you're interested in anything to do with the .NET Foundation, come speak to me. I will be around the conference for the next 2 days, and happy to have a chat about that. So today, we're going to talk about stabilizing eccentric systems. In my career, I've worked with a variety of different systems in a variety of different companies. Big, small, startup, up to government, to Experian. I've worked in various sizes. There's one thing that a lot of these systems have had in common, which is they're normally the systems that nobody else wants to touch. So I get hired to come in, understand them, understand the teams that are working on them, and see if we can help stabilize and make them into systems that people actually enjoy working on and know the purpose of. So today I want to talk through some of the things I've learned doing this work, and give you some of the secret sauce, the secret tips into what I find helps with these kind of projects. The little trick here is this isn't a very technical talk, so surprise, you've actually come to a talk that's a lot about people and about communication, so sorry about that. There is a little bit of tech splattered throughout, but if you're not a devy engineer who's got like 15 years experience, don't worry, none of my slides are going to scare you. So there's 5 things we're going to talk through. We're going to talk through understanding, measurement, prioritization, communication, and making mistakes. These things can be done in order, or they can be done at the same time. We'll talk through some examples as we go through it. But first of all, understanding. So I like to use this term pre-loved, and I'll explain why. So we talk a lot about legacy systems. And legacy, like the root of the word originally was you left a legacy. It was something good. It was something that you were proud of. But it's turned into this dirty word in tech. Nobody wants to own a legacy. It's always the system that's been left in the cupboard that nobody wants to talk about. It's always a system that is probably a bit old, written in a language nobody likes. So instead, I like to use the term pre-loved, because at some point, there was a team of people, or maybe a couple of people, who worked on this system. They got asked to solve a problem, and they did the best they could, given time constraints, given the technology that they had at the time. Like, there's reasons that the system is the way it is. So for a degree of empathy, I like to use the word pre-loved, because somebody loved it once, and maybe we can help the teams love it again. And language is very important. So, as I say, I've changed my terminology, and my teams luckily have kind of picked it up. But language is incredibly important, not only for understanding the systems itself, but also for understanding each other. An arbitrary example of this, pants. So in the UK, pants is underwear. In the US, pants is trousers. So the term no pants, no service suddenly takes a whole different meaning, and you wonder what they're checking. Now, this is a very simple example in English, and let's face it, English is not the easiest language. We make it as hard as possible. But then you have technology, where we have our special little words, our jargon, and anything that has 2 Ds is good, right? DDD, TDD, BDD. So we've got all these acronyms as well. And these letters mean something to our developers, but sometimes they mean completely different things for the same 3 letters. And that's not even counting in when you're talking to a product person or someone's working in finance. Like, what are we even talking about? The one that comes up a lot in the teams I work in, integration test. Oh, whenever somebody asks me about an integration test, my soul escapes my body. I'm like, what are we talking about? So I'm sure you've all got similar experiences where we need a shared language. And that's the case for these systems as well. And kind of going on to this, the first big step that I would take is understanding the domains. Now, you're all at NDC, so I imagine that you have an understanding of the word domain. I now wonder if you turn to a person next to you if they had exactly the same definition. So what I like to do is talk about the product instead. Because you're not always going to be talking to people who are technical. You're not always going to be talking to someone who has the same understanding as domain as you. And this has happened in my most recent piece of work. Oh, domain, it's another one of those words. It's causing so much confusion. So instead, we talk about product. And the reason for this is not just so we understand what we're talking about, but at the end of the day, all the work that we do comes back to supporting a product. It means that we can talk to the many different departments within the company, have that shared understanding, but also the developers, the engineers, your infrastructure engineers, anyone who's working on these systems understands what they're working towards and why. It should always come back to product. Now, a mistake that I have made in the past, and I'm human, I'll probably do it again, is when I've been given a number of components, services, APIs, databases, and gone, what does this do? Oh, thanks, great. That's a great ask. I tend to take this the wrong direction. So for an analogy, a jigsaw puzzle. You've picked up a jigsaw puzzle from a charity shop, or you've got it secondhand, maybe a boot fair, and you start to put this jigsaw puzzle together. Now, you don't know if all the pieces are the part of the same jigsaw puzzle. You might have several different ones in this box. You don't know if there's pieces that are missing. You could take a piece and kind of jam it in and hope for the best, but you don't really know how this is all supposed to fit together. I've done this with systems before. I've looked straight into the code and gone, right, so this bit kind of looked like it goes here, and maybe, oh, but that's deployed over. No, it takes far too long. What you need to do is have the picture of the puzzle. The picture that's normally on the front of the box, if we're going for this analogy. But what does that mean in terms of understanding our systems and our product? How do we get this picture? I'm sorry, you've got to talk to people. I don't like it either. It's fine. So we talk to our users and stakeholders, and these come in many forms. You have your product owner, product manager. This is hopefully you've got someone who's worked on these systems before, has some pre-existing knowledge. You might not be that lucky. I've certainly had that case. If you can, talk to the users. Watch your users, see how they're using the system. You have your stakeholders. And I'll go through some of the things that these people will be interested in, but your stakeholders are going to have business interests in particular in your product. And again, if possible, your contact points. So sales and call center. It might be a product that you're selling to other people. And in that case, you want to know what's being sold because you want to know that this system can support what's being sold. As I imagine most of us have had some interesting experiences with sales, selling something that we don't even support. And then you have your call center who'll have an idea of what are the common complaints, how this thing's being interacted with. It might even be a product that your call center's using. Again, I've had a past experience of working on a system that a call center has used, and the amount of things that I thought were bugs that were actually features for them, whoops. I learned that the hard way and just listened to the screams from the floor above as they did a release. So you'll be talking to them about key performance indicators. So what is it that they see as their successful metrics? So what are they looking at? Is it cost? Is it the amount of people who can use the system at once? There's a number of metrics for this. It's not a talk on KPIs, so I won't go into too much depth. How is the system being used? As I say, you might be surprised. And common issues that might come up. So there are some handy techniques. I'm not going to go into very much depth because these are entire talks by themselves, but I will share some resources at the end for if you want to learn some more information. So event storming and capability mapping are the two kind of DDD special words I'm going to say this time around. And the reason I use them, so capability mapping is to help identify those domains, those product areas, the bounded context, the business capabilities, so what this product is doing, and that will help you with your language. And event storming is understanding the connections and flows that happen both in the system, online and offline. There will be, well, there's likely to be some manual elements that you wouldn't necessarily see when you're putting that jigsaw puzzle together of all the different technical components. So the hidden pieces. So this brings me to measurement. Sorry, I'm pausing because I'm quite nervous and I'm trying not to speak like I'm a chipmunk. So your measurement, the most important thing is how do you know it's working? There's 5 things I'm going to talk through here. Again, from experience, I've done this both, sadly, as an individual contributor, sitting by myself at a desk, and sometimes with a team, which is even better. So first of all, I want to talk through documentation. Oh, if you're really lucky, there'll be some good documentation, but I would put money on the fact that this is probably going to be one of the worst suffering areas. Whether your company uses GitHub, Confluence, or something else, whether it has hidden Google Docs around where you have to find somebody who left the company 5 years ago and how to access their account. Oh, I see some nods. I'm glad I'm not the only one. This is one of the most painful of the 5 points. I'm not going to lie to you. But if you can find runbooks, readmes, project notes, release notes, hidden notes in someone's desk where they're cursing the system with some sort of witchy hex, don't blame them. We're trying to get as much information as you can. The big warning sign with documentation, pretty much guarantee it's going to be out of date, it's going to be hard to understand, it's going to have missing information. So good luck if you just do this step. I wouldn't suggest it. You have your tests. Do they run? Hopefully. Do they run consistently? Maybe. And what's the quality of them? Now, this isn't a testing talk. I'm not going to get contentious with you here and tell you how to judge the quality of your tests. But if you're lucky, your tests will also help with the documentation part. You'll be able to read the tests and go, OK, so this thing does this thing. It aligns to documentation. I'm a big fan of a given one then. I'm sorry. But yeah, so you want to have a little look through to see if assert is equaling true, or if it's just doing nothing and they've done something to make those little ticks turn green. Done it myself. You want to have a look at the type of test. Oh, sorry, my husband's shaking his head at me. I'm being shamed from the front row during my talk. I should be ashamed. So there's also the type of test. So is it just unit tests? Do they have integration tests? Do they have tests which are checking the integration boundaries? Do they have smoke tests? Are they automated or are they manual? Again, it's going to link into your documentation if you're lucky. If you're unlucky, it's going to be somebody that you're going to have to hunt down in an office somewhere to go, what are you doing? Can I watch? And see how they're testing something. So are they automated? Are they manual? If they are manual, do they need to be documented so they can be automated? And then the processes. So when are they run? Are they run against pull requests? Are they run against deployments? Are they run whenever somebody feels like it? Are they run at all? Let's quickly skip past that question. Ooh. And my clicker just decided to stop working. Sorry about that. So I'm going to skip to pipelines and processes, because it's slightly linked to what we just talked about. So again, pipelines and processes, do they run? When were they last run? I've done this talk once before, and I got asked about the worst case scenario. I have worked on a system where the deployment pipeline hadn't been run for 4 years. So the team was so nervous about the fact that if they had deployed this, it was going to break, and they didn't know the consequences. They'd been pushing changes but they just never deployed them. It's kind of beautiful. And they got away with this for 4 years. So what we did is we had a look at the deployment pipeline. We went, yep, let's give this a go, and everything broke. Luckily, we had kind of figured out how to roll it back nicely. Not all that nicely. Did take a bit longer than expected. But yeah, there are scenarios where they might not have been run in a while. 4 years is my worst case. I have also seen 2 years with the same scenario, so this is more common than you think it is. If you don't think it's happening in your company, maybe double check. What's covered in a CI pipeline? So what tooling is used? Are your tests being run? Do you have a linter? Is the security testing, etc.? Is the deployment fully automated? Kind of like a little side note to this, not only is it fully automated, but is it in like a coherent one language script or one tool? Again, not uncommon to kind of see this Frankenstein deployment pipeline, which can cause teams a lot of pain. But yes, I've worked in technology long enough that I've had to do manual deployments as well. And again, when and how are the pipelines run? So are they run against a PR? Are they only run against deployments? If they're only run for a production deployment, I wish you luck. But yeah, these are kind of the things that I would look at. Observability. I have done talks on observability. I am very passionate about the topic, but this is not an observability talk, so I'll try and stay in my box. Observability, the main 3 things I'd look at are logs, alerts, and metrics. Logs, the level of your alerts, the level of your logs. So again, semi-recently, I had a team that was putting all of its trace information into the production environment. It was very costly. It wasn't very useful to use because the amount of noise that was happening. So when they had to go and investigate something, they had to read through a lot of logs to find out what was actually useful to them. Also kind of the quality of logs, so whether they're structured or not. One of the first systems I worked on, they logged every single time something entered a method and exited a method. Again, that's a lot of logs. So just light little touches like that. Alerting. Alerts are incredibly important, especially when it comes to noise. So if you're in a hospital, for example, you'll hear lots of different types of beeps. The reason is that those beeps mean a very specific thing to the nurses. One of them is this person's about to die. The other one is they've just got really handy on the buzzer and they're going to annoy you for the next hour, so you might want to silence it. It's the same with our tech systems. You want to make sure that the alerts are somewhere that they can be seen and have being paid attention to, but you also don't want alerts going off every 3 seconds because that channel is going to be muted. So have a look at how much noise is being produced from your alerts and whether there might be missing ones as well. Metrics, I do metrics, but how are they used is very important in this. Vanity metrics are a thing, which are metrics which aren't useful. They're just somebody wanted them, so they got put in. A metric that you need is something like, there's a lot of resources around RED for APIs. So your rate, your error, and your duration gives you an idea of your API health. Those are really useful metrics. Again, noise. If you have a lot of dashboards and a lot of metrics, how do you know what's useful to you? And this one I'm going to go into a little bit more depth, which is recent incidents. Now, as I mentioned, my lovely pre-love systems were loved ones. But they've probably been neglected for a while, so they're probably complaining on a regular basis. And as such, you will have a lot of incidents that happen. So there's 3 kind of main slides to this. First of all, I look at the current process for incident response, meet the teams that are involved, understand how they're engaged with engineering. So you might have a separate incident management team, or incident management might be dealt with your engineering teams. Different companies, different formats. But understand how engineering are engaged with those teams. Understand the end-to-end process of incident management, so from when a thing happens to when it gets noticed, right the way through to being resolved. With this, if you're lucky, there'll be some measurements. So if you are very lucky, there'll be the mean time to detect from a thing happening in your system, how long does it take for someone to notice? There'll be a time to respond. So if somebody has noticed the thing has happened, how long does it take for them to do something about it? And the time to resolve, how long does it take to fix the thing and stop it from happening again? Who has visibility of the incidents? So again, it might be an incident team, which means your engineering team has no idea that your system's collapsing every few seconds. It's just causing someone else some pain. And how are the measurements used? So are they tracked? Do you have some company objectives around making sure that your time to resolve these incidents is shorter than it is? Is there somebody in C-suite who's actually really angry about the amount of time that your system is going down and nobody's doing anything about it? But nobody knows because they don't know that they're supposed to be measuring this. And then there's some things that often occur in incidents, so post-mortems, root cause analysis, and preventative actions. Post-mortems, in terms of my definition, is your log of what's happened and when. It's normally a paper document, a Google Doc or Word doc, which has a log of the main events that's happened during the incident. This can be used for a root cause analysis. What it says on the tin, you're trying to determine what was the root cause that made this event happen. There's lots of exercise around this. 5 whys, fishbone, again, there's lots of more in-depth talks about this. Happy to share resources afterwards. But you need to get down into what caused this and what actions can be taken to stop it from happening again, or even to shorten that resolution time. Which brings me to preventative actions. Are they recorded? Are they planned and tracked? Are they prioritized? Are they recorded? Yeah, quite possibly. Are they planned? Maybe. Are they prioritized? Never, really. Let's be honest. It doesn't really happen. But they should be, and we know why, or we will do by the end of this talk, if I do my job properly. This slide, the next bit, it used to have a less talk-friendly title, which is how I refer to it at work, which is, I make them create the poop list. I don't always use that language. So what I like to do is get the teams that have worked with these systems, and I'm not just talking about developers, it might be the people who support the infrastructure, etc. Anyone who's had interaction with the systems that you're dealing with, get them either onto a room or online with a bunch of Post-its and go, tell me what you really like about system and tell me what you really hate or that you really want to be working on, like where is this system causing you pain? Should be a safe environment, people can put what they want. It's fun to make a bit of a joke of it, but this is where you get some really valuable information for planning the work to deal with these systems. And once they've done all these Post-its, this is my secret piece of work, is I like to put them into certain categories. Now, I will go into more depth why these particular categories, but I'll get those Post-its, I'll sit by myself and put them into security and compliance, commercial and feature, maturity and debt, the architectural pillars, because I am an architect and I have to think about them occasionally, business KPIs, housekeeping, and other. I will go through what these mean in a moment. So for an example, I've got a notifications product. After talking to my stakeholders and my product owner, I kind of know what this product's doing. And I've had my team in a room, and they've said, oh, there's personal data in logs, and there's an out-of-date framework. I'll pop that into security. We would like some new features that aren't supported yet. Yep. Maturity and debt, our tests are a bit slow. They're a bit flaky. And one of your engineers wants to rename a widely used library because sometimes that happens. Go through the architectural pillars. I won't teach my grand to suck eggs here, you probably already know, but your cost, your reliability, your resilience, etc. Is the business KPIs, so cost effectiveness is one that we have identified in this particular exercise. And then housekeeping, so this is often related to how they're managing their Scrum ceremonies or how they're organizing themselves. So in this case, they've noticed that they get blocked when they're going into test and estimates aren't really working for the team. And my other is somebody saying that They don't really get to socialize with their teammates. And so it's not necessarily to do with the tech, always. Sometimes it's to do with the team itself and how they're working. All of this will help us with prioritization, I promise. So with these items of work, you'll want to do a value analysis. The three things that I look at are urgency, impact, and effort. So is there a committed deadline? Can we negotiate that deadline? Is it impacts in terms of risk, legislation? So is there some sort of law or governance or compliance reason why you might have impact for not doing this work? The user experience and the business requirements. You'll see there's a lot of threads that have repeated themselves throughout this. And then effort, so how complex is the work and how many dependencies are there to manage? The third one is one that I see gets missed a lot in these conversations. But again, I'll go into why it's important. Some of you may have seen something like this before, but these then get used to put into a do, a plan, a backlog, and eliminate. So do is something that's going to happen in the next couple of sprints, plan next couple of quarters, backlog eventually, and eliminate, you don't really need to do it. And in terms of this, you're looking at your value analysis, so high impact, high urgency, and high impact, low effort. If somebody's really yelling about it and it needs to be done yesterday or it doesn't take much to do, just do it. If it's high impact, but you can negotiate that urgency, you can plan it in. And then everything else goes into the backlog, apart from anything that's low impact, not urgent, or high effort. Which brings me back to, oh, nope, I have got ahead of myself. It will bring me back to my example. So going back to those categories I was talking about earlier, and how they relate to these values. Security and compliance, they're normally high urgency, they've normally got a deadline associated with them. You normally have an idea of the impact, so whether that's a penalty because you aren't PCI compliant and you're about to get caught out. And the effort can be variable. Commercial, normally you can negotiate the urgency, it depends how much your product owner likes you. The impact can be variable, so can the effort. Maturity and debt, most of this is variable, but the urgency tends to be quite a bit lower. But as I say, I won't talk through all of these because you'll be bored out of your minds, but each of these areas has an associated impact and value, which is why I like to group those post-it notes to make my life a little bit easier. The housekeeping and other tends not to be planned work, but it's normally something that you want to pick up with the teams relatively urgently to make sure that they're happy. And this is where my example came in. So I've taken those post-it notes. They've been in those categories, so I've got a relatively good idea of what their value analysis is. I've put them into my quadrants. And in this case, the wanted to rename a widely consumed library. Oh, that's much too high effort. It's going to cause everybody pain. And this team already has some issues with the company not really trusting them or liking them, so let's not make some enemies where we don't need to. And I've also added in my post-its from my previous analysis. So I've looked through that documentation and the tests and the incident management. So there's been some work identified from those exercises as well. And I've talked through with the team and product on what this means compared to everything else that we've already discussed. So they have an idea on why it's being prioritized in that way. Now, this work can be considered as two separate categories. There is reactive, expecting the unexpected, and proactive, planning ahead. Now, catchy titles aside, the reason why I want to talk to you about this is because if you've got an unstable, not well understood system, your reactive work is likely going to be very high. You're going to have a lot of incidents coming through. You're going to have teams going, "You are blocking us, rah. We were supposed to tell you this 3 weeks ago, but we've just decided to land it on you now." And not very much proactive work. So your poor product owner will be trying to plan in the work, and it just gets blown out the water by all of this very urgent stuff that's coming in. Now, as you go through this, the items of work that I've talked about, what should happen is your reactive work should get lower. So as you have prioritized those actions from that incident response work, actually prioritize them, oh, exciting, that reactive work should come down because your incidents should go down, which means you can plan more, which means you have a solid velocity, which means the business is happy. Yay! And you can measure this through whatever tool that you're using to plan your work with, most likely Jira. You can actually show these percentages changing and your team becoming more stable, which is a great thing to communicate. See what I did there? So communication, step number 4. Consider your audience. So you'll have your stakeholders, both internal and external. Impacted teams, so these are people who are doing the work or are impacted directly by the work. Dependencies, the teams that may have to plan in some work to help you out. Senior leadership, so C-suite and Exco, they will be very happy that you suddenly understand the product that you're working with. And the peers, so these are teams that aren't directly impacted by your work, but can learn from it, might be interested in it. Hey, you might be able to poach a couple of them across into the dark side to work on the interesting system, who knows. But it's good to share knowledge. And it's important to consider what they care about, especially in terms of communication. So your stakeholders care about the measures of progress and success. Can that team now reliably work on things? Are they actually going to get features through? Are you not going to get complaints about outages all the time? Impacted teams want to know about what the work is and the impact and the progress of it. Hopefully you've been using that shared language, so you're all talking about the impact on the product. If you're not, that's fine, but hopefully you are. Dependencies will want to know how it impacts them and how they can plan the work. Senior leadership want to know, as I said, about the progress, success, and delivery impacts. So not only of your team, but also anything else that's affected. And the peers want to know about what they can use. Have you got a tasty little shared library? Have you learned something that can help them and save them time going forward? And with this, it's very, very important to show your workings. So show not only the results, but how you got there. You want to talk about what work was planned, why you prioritized this work, how you're going to achieve the plans, when do you expect to see a measurable impact, and this is all going back to our metrics and everything else we've previously talked about. How can people get updates of the work? Different people will consume information in different ways. So it might be that you have a weekly meeting to update people. It might be that you also have a newsletter that goes out once a month. Because these stakeholders, because these audiences need different levels of information, probably best not to have a 100-person meeting with everybody sitting on there that only need to have like 10 minutes worth of it. It's expensive, people won't be engaged. So make sure that the way that they can get updates about the work fits them and suits them. And plan B, if it doesn't go as expected, maybe plan C and D as well. We'll get into that in a little bit more. And now, prioritizing when everything urgent is really difficult. But you now know the impacts of your work, you know like how to prioritize this with a product, you know how to support the product and why you have to deal with making sure this incident never happens again, opposed to doing this feature that might bring the company some money, going back to those KPIs. I am not taking away from the fact that this is a really difficult conversation to have. It's not fun. I don't enjoy doing it. But the most important thing is to know when to let items burn. Not out of badness, a little bit out of badness. So what I mean by this is you now have enough information, not to go, no, we're not doing that, but we can't do that right now because we have these other items of work that we are doing, and the reason that these items of work are more important is because this is the impact of them compared to what you're doing. So as long as you're explaining to people why their really, really important thing that they really want to do isn't being done, and that it will be done eventually, but this is the reason why not now. That's an easier conversation to have than no. I'm about to say, my boss isn't in the audience. No, he won't watch the recording, it's fine. So the other trick with this is sometimes you will get a lot of pushback on, but I really need this, but I really need this. Or maybe your team really cares about an item of work because it causes them a lot of pain, but it's not visible to your external users. What if that item of work just doesn't happen? So that pain then affects those users, those stakeholders, and suddenly the stakeholders really care about it. Now, I'm not advocating for always letting situations get worse. I'm definitely not advocating for that. But sometimes there are situations where if you let a little simmer turn into a visible fire, it'll help you get that work prioritized as it needs to be. Sorry, David Whitney. And I've said this, but keeping it visible is keeping it safe. So as long as you're visible about the work that you're doing, why you're doing it, what the state of your system is, where your successes are, you are keeping your project and your team safe. Now, a lot of these systems that I've worked with, there is lost trust in the teams that are supporting these systems. Because externally, people don't have the information to know why it keeps breaking or why this system is so unloved. And then they lose trust in the engineers because often there's a message going, oh yeah, we'll have that product out by next week. But then 50 incidents have come in. They can't do that. And all of a sudden, all the stakeholders are seeing is that they're not getting what they asked for. Nothing more than that. So often there's a loss of trust. In order to build up that trust, you need to show your workings. You need to show why you're tackling a piece of work. But also, you can be relatively vulnerable and show the impacts of the situation the team's in and how it's affecting them. So being visible about this work is keeping it safe and will help you going forward. Which brings me to making mistakes. I can't guarantee a 100% reliable system. I can't guarantee that I am going to make the company lots and lots of money. I can guarantee mistakes are going to be made. Probably not the message they want to hear, but they are going to happen. And very importantly, you can't fix the world with this. So I've gone through a lot of content very quickly. And the feeling that I see a lot from my lead engineers, and I often have myself, is I see all of the problems, and it's a lot, right? Like, you know that you need to fix the alerting, the logging, the metrics, that the system keeps falling apart every time you deploy it. You have to do all these pipelines. Like, this is a lot of work we're talking about. And sometimes it feels like too much. So it's important to acknowledge that you can't fix everything at once, and being able to scope down what you can control in what time frame will help you a lot. It will help your teams a lot. It's a conversation I have very frequently with the teams that I work with, getting them to rescope back down to what they can control and acknowledge when they've had a success with it. And this is what I mean by you can help others as well as yourself. So there's a really beautiful book called Endings. It's not really a technical book, but it's a short read. It's very nice. And it goes through how human nature, we don't really look at, we always look at what's coming next. It's always a treadmill. So we don't take the time to stop and go, what can we learn from this? What have we achieved from this? Instead, it's, okay, so we've achieved that epic. What's the next one? We've fixed the alerts. What's the next bit? We've made our things. We've saved a bunch of money. What can we do now? The problem is with that is everybody gets burnt out. You're always in the depth of the fire. You're feeling the heat of it. You feel the problems that are around you, but you don't actually get to say, hang on, we actually have saved this amount of money, or we actually got, like, Pete could take a holiday this week, and it was okay because he's not the only person who knows how to manually deploy the pipeline and do the tests. And, you know, he's not insisting that everybody has to go through him for PR before it can go to live. Sorry, Pete. You know it's true. But, you know, you can help others as well as yourself by taking, acknowledging those successes, those challenges, those learnings, and chunking this work into endings. This is what I meant at the beginning of my talk, where this is not a technical talk. Yes, it involves a lot of technical work. You have to have a good knowledge about testing or have people around you who do. You have to be able to talk to other people in a way that they understand. you have to be able to have the patience to go through all that documentation and realize when it's good and when it's bad. All of these are skills. Some of them are very technical. But this talk isn't a technical talk, because all of these elements that I've talked through today are actually the magic to building trust with the teams and with the company, which is the way that you'll then get support to do the work that you want to do going forward. It's how you build up a level of trust and respect in your role, which, by the way, is one of the hardest bits of being an architect. Nobody warned me about that. But yeah, as part of my role, I have to go into teams. Often I'm working with a number of teams at once. I mean, there are a number of reasons why if I went into a team, they'd go, why should we listen to her? And you build this trust with small experiments. It's a case of, look, I understand your pain. I've gone through this. This is my understanding of it all now. Let's just try this one thing. If it doesn't work, cool. We'll try something else. I want to hear your feedback on what's going on, but let's just try it. And as you do these small incremental experiments, you'll build that trust, because they'll see that it's not just some random lady who stands on a stage occasionally with her Comic Sans slides. There is a reason for that as well. And whitters on to people. But actually, there is some logic behind this. And then they can start proposing what the next small experiment is, and you can work together to build that trust. These small experiments you're going to be sharing with the rest of the company, so they understand why you're doing things, why it's important, and why they should care, which is that visibility part we talked about earlier. The measurable results, so all of that research that you did at the very beginning, you should be able to kind of get a view on what you can measure. Is it the velocity and the predictability of your team's delivery? Is it the amount of outages that you're having? Is it the uptime? There's a number of numbers that you can use here to demonstrate in a way that your different audiences can understand why you're doing this work, what comes out of it. Your work will become more predictable as you have less of those incidents coming through, less of the big reactive pieces of work, which makes everybody happy. It means that we can have our holidays and not worry too much. And improved experience. So going back to the very, very beginning. Sorry. This is why we're talking about product instead of domains. Because throughout all of this work, if you're talking about not the technology, not your API, not your system, but the product that they're impacting, not only will everybody understand why you're doing this work and what it's impacting, but also that improved experience comes in. So I am not an agile coach. I am not your lawyer. But user stories. I probably shouldn't talk about my current company, but I did have a team that I had as a CEO, I want this system to work so that the team's less stressed. Not really a user story. If we're talking about our product, suddenly that language is much easier to form with the team and create with each other. So you're talking about as a client person who is pressing this button, I need this thing to happen so that my credit details aren't spread across the internet. There's lots of different reasons, but being able to have that shared experience, shared language, being able to talk about the product consistently, being able to have those measurements at hand will improve not only experience for your users, but for your team, for your stakeholders. And it helps get that team that is not the favorite of the company to be one of the ones that everybody's looking at. Because, yeah, somebody over there might have a really fancy, stable product, but look at the progression that your team's made in comparison. If you can't tell, I really, really love these kind of projects. I don't know if that's a glutton for punishment, but yeah, I think they're great because not only is it working with very difficult technical systems, but I think the biggest part in technology, the most difficult part, most challenging part, is people. And often this is dealing with the people around the product as well. I did say I'd go through recommended resources. Ian Cooper is also wandering around the conference in the next few days. Lots of piercings, beardy, tattoos. Hard to miss. There is only one Ian Cooper. But he does some really fantastic talks. I know he's famous for his test-driven development talk. If you haven't seen it, please do. It's really good. But he also has talks around capability mapping and event-driven collaboration, which will go into more depth about the capability mapping and event storming that I discussed earlier in a much more eloquent way than I could at the moment. The domain-driven design book, controversially, I like this book more than the big blue one. The big blue one I find is quite challenging to get through because it's very, very big, and I find it a bit intimidating. But that red one has most of the content you'll need, and it's very easy to consume. Probably a bit strange, the next two, but site reliability and DevOps. This will come in very, very handy for those initial slides where you're investigating into your system and how it's working and where the problems are. So the Site Reliability Engineering book has some fantastic chapters around incident management and has some resources that your company can use. Also has a couple of chapters around the metrics that may be important for your system, how to use them, what they mean, and what metrics to avoid, which, I owe many favors to the person who wrote that book. They saved me a lot of time and pain. And DevOps for Dummies. I know that you might not all be working in a DevOps environment. If we're being honest, most of us aren't. But being able to understand that different relationship between infrastructure and engineering, software engineering, for example, is quite important. But there's a lot of patterns in there that will help you with stabilizing the systems. So you don't need to be have a really solid knowledge on infrastructure to get benefit from that book. It also has a lot of really nerdy jokes relating to Lord of the Rings, and it's kind of a joy to read. So even if you don't think you'll benefit from it, it's a great book. I have run rather fast, as I say. Was a bit nervous. But I'd like to say thank you for coming to the talk, and I will happily take any questions for the next 10 minutes if you have them. Thank you kindly for your time. Oh, one thing, the Comic Sans thing. So I didn't do it just to trigger you all, though that was a bit tempting. No, so Comic Sans is the most dyslexic-friendly font, I found out the other day there, which is why I used it. So Calibri and Comic Sans are the two main fonts that I use throughout these slides, and that's for anyone who might need it. But also it's fun because everybody hates Comic Sans, so I'm not sorry. So thank you very much. Any questions? Oh, yeah.
For the books you showed, it's more technical, but I'm more interested in your mental model. Because for me, if I summarize your presentation, it's more than a process.
Yeah.
So can you tell me how did you reach this or experience to build?
Cool. So is it these groups or the groups of people? Oh, the end-to-end process.
I mean, the best way is when you put the sticky notes, there is a slide with sticky notes.
Ah, yes. Oh dear, I can't navigate my own slides. Sorry about this. These ones, yeah. And correct me if I'm wrong, is how these groupings are achieved and why these groupings, how I got there. Yeah? So this is a bit of an arbitrary example, but I will go through each of these sticky notes for you. So the high impact, high urgency, the personal data and logs, and out-of-date framework, those are relating to security asks. So personal data in logs is a big GDPR no-no. Very relevant in the UK at the minute. And the out-of-date framework, there's often policies and SLAs around not having out-of-support frameworks. So because they're security items, they will have an impact, so a penalty relating to them, that'll be quite clear. And often I find that the high urgency, there will be set SLAs, so service level agreements, expected dates. And again, those will be easy to get hold of. For the noisy alerts and some incident prevention item, you can tell where I got lazy with my notes. So again, I've put high impact, low effort because it's not a lot of effort to get rid of alerts often, unless you've done something really funky. And normally there are some small items with incident management where you can do some improvements. So it might even be putting in an alert for when something goes wrong so you get that lower response time. For planning, tests are slow and flaky. So again, the urgency is negotiable. It's not overly urgent, but hopefully the effort isn't too high. Again, depends on the quality of tests. But it does have quite a high impact on the team. So this will give you an idea of how reliable it is to make that change, like how safe your change is. Log levels, again, high impact because it's going to decrease the amount of logs in production, for example, if you are logging everything. Not only in terms of being able to investigate incidents, but also sometimes in terms of cost. Sorry, Splunk, but very, very expensive if you're logging a lot. Pipeline improvements, again, well, high impact is quite obvious there. But nobody's going to be yelling apart from the teams, and the effort, hopefully, isn't too high, but sometimes it's a nightmare. And then you've probably got some other incident actions. For the backlog, so resilience and reliability issues, whenever it comes to the architectural pillars, it's not normally something that's you can plan overnight. So it's normally something that takes a bit of discovery, a little bit more effort into looking into. So you normally need to do some planning there. It will have quite high impact in terms of key performance indicators for the business. So often it's going to be relating to uptime and cost, etc. So there will be high impact. It will require some planning. But again, there's probably not some service level agreement or deadline that's associated. And that's the cost effectiveness as well. Incident process improvements. Changing processes is hard. I wish it wasn't. But yeah, changing processes always takes a bit of planning. But again, high impact. And batch not real time. That's actually an example from a past piece of work. So we needed to get alerts out to customers as soon as they were happening. So often fraud alerts was the case of this. But they were being done on a 48-hour batch. So it was 2 days before somebody realized there's fraudulent activity against their account. Not ideal. So it did have a high impact to the user, but it is going to take a bit of planning to sort that out because it's going to be a big system change. And then reaching monthly max notifications, that's another example from work. Blocked in test. Blocked in test is not a technical one, really. It's more of a process situation. So again, this often happens if you've got a throw it over the fence culture. So it might be that you're waiting for Pete to come back on holiday before he can test everything. So it might not be a technical fix, it might be a people change. So you're getting people to pair with a tester, or you're making the engineers more responsible for their testing, etc. So it might not be high impact to the company, it will be to the team, but no one's really going to be chasing you about the urgency of it because it's been like that for a long time, and the effort shouldn't be low. Well, depends on your team. Estimates not working, same situation, so that's very much for the team. And run books, I've put as not high impact, not urgent, low effort. Sometimes the effort for getting run books up to scratch is it's a bit higher effort than I want to admit, but we'll go with that. I made it up as I went along, if I'm being honest. But the eliminate, again, is actually an example I had from my work. And I don't blame the person at all, because he wanted to rename the library because it had a spelling mistake in it. And every time he saw it consumed everywhere else, it was driving him nuts. So I don't blame him, but it's going to impact a lot of teams. It's a big piece of work. Nobody really wants that to happen, so we just didn't do it. He got over it eventually, it was fine. Any other questions? Yeah.
The same slide. General question, not regarding the post-it notes. Wouldn't you drop not high impact and not urgent?
Yep, so the question is, wouldn't we drop not high impact, not urgent also? Some may. So this is going back to my days as an engineer. I like to have little 1 or 2 pointers in a backlog for, you know, when you have those days where you've been working on something that's really, really difficult, it's kind of driving you nuts, and you just want a distraction for a couple of hours. I used to have back pocket stories, which is something that I knew I could solve in a couple of hours. It'd make me feel good about life again. And I like to have those in a backlog so I could turn around to my product owner going, in order for me to think through this issue, I need to solve something, feel good about myself, and then I'll continue, I promise. So those are the ones that I tend to just sneak in a backlog. It's not for everybody, but I find it helps my mental health. Any more for any more? Super. Well, I'll be around the conference for the next couple of days. Feel free to come up and have a chat. I hope that this was of some value, and if it wasn't of value, I hope it was entertaining. So thank you very much.
Okay, let's just get started because this is a topic I really love. Privacy mostly. Security is great as well, and we'll look into a lot of that, but I had to cut so much stuff because I love talking about this. Like even an hour wouldn't be enough, but don't worry, I cut it down. But we'll be going fast, and I give you a lot of little things to put. You don't have to remember everything, but I'm hoping to give you some things to bring back to wherever you work and to use in your professional life, or maybe just a refresher of some things you've forgotten, right? My name is Nikolai. First of all, I am a developer. I program every day. I'm a consultant, and I work at a firm here in Oslo called Variant. So I live and work here, so I'm a local speaker. The big thing in a talk like this that you always see is like, maybe the title should have been this, right? I'm not a lawyer, and I do not give legal advice. We'll be talking about some like legal stuff, so now it's said. I've divided it up to kind of 4 topics to make it a bit easier to follow where we are and what I'm going to be talking about. So I'm going to start with the most fun part, which is kind of navigating the complexity of legal compliance. Wow, that's a mouthful, right? So we'll go into some like history and some laws, and if you're not from the European Economic Area, you're going to learn a lot, and you're going to start hating the area because it's a lot of rules and laws. But yeah, we've been handling a lot the last few years and still are. Then we'll move on to anonymization and pseudonymization, which are techniques to use in privacy. And I'll just give their overview of what it is, and I'm going to show a very cool example from my time at Utdanningsdirektoratet, the Directorate of Education and Learning, where we had to give out aggregated statistics with different levels and how hard it actually was to anonymize it. Then we can move on to encryption and keys, and there we're just going to go through like symmetric keys, asymmetric keys, and key exchanges, right? The foundations of how the internet works. We'll just go through them so we all remember how they are and how they work, and how we can communicate securely and store data securely, right? And at the end, practical insights and tools, just some cool things that I've done, like how to encrypt and version control your secrets and get them deployed. We'll look into like managed identity on Azure as an example of giving your app an identity, and we'll look a little bit into always encrypted on SQL Server, which is kind of a client encryption technique. So some more practical stuff, but things I've used in real life, and I think it's super cool and kind of want to show you. So in this kind of part 1, your brain, I will show some text because the legal text is not a lot, but I know your brains will read the text on the slide first, right? And then I'll try not to start talking about something else while you're still processing, but I'm aware that in some slides there will be a bit of text, but not more than kind of this, so don't worry. You were probably expecting like a huge wall of text. So I just always like to start with this. Like if you write down kind of your mother's name on a to-do note at home, this is kind of not the legal stuff we're talking about. We're going to be talking about kind of law and compliance and rules we have to follow and things we have to do as developers based kind of from a organizational standpoint, like from a business standpoint, thinking about our customers, but also our employees. Remember that employees are just as well protected by laws as customers. But first, let's kind of think about what is personal data. So this is a very wide definition of what personal data is. Like you have the obvious ones, right? Name, phone. The ones that are not as obvious, IP address, right? And the reason it's personal data is because somewhere at the ISPs, they are able to connect that IP to a individual, right? Natural person at a certain date at a certain time. So that makes it personal data. Things you don't think about, like an audio recording. An audio recording where you can recognize someone by their voice, that means that recording is personal data. And then we have another layer, right, of more sensitive data like race, ethnicity, politic views, religion, and health. These are considered more sensitive. And also personal data about children. They're also considered sensitive, so you have to do even more when you're talking about that kind of data. And in the EEA, like the EU, I might say EEA, European Economic Area, or EU, but I'm talking about the same thing. We have very strong laws, right? They're kind of like, we have by law the right to the protection of our personal data. And as individuals, this is amazing, right? We are so well protected. And we have all these rules about lawfulness, fairness, transparency, and businesses using our data, our personal data, need to like have specified, explicit, and legitimate purposes to actually do so. And you cannot use that data for anything else once you collected it. So the EU laws for this are super strict, which is good for us as individuals and a pain for us as developers and working on products, right? And you have like different ways of giving. You have consent, I'll get back to that, but you have also like legal interests, which is how Meta says they're gonna use your data for AI training, like it's in their legal interest to do so, which is, let's see how that turns out. And then, but you also have contractual obligation, right? So if you sign up for my service and I'm using Stripe as a payment provider, then I, of course, have to let you know in my privacy policy that I'm using Stripe, but I can put your personal data in Stripe because I need to do that to do what you asked me to do contractually. So that's what kind of contractual obligations means. So yeah, here's a lot of points, and this is kind of the demands that the GDPR puts on us as developer and corporations when we're working with personal data for individuals in the EU. Doesn't matter if you're a US company, if you're working with the personal data of an EU citizen, you have to comply with these laws. So that's a bit weird, right? Because, yeah, these are laws in the EU, but how is it with international transfers? So we have good privacy laws inside the EEA, and that's kind of okay, but how can we transfer personal data to countries outside the EEA? And I'm going to go through kind of the two basic ones, which are standard contractual clauses and adequacy decisions. And these are kind of the mechanism grounds for transferring data to third countries. There are a lot of other ones mentioned in the GDPR, binding corporate rules, code of conduct, blah, blah, blah. There are some exceptions, like if your life depends on it, it's possible to do it. But basically, these are the only two that is kind of, there's precedence on how to use them, and all the other ways are kind of, there's no precedence, so there's no practical way of using them. This is kind of the biggest slide I have in text, this and the next one. But summarized, when you have an adequacy decision, it means that the EU Commission has decided that this country has the same level of protection as inside the EEA. So you can transfer data there. You don't need to do anything special. You still need like a data protection agreement and all the stuff that you need inside the EEA as well. But they're kind of stamped this country as approved. Examples are South Korea, Switzerland, Japan, and the US. But a bit on and off on that one, and I'll get back to that. The other one is the standard contractual clauses, the SCC. It's kind of a pre-approved contract that the EU Commission has made. And it has been updated and includes kind of cloud and data protection agreement. But the important thing with this one is that you, as the data exporter, you are responsible to make sure that the data importer, who might be in the US, you're using a US SaaS service, right? You are responsible that the US laws are adequate for protecting the personal data you are sending there. So while we didn't have an adequacy decision with the US, kind of you were the one who had to say, okay, the EU Commission couldn't approve the country, how are you going to do it, right? So, but this is a way of transferring personal data as well. World's quickest timeline, because it does matter a bit when we're going to talk about these adequacy decisions and using services in another country. So in 1995, we got a directive in the EU and the EEA about how we're going to process personal data. This is a directive, so it means all membership countries in the EU has to apply it in law for themselves. So in 2000, 5 years later, that was actually applied as law in Norway. And at the same time, we got an adequacy decision called Safe Harbor I bet these names will sound familiar for a lot of developers at least. And that was kind of the decision that the US, you can transfer personal data there, that it's as well protected there as in the EEA. Then Schrems 1 came 15 years later, because a lot happened during that time, right? From the 2000, we got the iPhone and the cloud took off, right? And the 3 big ones in cloud, they're all US based. And Facebook came, social media, right? It became much more, much bigger. So Maximilian Schrems is quite famous. He's an activist now, but with a legal background, and he took on Facebook, and it validated the whole adequacy decision with the US. But only 10 months later, they just created the Safe Harbor 2.0, which they called Privacy Shield. And in 2016 is also when GDPR came. It was those 2 years until 2018 when the GDPR came into effect. I think the only thing I was working on was becoming compliant, and I think that goes for almost everyone working in IT in the EU at that time. Definitely everyone touched it somehow. But of course, most people know in 2020, Schrems 2 invalidated Privacy Shield because it was kind of the same shit, different wrapping. And yeah, we were 3 years without an adequacy decision before the new one came last year in June called DPF, which kind of, yeah, we'll get a bit back to it, but we have adequacy decision now, so now you can use Google Analytics and you can put things in US data centers, but feels a bit fragile, right? So there are 2 laws that kind of all the Schrems judgments were based on. And I think the bottom one, the executive order, it was Ronald Reagan who made this one in like, I don't know, the 80s. But it has to do with bulk surveillance at the border, right? And storing data and things that are not compliant with the GDPR. And these are the laws that kind of killed Privacy Shield. And yeah, they were cautioned about this before they made the adequacy decisions. And these haven't been removed. They are still there. But we got a new executive order from the Biden, from Biden, and it kind of adds some more, yeah, be sure you have to save all that bulk data before you do it, and a bit new ways for us to complain, right? But the laws are still there, and we should maybe be prepared for a Schrems 3, the trilogy. So at the time when Schrems 2 was active, I was working in a startup, health tech startup called Confrere, and we were doing a web RTC and end-to-end encrypted video calls between doctors and patients. And we were going into Germany, which has even harder privacy laws, like on top of the GDPR, especially in healthcare. And yeah, we had to do so much stuff here to become compliant, because when Schrems 2 happened, we were using AWS, we were using Twilio for SMS and emails. So we had to start going through how we could be compliant with German healthcare and the demands there. So we had to just switch Twilio to our Swedish SMS provider, because even though you're using a GDPR compliant service, does not make you GDPR compliant. So a lot of like services you use for analytics and for SaaS providers, platform providers, they say we are GDPR compliant, but that doesn't mean you can start using them and think you are GDPR compliant as well. It means that you can be GDPR compliant using them, but all the responsibility is on you. Maybe you have to encrypt, maybe you actually can't use the service, but they are kind of doing everything they can on their side. And as long as you follow the rules, they can too. But it's to put all the responsibility on you. So we, for example, we had problems with the integration with these SaaS providers, CDN exit nodes, like weird stuff, and I'll get back to that. But like the first thing we had to start thinking about was like data center location, right? And we were on AWS. I just took like this Norway as an example, because that's probably the most used one now by Norwegian companies from that period. So we had to kind of prove that we were operating in the EU, in EU data centers. But there were still issues with like, there's still American access, right? And support and updates, and the company, Microsoft, is still under US law. But we were on AWS, and they go out and they say, like, we have to do risk assessment, right? What is the risk of the US intelligence coming and taking our data? And AWS says we haven't got a single request for data. That's probably because they don't have like G Suite, Google Workspace, and Microsoft 365, right? They'll go for your emails, not your database. And of course, they are not allowed to tell you most of the time, I would assume, anyway. But all cloud providers say they will object and inform you if this happens. And it came some precedents, right? There was one, you don't have to read all this, but as I said, I know you're going to do it. But I underlined, like, it was a ruling that said about CDN and cookie handling, and they said, like, doesn't matter if you use a European data center, because if the American company has access, it's not good enough. So yeah, hard time to navigate. And yeah, it was also about CDN exit nodes. So they were actually testing, like, the Portuguese National Statistic Institute, they got a 12-hour warning, stop using the Cloudflare CDN, because we are seeing us hitting US exit nodes or nodes in the CDN network. And we were trying to do this because we were on AWS and CloudFront, and we had to make sure that when anyone was certifying us in Germany, they would always hit the EU CDN node, right? Even for our static web apps and stuff. It was crazy. And another health startup called Doctolib, they were challenged by professional associations and unions for using AWS, even though they were in French data centers, because they had a platform used to book COVID-19 vaccinations. But they were allowed to do so because they had legal safeguards in place with AWS, like good contracts, risk assessments, but they also did client-side encryption. So the data was protected by encryption. And it said when you had a reservation and appointment, but it was encrypted and no health data. So end-to-end encryption. And we thought, like, yeah, this is a great idea. They used a tool called Tanker.io, which has a SDK and a key management solution for the client side. And then Doctolib actually bought that company. That's how valuable it was in healthcare at that time to actually get around these problems. So we didn't get to try it, only read the docs and realized that it was out of reach. And of course, most people remember that Google Analytics was actually made, decided to be in violation of the GDPR. Even if you turn off the IP tracking, right, you cannot hit a web server without saying who you are, saying your IP, right? So when you hit the server, your personal data hits the server, and then, yeah, Google Analytics doesn't store the data, but your IP, the IP of the user in the site, right, has hit the edge servers here. So it was a lot of things around this. But now, of course, we have a new adequacy decision, as I said in my timeline. So now it's okay. But just be aware of what I told you. These laws are still in effect, right? And there's still a chance that this adequacy decision might just disappear. And then suddenly you have to take all these considerations again. So I think we as developers, like, I've gone through a bit like the laws and rules, but also this with the international transfers. Like, we choose often the data centers, we choose the providers, we choose what kind of data store to use, what kind of security to use, where we transfer it, policies, right? And we have to think of all this, data minimization, auditing, retention, and we'll get back to encryption, right? So it's important to kind of know a bit the history here, know the laws, know the issues that can arise. So when we do kind of bigger decisions around our solutions, we are aware that this is something that can hit us and can hit the business, right? This isn't just about the, like, small things in our code and that is, this is annoying as a developer. We work for an organization trying to achieve something, like, with a goal, so we need to be part of this and have this top of mind. These are considerations we have to do when kind of doing system design and working on products, right? It's our responsibility. So I'm sorry to say the fun part is over now with all the laws and legal compliance and text, but it kind of put the groundwork for everything, right? The foundation for everything. And before GDPR, for people who worked with personal data at that time, you know it was a lot more slack than it is now, and that this is a very big improvement for individuals living in the EU. Okay. Anonymization and pseudonymization. I see a lot of privacy policies. I'm actually kind of one of those people that read the privacy policy before I sign up. You could maybe have guessed from the first part. But I often read this. We may anonymize your personal information so that you can be blah, 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 blah. It doesn't matter what I read after that, because I'm always skeptical, because it's so hard to anonymize data. And most people really underestimate how hard it is. So the definition of anonymization is the process of removing personal identifiable information, as it says here. That means it's impossible to reverse engineer it. That's the definition of anonymization. If you can reverse engineer it and get back to who this person was, it's not anonymous. There's no wiggle room there. An example is, for example, when I work at Utdanningsdirektoratet, the Director of Education and Learning in Norway, we had aggregated test score results from school. And for example, if there was only one student in that school, then the average test score would be that individual's test score, right? These are children also, so we needed to hide that. And I'll show you that example after, because it's a lot of fun. Encryption is a safety measure, so and anonymization is a privacy measure. It means encrypting something doesn't make it not personal data, because it means it can be restored. That includes one-way hashing also, and because you can later hash and then match the hash, right? So it's possible to figure out who this was. And yeah, if it can be restored, it's pseudonymized. And that's kind of what we do when we want to hide personal data, but we need to be able to identify someone, right? So think database identifier in your users table, right? The ID. But pseudonymization, as I said, it can be restored. It can be restored, but you can use data somewhere, and it doesn't matter where it is, right? If you have an ID in your system, and there's like a secret database in an offline server in your headquarters, and that's the only way to identify the user using that hash, is still personal data. That's how strict it is. Global kind of, doesn't matter if it's inside the EU or anything, it's kind of the definition. And so it doesn't have to be publicly available for you to be able to re-identify. So this is the example I gave, the user database identifier, personal information, because it can identify someone. And I always, when I try to be hard with people, I always I call it the library computer test, right? If you had a URL like this in your web app and someone visited it from a public computer, it gets saved in the browser log. Remember, this is personal data, right? So if the user kind of chose to do that, then it's okay, kind of. But we have to be aware of this even when making URLs and endpoints, because, yeah, you have to be aware. Maybe you need some kind of check or something. A lot of people have that, like I'm on a public computer, right? Because they're thinking of these scenarios. And also machine to machine, if this was a machine to machine call for some APIs, we have logs everywhere. And that might be fine, legal obligations, right? You need it for debugging and so on, but make sure you have like time to live, all these things, and that you are actually aware of where you send personal data. So yeah, pseudonymization is a tool for protecting personal data and a tool to reduce risk. That we are, by law and by the GDPR, we have to use it as a tool. If you could use pseudonymized data instead of the real personal data, then you have to do it. Because if not, you are not minimizing and protecting it good enough. So I wanted to go into, as I said, from the Norwegian Directorate of Education and Learning, a bit about anonymizing statistical data, because that was one of the most fun things I worked with inside of this domain. And every 4 years in Norway, we have an election. And at this time, when I was working there, we went from a red government to a blue government. And they wanted to, we're not going to have aggregates just on municipalities anymore. We're going to go down on school level for national tests to have public data on how schools are. And yeah, so we had to add lower aggregates, and we had to use proper anonymization because these were kids' test results, right? So I just going to go through it because it's a bit cool. This is very simplified, like it was many accesses on the data set, but you get the basic idea of a problem. So we had like an aggregate for boys on a school and for girls, and then we had an everyone aggregate, which was kind of the sum of those two. But as I said earlier, if we had one student in one of these aggregates, we had to suppress it. It's called primary suppression. This one has to be hidden because it's the actual test result of this student. But if there are some mathematics nerds in the room, you maybe realize that if you just take the everyone aggregate and remove the girls, then you actually have the boys aggregate. So we needed to do what is called second suppression. And at this point, we're actually losing statistical data just to preserve anonymity, right? The everyone by itself couldn't identify a score if the girls' pool was big enough. But it wasn't as easy as just doing this per school because we had higher aggregates, right? So this is a terrible slide, I'm sorry, but you can see the different levels on the left side, and the one with the arrow, we have the school we just suppressed in, but if we take the municipality and we remove the other school, because in this example, it could be 1,000 school, but if it was just one unknown, then we could solve it from there, right? Because we have a higher aggregate. So we need to second suppress that school as well. But of course, it's aggregates down on that school. So just as we suppressed only 2 aggregates on the other school, we need to go down in the second suppressed school, down 1 level. And it makes sense to maybe second suppress on that school the everyone aggregate. And here we have high numbers, so we're losing data here just to hide that data from that other school, because we don't want people to be able to solve it and get that individual student's test score. And a good rule when doing suppression is like, let's take the smallest one, right? Hide the least amount of data. But if you were a bit observant, we did a mistake here, right? Because we were not considering the higher aggregate. So the municipality aggregate, as you can see here, the everyone has 2 unknowns because it's suppressed in both schools, but we suppressed the girls in the second school, so there is only 1 unknown on the boys' axis. So we should have done like this. And yeah, some weird things, like we have Svalbard in Norway, which is like a little island, and if we only looked at one axis, like one girl on the 5th level of school there, then it could go up, right, all the way up here, and it could go, we'd have to choose something. The one on the right has fewer municipalities, but that's Oslo, so it has a shit tons of schools, so we have some rules, right, to go down and blah, blah, blah. They actually put Svalbard under Finnmark, another county in Norway, to avoid this problem, because it would always be the one that would be second suppressed, so because it's the least amount of students there. But yeah, crazy. And we had so many axes here. We had shit tons of axes. We also have private and public schools, so you could use kind of a second axis to solve over to the problem we're looking at now, and we divided them into level based on their test scores. It was an average per level. So this was the funniest problem I think I've ever worked on. I worked together with the statistical department, and we solved this all in F# with like an algorithm that would, we had a test that was always trying to solve, that we made to try and solve all the statistical data. We used it on previous years. I think we solved it. So, but we used it on kind of our new algorithm, and we found it to be proofed. But we needed to always work on trying to hide as little data as possible, because it's easy to hide a lot, but it was really hard to go down and kind of show as much as possible without exposing personal data, right? And yeah, I remember I was dreaming about this suppression stuff. So I was talking with the guys in statistics, and I came one day and we were in a whiteboard in the meeting room, and I said like, now it's getting too far. I'm dreaming about this. And he was like, finally, you're one of us. So that was fun. So back to that privacy policy. Last slide on this part, but yeah, now you kind of know where I'm coming from. When someone says they're going to anonymize my data in some kind of pool, I'm not too sure they're actually doing it. Always a bit skeptical, because anonymization is hard. So that was fun. I just think it's a fun example of a real-life problem where anonymization is very hard. But now to the fun part. Encryption, I'm saying that about everything. Encryption and security. And I just want to drag us through like how the internet works, right? And this is like, people have read about this, people have had it in school, but it's kind of easy to forget, and it's kind of fun to recap everything. So you know these two, you've heard about them, I'm sure. And you most likely heard about these two as well. Eve, which is for eavesdropper, and Mallory for malicious. But luckily we have encryption, right? If we met in real life and we had a lock and we had 2 keys to that lock, we could take 1 key with us and one each, and I would be able to send things across. This is what we call a symmetric key, right? We have the same key on both sides, and it can both lock and unlock the lock. And for the example of all this, like, you can't pick this lock, not with today's technology, right? Unless you have a quantum lock pick, but we'll get back to that. So both can encrypt and decrypt, right? So that's a symmetric key, but we had to meet to make this work, right? To get the same key. We had to somehow come together and make sure nobody was looking, and I could look, if I was Alice, I could look Bob in the eye and say, like, let me have your key. And then we kind of know that this is a safe way to communicate. But what if we were unable to physically meet to exchange keys, right? And for that, we have what everyone knows as the Diffie-Hellman key exchange. And this is in practical use today. Like, we know it with kind of prime numbers and stuff, and now it uses like elliptical curves. But these kind of basic things are the foundation of everything. And yeah, they are always been made more secure, but the basics here is still how it works. So it's good to know. And it's a very easy way to explain the Diffie-Hellman key exchange. First, you start on agreeing. I like to explain it in colors, right? But the assumption here also is like you cannot divide a color into the 2 colors you use to mix it, just as the lock cannot be lock-picked. But it's a good explanation, so bear with me. And this common color we agree on, we share it with each other through our public channel. It doesn't matter if the eavesdropper hears about this color, right? And then we pick for ourselves a secret color, a secret key, a secret color that only we know, and we're not going to share that with anyone. We then mix those 2 together. So Alice mixes her private key with the shared color, and Bob does the same. And what we do, and again, the point here is very important, that you cannot take that color and use some kind of tool to find the 2 colors used to mix it. You cannot sit in a room and brute force it, because with today's technology, it's impossible, for the sake of the example, right? If it was colors, you could, of course, be at home mixing color until you got that common color, maybe in the end find the 2 colors. But for this example, that's impossible, because with today's technology, you can't do that. We then share the mixed color. So note that we're not exposing our private key. We're mixing the mixed color from our secret key with the common color. And then we add our own private key to the other person's mixed color. And we arrive at a shared secret color. So if you kind of reverse engineer this, you'll see that the nudient on top equals the 4th color on the top row. It equals the shared color and the secret key of Bob plus our secret key. And if you go the other one, it would be the same. So basically, we get this. That's why it works. But we managed to do it without even exposing our private key. And this shared color we arrived to is this kind of symmetrical key that we talked in the start. So we shared keys without ever meeting. We're back again here. And yeah, symmetric keys uses the same for encryption and decryption. It's much faster. It's the fastest way of encrypting and decrypting and talking back and forth. It doesn't demand so much computational power, right? It's fast because it's less complex math than some of the things we're going to get to. But they were all of them deceived. for another key was made. So yeah, we haven't solved the problem we talked about earlier, right? We didn't meet, so we don't know that we actually talked to Bob. It could have been Eve here saying like, yeah, I'm Bob, let's exchange keys. And on the other side, yeah, I'm Alice, let's exchange keys. And just decrypting and encrypting it again and passing it on. And you would never know that the eavesdropper is here in the middle listening in. So this is a classic man-in-the-middle attack. And here at the kind of key exchange level is where it could happen. This is today's sad news for some. We need to trust someone. The whole internet is built on trust, keys and certificates. But we need to learn about asymmetric keys for this. Asymmetric keys is kind of, we all know this as developer. If you never touched asymmetric keys, even though if you didn't know their name, as a developer, that means you maybe never used GitHub, and then I'm starting to doubt you know what you're saying. Like, we know this. Public keys, the public key, we mostly use SSH keys, and they are for authentication, but there's also like GPG and PGP, which is the same implementation, but it consists of this key pair, where we have a public key for encrypting and verifying signatures made by the private key, and only the private key belonging to that public key can decrypt the data and create the signatures that the public key can verify. So in this case, both Alice and Bob has a key pair. The one on the inside here is their public key, which you can share freely. It's you don't have to keep it safe, but your private key, never show it to anyone, right? So we can swap these now. We don't have to do the whole key exchange. But at this point, we haven't solved what we talked about earlier, right? We don't know that we actually got Bob's public key. And this is where trust comes in. You need someone you both trust to be able to trust that public key. And kind of GPG keys, they try to solve this with kind of the web of trust. So let's say I met someone here in real life, we exchanged keys, then I could use my private key to sign their public key. And that means if you trust me, you can trust them because I signed their key. But it's way too complicated. But that's what we call it kind of. Then I could publish it on a key server for GPG, but we kind of all trust GitHub, right? So I could put my SSH key there and my GPG key and sign my commits. And since we trust GitHub, we would trust that, yeah, the GPG that is connected to my profile is actually me signing the commits. Keybase, for those who use that, was kind of a way to sign across social media to confirm which accounts you had by signing them. And you could know that if I could be 100% sure if I knew that was you on Facebook, I could go through there and know that's you on Twitter, that's you on GitHub or other social media, right? You have SigStore, which is for artifacts we create and signature. SigStore, I would recommend going and reading about SigStore because they have so much good documentation about how to do safe packaging and signing of packaging that goes way beyond what we are mostly used to, like a MD5 hash, right next to the zip file or whatever you're downloading, so you could verify it locally, but you never have. And of course, the last one, the certificate authorities for these TLS SSL certificates. And that's the big one at the end. Like that puts the whole internet builds on trust on the certificate authorities. And our browsers and operating systems are pre-programmed on certificate authorities to trust. So, for example, here is a certificate authority at the top, a web server, and this is like the most simplified TLS secure handshake from a browser. It's a bit more about like which protocol to use, cipher suites, compatibility and stuff, but we're going to show it's the kind of same basic we've been going through, right? So the certificate authority has some kind of, they approve that, yeah, you are this business on this domain. And they sign a certificate for you and give you a public and private key for that certificate. So when Alice comes from her browser and tries to talk to the web server sends the certificate signed by the CA, and which contains the public key, but they also sign it using the private key they got. So with the signature, Alice knows that, yeah, the web server that sent me the certificate, they have the private key, because if not, they could not sign it. and the browser trusts the signature also of the CA on the certificate. So this is simplified. It's a big chain of trust up, but this is basically how it works, simplified. So Alice just creates some key pair on the fly. She verifies through the whole key exchange procedure that is still the same public and private key that is on the certificates, but the web server doesn't care who Alice is, but to exchange a symmetric key and start communicating fastly and securely, we do the same. We're back now to starting this Diffie-Hellman key exchange, right? But we have verified the keys of the web server. And you could do the same with people. So that's basically how the internet works. Asymmetric keys, symmetric keys, and these kind of handshakes, signatures. And as developers, we mostly know or use JSON Web Tokens in a lot that we do. And this includes all these kind of things, right? It consists of 3 parts, the header, the payload, and a signature. So the header just is data about how it's encrypted and stuff. But the signature is signed by the public certificate of the issuer, right? So the issuer is either in the token itself, or you usually, in your middleware, you point it at an authority server, right? Maybe Microsoft AD, for example, or Microsoft Entra ID. Sorry, Microsoft. And we send it right in the header, and we verify it. And since we have the trust of the internet, right, we can go over HTTPS to this well-known endpoint that we use for OAuth and for JWT. And there, the public keys for the token are hosted. So we can just, when we start our application, we could fetch the public keys and say that as long as we verify that the token coming in is signed by the private key owned by this public, as long as the token is signed by the private key belonging to the public key at our trusted issuer, then the claims in this JWT tokens are true. So here we're using kind of asymmetric keys, and we're using the trust of the internet and certificates to actually get the public keys we're going to verify against. And JWTs are what we call stateless tokens. Might not make sense to you because it is a lot of state in a JWT token, but it doesn't have any state on the server, right? It comes in and it's kind of self-contained, so we just verify the signature and then it's like, yeah, it looks good to me. While, because it's signed by the issuer. And that can reduce a lot of networks requests because we already have the public key, we got it, and we are just verifying on the fly. Stateful tokens are just arbitrary strings, like they don't mean anything because they're stateful. They come to the server. It's just a bearer token in your header. And then when you come server side, you actually have to go to the authority server and ask, hey, I got this token, is it valid? And it's like, yeah, it's valid. And then you have to go fetch like, yeah, but who is it? And then you get kind of the ID token. So it's a lot more network effect. If you have a SPA or something, you can always cache for a short amount of time to avoid that. We did this. I was at If Skadeforsikring, insurance company here in Norway. And we use opaque tokens because it has some plus. Because if the private key gets compromised or lost, then they can sign their own JWTs. And with opaque tokens, if a user, for example, clicks log out on one device, you can actually just right away invalidate the token, and all requests will start failing on all their other devices because the token they're sending is invalid. While if you're using JWTs, it might get a bit more complicated because they have valid tokens that are signed. So keep short time to live on JWT tokens, so they'll have to be renewed. Then you don't have to have like, yeah, I don't know, web sockets into every open browser the user have to actually log them out, and can get complicated. So it has some pluses, right? And I promised to tell you about the biggest attack vector of all, quantum computing. It basically breaks asymmetric keys, which is kind of built on, as I said, we all know, large prime numbers, or now it's elliptic curve problems. So yeah, quantum computing will come, and Shor's algorithm will manage to solve kind of, if you have the public key, you can solve the private key. And we need to also think that everything we store now, or an attacker stores now, can be decrypted later. And it's in very small text down there, but if you search for Google's post-quantum cryptography blog post, it's a really good, cool blog post about the future, new algorithms coming, and also like things that, like businesses that are very that can be attacked like this, how they can already start now to be a bit more quantum computing resistant, and how they can start planning a transition. But most of all, it's just a very fun read, right? So there's a lot of things to consider, right? Private keys can get compromised, stolen. What do you do then? Someone can sign with your name, basically. You saw this often with having a master key, and the key you use, the sub key that is signed that master key. If you want to go into this, it's crazy how much you can do. You can have a YubiKey. A lot of people use that. A YubiKey basically does all the signing and stuff on the hardware device, and the private key lives on the YubiKey and never leaves the YubiKey. That's why it's considered so safe, right? Because everything cryptographic happens there in that secure enclave, or whatever you want to call it, on the hardware. SigStore, check it out for artifacts and signatures, and their documentation is amazing to explain kind of all the problems with having long-lasting private public keys, asymmetric keys. And they really get into this last part, right? If you had a package used by millions of people and someone gets your signing key and they can re-upload something and sign it with that key and replace something that people use and it has the same signature, right, safety-wise. They go into a lot how you can get around that. So great. We went through the 3 things that keeps the internet together, right? We can exchange keys, asymmetric keys, and sign and encrypt and decrypt and verify signatures thanks to trusted third parties. We know how a symmetric key can be decided without every meeting, and using that symmetric key, we can actually fast and cheaply, computational-wise, communicate. So that's a lot, but like I think these 3 is so important to be reminded of how this works. We touch this every day without knowing it. We touch it when we open our phone and go to a web page, right? All this happens behind the scenes. So the last part is just some cool different stuff that I've done in different places that touch a bit on this with encryption and especially in keys. And the first thing, like, people would probably know this, like you start a new project and to onboard another new dev, they kind of, I need to send you the .env file with some secrets that give access to different integrations or, yeah. So we need to make kind of it easy for ourselves. I am a big, I love putting secrets in source control on GitHub, why not? And so I want to just quickly introduce you to SOPs, S-O-P-S. I think it came out of Mozilla, I don't really remember, but it's a great way of kind of using keys to encrypt files that you have in your Git repository. And it has a lot of things that you can use. For example, Azure Key Vault, which I'll show you. I simply just make a sops.yaml file in my root folder to tell which Key Vault I'm using. So I have to, of course, log in with the Azure CLI, and someone needs to add me a group to give me access to this Key Vault. But then I can start actually decrypting and encrypting files in the repo. And SOPs, it gives you this crazy JSON or YAML or whatever. But as you can see here, it's just the top row is just data, and then it is a bit info about Azure Key Vault. And it tells which key in Azure Key Vault to use for encrypting the encrypted key further down, because this is asymmetric and symmetric key. So our data is encrypted with a symmetric key, so we can keep encrypting and decrypting very fast. And then that symmetric key is encrypted by the key that is in Azure Key Vault. But everyone has access to that if they actually, if they can reach Azure Key Vault. So basically, you control access to encrypting, decrypting secrets in the repo, the same way you kind of would manage it for access to email, right, in your Azure AD. Very quickly in a GitOps flow. For example, here, this is a Git Kubernetes secret with some secret data. I make a SOPs file in the repository. Here I'm using a PGP key that I have on my computer to encrypt the data. And here you can see that SOPs also can, you see it still contains some of the, it's still valid YAML for a Kubernetes secret. And the cool thing is I'm going to go a bit too fast through this, but I can actually put key in the Kubernetes cluster, right? If I'm using Flux CD, for example, or using Argo, it supports this as well. So I give the cluster the secret key as well, and then it's able actually when I commit encrypted stuff to or secrets to the repo, and it pulls it and starts deploying it, it can actually decrypt it inside of the cluster. So we have a safe way of giving and making sure these secrets actually exist on the can be applied on the cluster, right, and exist there. So I also want to show you managed identity in Azure. It's actually something you can just turn on a web app, for example, and it gives the app an identity, kind of a user, thinking of that. And you can also turn it off. Of course, you should use infrastructure as code. And it basically just opens kind of an endpoint that the app can call locally, and it gets kind of a username and password, a client ID, client secret, to a token to communicate with. And then you can use that. You just use this default Azure credential, which I'm sure most people have used. But most people don't know that behind the default Azure credentials is a lot of different, and you can pick and choose from this one. But one of the first ones is checked is the managed identity credential. So it actually, before it starts looking if you have Azure CLI installed or you're using the Visual Studio Code, it checks for this endpoint. Hey, can you give me a token? And it says yes, because it's kind of in the secure zone running in Azure. And then you can start calling like app configuration, where you can have kind of think of this as the .env file, right? Now you can just use that default Azure credential, and it doesn't matter if you're the app or a developer. You can go here and you can get kind of the secrets you need to get started. And here's even some references to Key Vault and secrets. And yeah. So in the web apps configuration itself, it's no secrets, not even in the connection string. Connection string just says where to find the database. And then you can kind of get this token, and we can even put it on the connection, and it can connect to the database with this managed identity. So the best way to handle kind of keys and tokens is not to handle them at all. Managed identity lets you do that. So the developer experience becomes just AZ login. A new developer on your team, you add them to the developers group or your team's group. They run AZ login, and they can start up the app. They get all the secrets to call like integrations and stuff. And then maybe for the writing stuff, you run up some Docker containers, but you can get someone started very fast without having to share anything. Yeah, and I've done this a few places. I went a bit fast now, but this is kind of you can't, for people thinking about this, like, yeah, no, you can't program on the plane now, right? Because you need actually to get the secrets from over, you can't run things up locally. But for the places I've used this, like, okay, then I'll save some work that I can do on a plane. I'm not gonna design my whole developer experience, security, and kind of application around that we should be able to program on a plane. Some, like without internet. Some cases it might be worth it, but yeah, it's a cool thing to check out, but it just works kind of in the Azure way, but in the Azure scope. But there is a lot of alternatives on other platforms for giving your app an identity. The last thing on this part I'm going to show you is a bit about always encrypted, which is a feature of SQL Server, but almost all databases have some version of this. And we actually use this. This is great for data confidentiality. We use it. I was at the Directorate of Health. I've been at a lot of directorates, I realize now. But here we were getting health data in messages coming from journaling systems, but we're not allowed to see that data even as developers working in the database, right, in the production environment. We shouldn't be able to just open the table and see health data about individuals in Norway. It was no reason for us to do that. And if there was a reason, we should ask someone who actually had a reason to go there, someone on the business side working with the data, and ask, hey, we actually have a valid reason to do it, right? So this is a great feature. We kind of, it lets you do this thing. I talked about Doctolib earlier, and they bought this company Tanker, and they were encrypting things client side. So what you can do here is actually, you just set a column in your database to be always encrypted. And if you have the key, it will kind of get that row, decrypt it on the client side inside kind of the SDK, and you won't even notice that it's getting encrypted and decrypted on the fly on your client side. but the database engine never sees that data in plain text. And you kind of had, it works the same way. You have kind of a column master key, which is a key value pair that you have the secret key to on your client, and it encrypts a symmetric key that is stored on, encrypted on the server. So everyone who has the master key can get that symmetric key to their client, decrypt it, and start decrypting and encrypting data. And your app, it can have, for example, a managed identity, right? And you can add in Key Vault that this managed identity should be allowed to get this private key. So then your app, who of course needs to be at least able to encrypt data, but in most cases, your app needs to process the data as well, but only, for example, in the production environment. So then you would give it a right to get the key, for example, from Key Vault. And you don't need to like install the key right locally, because you can also be given access to Key Vault. So maybe you could have, you can be pinned, like be allowed to access the key for 1 hour if you actually needed to work on some data. So there's a lot of cool things you can do here. And this brings us also in kind of the secure computing space. Because if it's not plain text, but only ciphertext, it's kind of hard to work with the data in the database to do queries and stuff. Things need to happen on the client side. But it is possible with this kind of secure enclaves. And this is kind of in the CPU, right? This secure enclaves. It's called like trusted execution environments. And Intel and AMD, and they all have it. And it also works with trust. But the simplest way to explain it is not really how it works, but it's so similar. Think of it as your CPU basically reserves a bit of memory. It has some secure instruction. It secures a bit of memory inside the CPU, inside your computer and everything. It creates a secret key, and then you kind of get a public key that gets verified in Azure. So when you send a request here, it can do some more. It can actually decrypt the data. It goes to Key Vault. It's allowed to get the private key, to get the symmetric key, and can decrypt the data, work on it in here, and then make sure it's encrypted when it leaves out again. So there's no way, kind of, the idea is there's no way to get inside this secure enclave in the CPU once it's made for this perfect. So this is what we call kind of, you have data in transit, right, which we see in the middle. We have data at rest, which kind of the data encrypted in the database engine, and this we call data in use. So we're securing it in use in the memory or in the CPU. So yeah, I went through a lot there at the last one. It was mainly meant to just kind of inspire you to look into it. So we looked into a lot of stuff, right? The first one was that everything is personal data, right? Everything about encryption, portability, and third-party providers, and how much we actually have to think of as professionals. We talked a bit about anonymization and pseudonymization. I showed you how hard it can be to anonymize data, right? So we should know what we're saying when we say we're going to anonymize. And yeah, the business side often is very lean on that, so I like to arrest them, but that's not anonymized. Like, that's how you get popular in your business. We looked at encryption and keys, which we kind of all knew from before, but now we know it a bit better. And we know that the internet still works that way. And we touch this every day with our SSH keys and when we sign stuff. And I showed you at the end SOPs for encrypting secrets and being able to share secrets inside your team or your company for that matter, and still have the kind of same access control that we have for other things like email and the same kind of governance. And then we looked at always encrypted. No, managed identity we looked at, which I really recommend you look into if you're using Azure. It can also be a sidecar in your AKS cluster, right? So you can still use managed identity for Kubernetes apps living inside of a Kubernetes cluster. And there are the same concepts exists in the other cloud services. And yeah, the database, secure enclaves, and yeah, that's also a whole nother topic. And then, of course, the main point, none of this matters because of quantum computing. But luckily, that's a bit ahead of us. Just to end on a funny note, I wanted to show you this one. This is a very funny Twitter post I saw about a landlord who were giving out free fruit to the tenants And then suddenly came like a notice from the landlord. I've been filming you and analyzing which fruits you take. And in the bottom is like Devon, 56 blueberries, etc. And it's like kind of shocking. And then the disclaimer at the bottom is the best. I use the data to know which berries to buy. It's fine for me to do this. If you live in my building, I can use your data. Thank you so much.
All right, my timer has begun, so I think even though it's right after lunch, and I'm sure a few people are still going to be trickling in, we are going to hop into things. So welcome to my talk, The Power of Function Composition. My name is Connor Hoekstra. I go by code_report online, so you might know me by that alias. This is the full About Me slide. I'm not going to spend too much time going through this because we've got a lot of stuff to get through in my talk. The stuff worth highlighting for the last 5 years, as you can probably tell by my t-shirt, I've worked at NVIDIA, which a lot of companies, hadn't heard of in the last couple of years. I guess everyone in tech has heard of it, but my parents finally know what company I work for, thanks to the stock price going up. For the 10 years that I've been in industry, I've been a professional C++ developer. Over the last 2 to 3 years, I've migrated a bit to Python, but I consider myself a polyglot programmer. So I've never checked any production .NET languages into production code, but I have written some C# and some F# for YouTube videos primarily. But I actually added some C# and F# code to this talk because I have heard from the first day of the conference that a lot of folks are working on the .NET stack. In the last, I guess 3 years now, 4 years, my favorite languages have become these languages that fit in this paradigm called array languages. If you've heard of APL, that is probably the most well-known of the array languages. Maybe if you include Julia, Julia is more well-known than APL. But APL was created in the 1960s, and then in the last decade, I guess J was created in 1990. But in the last decade, there's been a bunch of new languages inspired by these, and we'll talk about that a bit later. I have 4 different podcasts, so trying to compete with Richard Campbell, if you've seen any of his talks. The most well-known one is the one on the left there, Algorithms plus Data Structures equals Programs. We're approaching 200 episodes. It's a weekly podcast. Primarily, I'd say 70% of the podcasts focus on C++, but we jump around from language to language. Typically, it's more lower-level systems language. We just did a 5-episode series with Doug Greger, who's one of the top people at Apple working on the Swift language. We've also had folks to talk about the Rust language. If you've heard about the Carbon Initiative out of Google, we've also had Chandler Carruth, who's one of the top people working on that. So it's a programming language-focused podcast. Even if you're not a C++ person, you might be interested. The 2 middle ones are on array languages and related topics, and the last one's a running podcast. All of this stuff you can find on a GitHub repository called Content. My previous talks that I've given at other conferences. This is my first NDC conference, so happy to be here. It's been an awesome conference so far. But if you're interested in any of that stuff, check out this GitHub repo. So today we're going to talk about function composition. What is the goal of this talk? I'm sure if you're working in F# or a functional language, you've heard of function composition before. But I think function composition is a misunderstood thing in computer science. Most people think of function composition is composing 2 unary functions together. But that is just the tip of the iceberg. And my goal of this talk is to show you that there are different function composition strategies, there are different types of function composition, and hopefully at the end of this talk, regardless of what language you're working in, whether that's C#, F#, Python, JavaScript, any other language, that you can take some of these strategies and techniques and bring them back to your language. Maybe there's already a library that exists in your language of choice that you can just go and reach for. And if not, you can build these libraries. I've built a couple, and I'll mention them at the very end of the talk. So there are 5 different function composition strategies that I'm going to cover in today's talk. They are operators, functions, trains, chains, and stacks. Probably all of you are familiar with the first 2. Anyone can compose functions just by using functions. And if you've worked in a functional language like F# or Haskell, these come with operators that give you the ability to compose functions. And usually I save the goal of this talk or the summary of this talk till the end, but I'm gonna start to potentially confuse you, hopefully blow your minds by putting that slide at the beginning. So that is this slide here. These are the different operators and techniques for composing functions across the languages that we're going to look in this talk. And anything that's left white after I color code and highlight some of these are operators. But on top of that, we have functions, which are highlighted in blue. They only exist in Haskell. Then we have trains, which exist in the array languages. Then we have chains, which only exist in Jelly, which is a super, super esoteric language. It's actually designed for code golfing. If you've ever heard of the art of trying to solve a problem in as few characters as possible, Jelly was a language designed to be good at that. That is the sole purpose of the language. However, there are some very, very interesting programming language ideas inside of Jelly. Jelly is actually so confusing, though, that I had to write a tool to convert the Jelly code into something that was decipherable for me. And that's someone who understands everything to the left of the yellow bar. Like, I love APL, JCap, etc. And last but not least is Weewa, which is a stack language similar to Forth, Joy, Factor, if you've heard of any of those languages, combined with an array language. And so they don't necessarily have a strategy for composing functions, but you get a lot of this stuff for free when working with a stack language. So we're going to come back to this at the end. Probably most of you are just scratching your head being like, holy smokes, this is overwhelming. But hopefully by the end of this, some of this will make sense. Probably not all of it, I'll be honest, but hopefully some of it. So at the top left of this, we have FOF. Does anybody know? I made this term up, so you probably have never heard it before. But can anyone guess what FOF stands for? Someone actually came very close in another conference. No guesses? It stands for function-only functions. So it's a function that takes as arguments only functions and returns you a function. But in order to really understand that, we got to look at a bunch of terms. So these are the terms, these are combinators, and we're going to define that in a sec. And these are the terms that we're going to work through. Combinator, combinatory logic combinator, function-only function, pure function, and higher order function. We're going to go through this very fast because it's not entirely necessary to understand the rest of the talk. But if you want to come back to this after the fact and kind of digest this a bit more, I think it's helpful going down the road. So first, let's look at pure functions and combinators. So a pure function is a function that when you give it the same input, it always gives you the same output. No side effects. If you're used to F# or languages like Haskell, they refer to this as referential transparency. But basically, same input, same output. And they're very nice to work with. A combinator is a function that deals only in its arguments. It can't refer to anything else. No global state, no constants defined in the function. It only is allowed to deal in what you pass it. And when I first heard about combinators, my first thought was, are these the same thing as pure functions? They sound very similar. But they're not. You can come up with examples where you have a pure function, but it's not a combinator. For instance, if you have a function that defines a constant in the body of the function, that is not an argument that it's referring to. So that is still a pure function, because it doesn't refer to global state, doesn't have any side effects, but it's not a combinator because it's not dealing only in its arguments. So pure function, combinator, similar, but not the same. The next thought I had is, what's the similarity between these two and higher order functions? So a higher order function, if you're not familiar, is a function that either takes as an argument a function or returns you a function. Once again, though, you can come up with counterexamples where you have a higher order function that's not pure because it's got side effects, or you have a higher order function that's not a combinator. So these all are not the same thing. You can come up with examples that they all qualify for each of these, but they're not the same. My mental model, though, is that we live in a pure functional land, like Haskell per se, and we can assume that higher order functions and combinators are both pure functions. And so then the question becomes, what is a function-only function, and what is a combinatory logic combinator? Is it just this green circle? And the first answer to what is a combinatory logic combinator is no, it's not. There is this inner blue circle, which are the combinators from combinatory logic. And this is also referred to as the SKI combinator calculus, if you've ever heard those two terms before. This is basically a field of abstract mathematics that was created in the late 1920s up until the 1950s by a guy named Haskell Curry. The Haskell is from the language Haskell. Curry is from currying functions. I mean, both of those two things were named after that guy. It's pretty awesome if you can have both your first name and your last name used to name things. But there are combinators outside of combinatory logic combinators. If you've ever heard of parser combinators, that's something completely different. But that's because a combinator, all a combinator is it's a function that deals only in its arguments. It doesn't necessarily mean that it has to be a combinatory logic combinator. However, the K and I in the SKI actually aren't function-only functions. They are combinatory logic combinators, but K and I, which we're going to look at in a second, they don't necessarily need to take a function as an argument. And therefore, it doesn't qualify as a higher order function. So we have to put it outside the yellow circle. And then so finally, we're only missing the function-only functions, and that is the final pink circle. It's these combinators from combinatory logic combinators that only take as arguments functions and only return you a function. So it's a function that deals only in functions. You don't pass it any data, all your arguments have to be functions, and the return type has to be a function. And you might be thinking this is kind of confusing, but once we look at a couple examples, which we're going to look at in this sec, it'll hopefully start to make a lot of sense. So like I said, this isn't like, you don't need to actually understand this diagram, but it is helpful if at the end of the talk you think back to this, this sort of taxonomy or categorization. So we're done with this. And technically, this is more accurate. You know, there is no such thing as a function-only function that's not a higher order function. So that yellow without the pink, you know, really it should not be a circle. It should be whatever, you know, we should get rid of that area. But, you know, this is good enough. So let's, you know, recap. Combinator, a function that deals only in its arguments. A combinatorial logic combinator, that's just a combinator from combinatorial logic. Function-only function, all its arguments are functions, and its return type is a function. Where you contrast that with a higher order function at the bottom, it has either or. It's either it takes a function as an argument or returns a function, and then a pure function, same input, so same output. So, combinators. I've been talking all about combinators. You're probably thinking, what the heck is a combinator? Let's look at a couple. So, in the 1958 textbook written by Haskell Curry called Combinatorial Logic, he defined the 5 elementary combinators and gave them pretty awesome names. The elementary identificator, the elementary permuter, the duplicator, the compositor, and the cancellator. So this is I, C, W, B, and K. And we're going to look at I first because it's the simplest. It's just a function that you return what it's given. The first time I saw this, I was like, what? That does absolutely nothing. How is this useful for anything? But then I also saw that in C++20, they actually added this, stood identity, and a lot of functional languages have this. Haskell calls it id. Clojure calls it identity. It is useful when you start trying to do these different composition techniques. So I just returns you what it's given. The next combinator, K. This is known as the cancellator because it discards the second argument. K is a binary function. It takes 2 arguments, and it gets rid of the second one. Once again, you might be thinking, why is this useful? But it comes in handy. Next up is, I think, the first interesting combinator, and it's the W combinator. So it takes as an argument f, which is a binary function, binary meaning it takes 2 arguments, and it basically turns that into a unary function, a function that takes 1 argument. And it does that by passing that single argument twice to the original binary function. So if you imagine f, we take a binary function, for example, as plus, adding numbers together. That takes 2 arguments. If you pass plus to the W combinator, that now becomes a function that you could call double because it's passing the same argument twice, so you're just doubling whatever number that's given. So here is, I believe, a small digression, which is that you're going to hear me use the words binary and unary, and then also sometimes I will interchange between monadic and dyadic. And this has nothing to do with monads. There are basically 2 different ways, Latin and Greek, to refer to the number of arguments a function takes. And these 2 things are called arity and adicity. And I think arity is the Latin one, and for 0 arguments it's nullary, and then 1 is unary, 2 is binary, 3 is ternary, and 4 is quaternary. But then on the Greek side of things, they refer to arity as adicity, and then you have nilladic, monadic, dyadic, triadic, and tetradic. So this is a bit confusing because we got 2 different ways of referring to things. And actually, the very first time I started watching talks online, like years ago, in C++, they have functions in the algorithm header where they take, like, the argument is a template type, and it's called binary operation. And I was always confused because binary to me meant, you know, 1s and 0s, you know, binary arithmetic. I didn't realize it was referring to an operation that takes 2 arguments. So anyways, in case you're confused when I say binary, unary, monadic, dyadic, that's what this means. So moving along, this is the W combinator. So once again, f, a binary function that then returns you, W returns you a unary function. Very useful. Next combinator is B. So this is what most people think of as function composition. So B is a binary function that takes 2 arguments f and g that are both unary functions. And then it just composes them one after another. It applies g to your argument first, and then applies f after. So this is the dot in Haskell. And you can get this with the pipeline operator in F#, kind of. And this is what most people think of as function composition. Next up is C. This is known as flip in Haskell. I'm not sure if F# has this, but basically what it does is C is a unary function that takes a single argument, that is f, which is a binary function, and it just switches or swaps the order of the arguments that you're passing to it. So for an associative function like plus, this doesn't matter because it doesn't matter the order you pass it to. But for a non-associative function like minus, you have to sometimes the order that you pass, 10 minus 5, 5 minus 10 don't give you the same answer, whereas 10 plus 5, 5 plus 10 do. So this comes in super handy when you're dealing with binary operations. And last but not least, of the elementary combinators is the S combinator. So this is where things start to get a little confusing. So S is a binary function that takes two function arguments, f and g. F is binary, and g is unary. You apply g to your single argument x, and that gives you a result. And then you take that with your initial argument x, and you now have two things, g of x, and you pass that to your binary function s. So a little confusing, but this is actually extremely useful. And there's a reason that S is one of the three combinators in the SKI combinator calculus, because it's actually one of the most important ones. So I've gone through all of the elementary combinators, but there's a bunch more. And we're going to look at these via example, because honestly, I think that when you're showing these in a talk, it's a bit hard to show why these are useful in the abstract. It's easy for me to go through these and describe them, but what's the utility in these? Why are these useful? It's much easier to understand why these are useful when you look at an example. So yeah, there's actually a couple extra off of this. I'll provide some links if you want to go look at them all, but these are the ones that we're going to talk about. So let's get to the example. This is kind of the most interesting part of the talk, and I think we're doing great on time. So this is an example from a LeetCode contest. I think it was like a month ago. It's called Special Array. And it's a pretty simple problem, but it's great for sort of solving these in different languages. And we're going to solve it in 10 languages. Originally, I solved it in 8, but I added F# and C# for the NDC crowd. So what is this problem? It is called Special Array 1. And it states you're given an array of integers, and it's considered special if every pair of adjacent elements contain two numbers with different parity. Parity meaning, is it even or is it odd? So basically, you want to have alternating numbers where it's odd, even, or even, odd, even, odd. You don't ever want to have two consecutive elements that are both even or both odd. It's a pretty straightforward problem. And I think first we're going to look at a simple example, which we're going to use. So 4, 3, 1, 6, four numbers. The first thing we want to do is kind of group these by 2. So we've got 4, 3 are the first two adjacent, then 3, 1, then 1, 6. Then we want to check whether they're even or odd. So in array languages, you represent true and false by 1s and 0s. So 0 represents even here, 1 represents odd. And then we want to check, do none of these equal each other? So we want these to all not equal their sibling. And so for the first and the last one, they don't equal each other, but for the middle one, it does. So you're going to end up with 1, 0, 1, because the first and last are not equal, but the middle two are. And then we're just going to do like an all reduction because we want all of these to be true. We want all of these to be 1. But in this case, because we have a 0, your answer ends up being false or 0. So hopefully that makes sense. Now we're going to go through, initially, like I said, 8 different languages, but we've actually added, I've added F# and C#. I just did this a couple hours ago because I figured, we're at the NDC conference, why not? But first, we're going to start with Python. So Python only has functions when it comes to function composition. And first, we're just going to solve this, maybe how I would have solved this when I started learning Python in university like a decade ago, or a decade plus, I guess. So simple for loop, and we're creating a range of integers, one less than the length of our integer list nums. And then we're checking for each of our pairs, so nums I and nums I plus 1. Then we're doing modulus 2 to get the parity. And we want to check that if these are equal, we short circuit and return false. And if we make it to the end of our loop without ever returning false, you just return true. I really don't like this code, but like I said, this is how I probably would have solved it a decade plus ago when I was first learning how to program. So, any suggestions on something that we could do to simplify this? No suggestions? Well, the first thing I would do is get rid of the index. Having to index into these two things, I and I plus 1, I really don't like that. So you can make use of a function called zip in Python. And if we zip the initial list with the tail of the list, so the 1 colon in the brackets is basically a slice of our initial list, which drops the first element. So it starts your sub list or your slice at the second element, 1. And then this gives us a basically zipped pair of tuples, which are the adjacent elements next to each other. And so we can destructure those x and y, and now I don't need to index into anything. So still not amazing, but nicer than what we had before. The next thing we can do is put this into a generator expression. So now because we don't have the indices, we can actually just put this destructuring for loop into a generator expression, and then instead of returning false and true, this is basically just a reduction all that's going to check to make sure that none of these are equal to each other. And note that we had to change our binary operation. Initially, we were checking if they were equal, then we were returning false. But now, we are checking, we want all of them to be not equal. Technically, there's a function in Python called none, but I think it's easier to read that we want to see that all of them are not equal, that none of them are equal. But that's just kind of my personal preference. So at this point, this is where we're going to look at some C# and F# code. And I got to be honest, I did this a couple hours ago. You know, don't tell Richard, but I did it while I was in his talk. And I didn't want to write it myself, so I just went and asked ChatGPT. Technically, I think it's GPT-4o. You get a couple of free questions. I managed to do this in like, a couple questions. So I just copy and pasted this code and said, GPT-4o, could you convert this to C#? And this is what it gave me. Pretty ugly. Pretty worse than worse than this Python code. But that's there's one big change we can make here to make it nicer, and that's the following. We just move those braces over there. Now this is much nicer code in my opinion. Still not at all what I wanted. So like I said, I'm not a C# expert, but I know that if you want to do something in the functional style in C#, you reach for link. So I went back to GPT-4o and I said, thank you, this is very nice, but could you make it more functional and use link? And when it did that, it gave me the following, and this is much closer to what I was looking for. So you can see the zip that we had in Python, the 1: slicing that we were doing, you get with nums.skip1. It's basically dropping one element. And then when we zip nums with that sort of tail of nums, we then can apply some binary operation that's doing the modulus not equal to, and then we have this all function. A little bit irritating, but really this result, arrow result, that is the I combinator. If we had something where we could, in Haskell, it's just called ID, we could just pass ID right there. We just want a function that returns you what it's passed, because when we perform the zip, we're going to end up with a list of trues and falses. And clearly what the link all function does is it checks for some condition, do all of these satisfy the predicate. But we already have a list of trues and falses. We don't need to apply a predicate. We just need to apply the identity function. So this is pretty nice. I think that's the extent of the C# code. But then I asked it, great, can you do it for F#? And it nailed F# on the first try, because there is no imperative looping solutions in F#. It's a functional language. And pairwise does the zipping for you. Nice that we have a built-in function. So that zip tail trick, that's just called pairwise in F#. And then we just do this array for all, very similar to what we had in the link code, and pretty nice. So NDC.NET, we got some F# and some C# in the slide deck. Back to the Python code. So now we have this generator expression with a zip, we're destructuring. But when I see this code, I think to myself, that's a combinator. Because what we have here is not equal. That's a binary operation that takes 2 arguments. And we're applying that binary operation after applying the same unary operation to 2 different arguments, the modulus 2. And so we can convert this to use something called the psi combinator, where we apply a unary operation to 2 arguments first, and then take the results of those and pass them along to a binary function. So in operator module, they have a not equal function that is NE. And then in this dove key library that I've written that provides you a bunch of these combinators, we've got odd, which is a unary function, and then psi, which is a psi combinator. So the psi combinator, to be explicit here, is a binary function that takes 2 function arguments, f and g. G is unary, and f is binary. You apply g to 2 different arguments, in this case odd, and then once you have the result of that, you pass the 2 results to the binary function f. And by using this psi function, we can get back to this code. So this, I think, is actually worse than the previous solution, but that's because we're destructuring the x and y and then passing it to the function we formed by passing not equal and odd to psi. But we don't actually need to do this. The map in Python is very attic, so we can get rid of the x and y and the destructuring and just replace this with a map that's mapping over two lists, the nums and the nums1 colon, the pairwise that we had from F#, and then we can just pass this function that's returned by psi. And this, I think, is actually quite nice if you compare it to where we started it with the for loop returning true, returning false. So this is Python. We're going to come back to Python at the end, but I think we're going to move on now to Haskell. And Haskell's Haskell. I mean, I love Haskell. At one point, it was my favorite language, but it's a bit confusing, and you're going to see why. So this is the equivalent of the code that we just saw in Python. So map odd, that makes sense. You're just mapping odd over your list of integers. Fold 1 ampersand ampersand, that's just the equivalent of our all in Python, or our for all in F#. But what is this zip width not equal to angle star angle tail? So if we go back, and also make note of the 2 dots, if we go back to our little combinator table, and we look at the Haskell column at the very end, the dot is the B combinator. And the angle star angle is the S combinator. So remember that function, that combinator S that takes a binary function and a unary function? And I said, oh, it's kind of confusing, but it comes in useful. Well, we're using it right here. So if we come back and we just focus on the zip width not equal to angle star angle tail, that's the S combinator. So tail is our unary function, and zip width not equal to is our binary function. And so basically, this is a way of spelling what pairwise did in F#. It's zipping the initial list with its tail, and then it's going to apply a binary operation. The operation that we're applying here is the not equal to. That's that slash equals. For some reason, Haskell spells their not equal to different from every other language. Although, so does F#. If we want to be, F# uses, angle, angle. It's upsetting when there is disagreement across languages on operators. We all agreed on what plus was, but when it comes to exponents, not equal to, every language had a different decision. So that's basically what zip width not equal to S combinator tail's doing. However, even though it's cool that you can spell it this way, we can avoid this by making use of a function similar to pairwise that we had in F#, but it's slightly different. Pairwise just does the zipping action for us, but map_adjacent here, it bundles a binary operation with it and then applies that binary operation to the zipped elements at the same time. And in my opinion, this is actually really, really nice code. Like the zip width not equal to S combinator tail, I think that's elegant, but it's hard to parse. This, however, is much easier to parse. We're mapping odd, mapping adjacent elements, applying not equal to, and doing fold 1 ampersand ampersand. And luckily, the fold 1 ampersand ampersand, we actually have a nicer way to spell this in Haskell, and that's and, which I think is unfortunate because this is the equivalent of all in Python, but for some reason they decided to call it and in Haskell. And all is a different function. So all does exist, but it does something different. And yes, so this is our final Haskell solution, except it's not. We used the psi combinator before in the Python code. Can we use the psi combinator here? We're mapping a unary function odd, and then we're mapping adjacent a binary function not equal to. That's the psi combinator. And in Haskell, they call the psi combinator on. So we can actually compose these two things, which is saying take 2 elements, adjacent elements at a time, and first apply odd to each of your adjacent elements, and then apply your binary operation. And in my opinion, this is extremely elegant code. Still a little bit hard to read if you're not familiar with Haskell, but compared to what we started with, the zip tail with the S combinator, this is really nice. So I think up next we have, we're going to revisit. So what if we had the map adjacent in Python? So this is where we ended with the Python code. But if we make a little room, add a map adjacent, how does this change? Well, we get rid of our map, replace that with a map adjacent, and then we can get rid of the nums and the nums bracket 1 colon, and just pass nums once. And now once again, I think this is more readable code. You still have to have access to this, and unfortunately, Python does not have a adjacent map in a library anywhere. But still pretty easy to write. And note that pairwise is the exact function that we had in F#. You have to find this in a library called itertools, but it exists. It just zips with your basically sibling, your adjacent elements 2 at a time. So I think at this point, and I think, the point that I'm making here is we don't even need to use the psi combinator at this point because adjacent map takes a binary operation. We're forming a binary operation here, but if you wanted to, this might be more idiomatic in Python code. Just use a map your odd over nums, and then pass that as the first argument to adjacent map, and then the binary operation you pass to adjacent map is the not equal to. So once again, we're going to come back to Python, but we're going to keep moving. So Closure. Here, we have functions and operators. We already looked at F#, so we're going to go through this really quickly. This basically is something called the thread last macro. It's also referred to as a thrush operator. It's similar to what the pipeline operator or the pipe forward operator in F# does. It basically just passes your argument along to the next operation. In this case, it's passing it as the last argument to each of your operations. So partition does your kind of creating a list of two adjacent elements. The map is performing the not equals to, and then the every at the bottom is the equivalent of the all in C#. Once again, it wants a predicate in order to check, do all of my elements in my list satisfy this predicate? But at this point, we have trues and falses, so once again, we can use the I combinator. In this case, we actually have the I combinator in closure, and it's called identity. Here's an alternative closure solution where it's just basically combining the last two into one and using a slightly different syntax. This way we can avoid using the I combinator if we want. It's your preference which you like more, but anyways. Closure, similar to F# in some regards. And with that, we are now going to move on to my favorite part of the talk, which is all of the array languages. So APL, BQN, J, and CAP. And all of these languages have operators, but they also have trains. Technically, you could write functions if you wanted to do function composition, but that's not the idiomatic way to use these languages. So first things first, trains, what are trains? Trains are basically just the juxtaposition, they putting side by side of functions. So when you put two functions next to each other in APL, that forms a two train. And when you put three functions next to each other, that forms a three train. And you can continuously do this so that when you form a three train, that'll then form a function, which is probably going to be unary, or at least it will be in the cases we look at. And then we can continue to build up these longer trains, which we'll see when we do this by example. So J was the first array language to add these trains, and they did it in 1990. And for the two trains, they chose S and D. And for the three trains, they chose phi and phi1. At a certain point in 2014, Dialog APL, they're the sort of main company that implements an APL these days, they decided to add trains because J did, but they switched the S and D to the B and B1 because they realized that those were better choices for reasons I'm not going to get into. And then since then, CAP and BQN have made the same decision. Note, though, that CAP did not add the three train, which is incredibly interesting. It is opaque now, but once we get to the live coding, you will see why it makes a difference. If we look at these for the ones that correspond to the two trains and three trains, we can hide them. We've got S, B, D, B1, and phi. And if we get rid of S and D and add phi1, in the modern APLs, sort of excluding J, this is what we have. So the first two, B and B1, are the two trains, and then phi and phi1 are the three trains. So B we've already looked at. B1 is just basically an extension of B, where instead of applying a unary operation after a unary operation, you're applying a unary operation after a binary operation. Super useful. And then phi and phi1, these get a little bit more confusing, but we're going to see them in examples and they'll make more sense. But basically, phi, you have a binary function and two unary functions. So it's similar to psi, where we applied a unary operation to two different arguments, and then the binary operation afterwards. Phi, it has two different unary operations and applies them to the same argument. Then you have two results, and you pass those along to the binary operation. And the phi1 has the same pattern, but instead of applying it to a single argument, it applies the f and h to two arguments. So I believe this brings us to the live coding portion of this talk. Hopefully the internet's working, because this is all going to be done in the browser. So everything you see now, you guys can go and try later after the talk, or if you want to whip out your laptop right now. You could technically even do this on your cell phone, because you can just go tap those symbols, and the solutions are so short, as you're about to see, it's actually not that hard. You know, you don't want to go code C# on your cell phone, but for array languages, it's actually possible. So this is tryapl.org, and this is how you create a list. Maybe I should make this no, we'll keep it at this size because that was terrible. This is a list of 4 numbers, so that's what we're going to work with. The first thing we want to do is we want to check if these are even or odd. So this 2 pipe is how you do 2 modulus. So the %2 in Python, you spell by 2 pipe, and we do this, it's basically going to return 0 if it's even and 1 if it's odd. So 2 characters, we're like halfway there. Next thing we want to do is we want to take 2 adjacent elements at a time. So there's an operation in APL called an n-wise reduction, where you specify n, the number of elements you want to look at a time, and then it creates you sublists of that length n, and then creates like a sliding window. So if we want a adjacent elements, we can basically do 2 catenate, which will form you a list, and then the reduce is the slash. And so when we hit this, it's going to give us basically the first 2 elements, then it's going to slide by 1, give you the next 2 elements, and then slide by 1 and give you the last 2 elements. But what's amazing about this n-wise reduction is you can replace this operation with any binary operation you want. So in our case, we want not equal to, so we just replace this with a not equal to, hit enter, and I have to delete the catenate in order for that to work. And then we get our 101. And you can do this with any binary operation. So if we were solving a different problem and we wanted to put a plus there, if we wanted to put a divides there, a domain error because you can't divide by 0. If we did this, though, it would work. Anyways, pretty cool. So let's go back to our not equals and 2 modulus. We got to type the 2 modulus. And so after this, all we want to do is an and reduction, which is just 2 characters. That's and as we saw before, this is reduce. And that is our full solution there. Pretty fantastic. We all want to switch to APL, right? So now let's switch over to the other APL, CAP. And so this is basically an APL-inspired language, but it makes a few different decisions. The main one here is that they don't have a 3 train. And actually, let's quickly back, because we didn't actually solve this tacitly. So here we've built up just an expression that's going to evaluate eagerly. Oh, the screen disappeared. All right, don't touch the computer too hard. If we try to evaluate this, though, it doesn't start with a 3 train, so we're going to get a syntax error. So in order to get this to evaluate correctly, we need to add an identity here. So what this is going to do is then this is going to correctly form us a 3 train, which is going to be the phi. This will form another 3 train, and then this will be our final 2 train, which is a B combinator. So this will parse. Actually, what? If we type this correctly. So this will parse correctly, but keep this in mind. We had to make this slight change in order to get this to work. So let's do this a lot quicker for CAP. So we've already seen this. 4316 is our initial list. Then we want to do even or odd. That's 2 modulus. Then we want to do our n-wise reduction. So here we're going to do catenate once again just to show the 2 pairs that are forming. And then we're going to replace that with the not equal to get our 1s and 0s. And then last but not least, we're going to do our and reduction. If I can type this properly. So, same thing we just saw, but in this case, we don't have the 3 train. So what's going to happen when I parenthesize this to turn it into a point-free tacit expression is that this is going to form a unary function because of something called left-bound functions. This is going to form a unary function because of something called left-bound functions. And this is already a unary function. So we just have 3 unary functions next to each other, which is just going to be 2 B combinators after each other. So when we evaluate this, we get the same result, which this is really, really nice because in Dialog APL, we had to make a change in order to actually form a point-free function, whereas in CAP, we don't need to do that. All right, switching back here, we're going to go to BQN. So BQN is a modern APL that has slightly different glyphs. It was actually supposed to be APL plus 1 for each of the characters. A plus 1 is B, P plus 1 is Q. But then they messed up the N, because L plus 1 is M, not N. So it's actually, the joke is now that BQN is APL plus Fibonacci, if you're familiar with that sequence. Anyways, this is similar. So we've got 2 modulus, and that gives us, so we've got 2 different test cases, one that's going to pass and one that's going to fail. And unfortunately, we don't have the n-wise reduction in BQN. So the thing we have to do here is we have to use a function here called windows, and that basically turns it's similar to the m-wise reduction, but it gives you a matrix of 2 elements at a time. And you can do this for the same thing, like 2, 3, 4. And after this, we want to do a basically not equal to reduction over. So let's see if we can type this correctly. Actually, let's do it this way. Not equal. For some reason, this is where is not equal? Well, this is not, let's see if we can copy it from over here. There we go. Not equal, and then we need to do this with cells. So that should give us what we're looking for. And now we want to do our AND reduction. Unfortunately, this isn't going to work now. So this should give us our right answer, but what we have here is a 3 train, followed by another 3 train, followed by a unary function, which is going to be the B combinator. And you can't have 2 unary functions in a row, so you have to do this trick, which is add this thing called nothing, which basically it breaks after your single unary function, and then enables you to call another unary function and still form the B combinator. So a little bit unfortunate that we have to do that. And last but not least is J. So J is an array language. It was Ken Iverson's second array language. He did APL in the 1960s, and then he did J in the 1990s. And it was basically just APL, but using ASCII symbols. So you can type it without all the special characters. So once again, 4316 is our list of numbers. Then we can do 2 modulus. So the pipe actually exists on our keyboard, so that stays the same. And then you get our list of 1s and 0s. Then we can do our n-wise reduction. Oh, it's pretty flaky. Oh, we're back. We can do our n-wise reduction as so. So this is the equivalent of our catenate. But if we change this to not equals to, which so not equals to does not exist on your keyboard. So you spell that with a squiggle, colon, and then you have to put that with a reduction. So that gives us our 1s and 0s. And then you want to do an AND reduction. Once again, the AND doesn't exist on our keyboard, so you spell that with an ampersand or asterisk dot and then slash for the reduction, which is going to work once again. So in order to make this point free, we have to put this thing called cap, and then we'll space this out so it's a little bit more legible. And if we do this, then we are able to parse correctly because we have a 3 train followed by another 3 train followed by a unary function, but because they chose the 2 train to be the S combinator, we don't want the S combinator right now. We want the B combinator. So you have to use the cap in order to turn the S into the B, which we're going to talk about a little bit later. So that got us through the first portion of our live coding. The next language that we're going to look at is Jelly. So Jelly, like I said, was a language designed to be a code golfing language. And it doesn't have trains. It has something that is called chains, which is similar to this idea of trains that you put functions next to each other, and then it forms some kind of composition pattern. But the way that they do it is they don't hard code, 3 trains as phi and phi1 and 2 trains as B and B1. They basically just have a pattern matching table, a list of you look at the arities of your function. If you have 2, 1, 1, that's the D2 combinator. If you have 1, 2, 1, that's the phi combinator. So you just, and one of the reasons it's able to do this is that in APL, BQN, CAP, and J, all of their functions are ambivalent, which means that they have 2 definitions. The easiest one to think about is the minus sign. Minus is subtraction in the dyadic case where you have 2 arguments, and it's negation in the case where you only have a single argument. But they took that, that exists in mathematics for the minus operation, and they did that for every symbol. So, maximum is both maximum when you're given it 2 numbers, and its ceiling to go to the closest integer, or the rounding up when you have a single integer. And so, because of this ambivalence, every function has both a unary definition and a binary definition, which means you can only do so much in terms of pattern matching. Whereas Jelly, every function is fixed. Its arity is fixed. So you're able to do more. So we're going to look at this example. It's easier if I don't live code this and then just show this one by one. So we've got a simple example, 416. If we want to check are these odds, this is the Jello tool. So the Jelly is the yellow B over dot. But that means nothing to me. And so Jello is a tool that I wrote that basically I can type in keywords and it does the conversion behind the scenes to the Jelly interpreter. So odd is odd question mark. That's my Jello keyword that I've added. But the actual Jelly is the yellow code. So now we've got our list of 0s and 1s for odd. We want to check are the adjacent elements not equal to each other. And we do that. We actually have a built-in function in Jelly that I've called differ, which basically checks to see are the adjacent elements different from each other. And in Jelly, this is a D accent caron. Because that's how they get away with, I think the person that made this is Spanish, and so they've got all these underdots, overdots, accents, and that's how they spelt their language. Yes, I saw someone put their hands up like, what are we doing? Remember, the goal of this language was to code golf. It's not to be readable. In fact, they added something that actually like compresses these symbols. Like if it has a string, it can compress it into absolute nonsense, but like save bytes of code. Anyways, it's if you think this is bad, you should see some of the other parts of the language. And last but not least, we want to just do an all reduction, which we call all here. And so that is our final solution in Jelly, the B overdot, D accent caron, A underdot, 3 letters. But what's interesting about this is that where is the function composition? Well, the pattern matching engine in this case says whenever we have a series of unary functions where the arity is 1, 1, 1, 1, 1, you just continue to apply the B combinator. You just apply the function after the last function was applied. And so I have a tool here that actually shows you, this is a super simple arity chain, where your arity chain is just 1, 1, 1. But this shows you that it's the B combinator, and then after that it's the B combinator. But this will do it for all different types of combinators, the S combinator, phi 1, etc. So very cool tool if you want to go play. And this idea of function composition by chains, just look at the pattern matching of the arity chains that are formed by the juxtaposition of your functions is a really, really interesting idea. So this is, because I built this tool, I built a bunch of stuff into it. So you've noticed that across these solutions, when we were in Haskell, we started with fold L1, ampersand, ampersand. But you can actually spell and. You can do this in Jello just by basically typing whatever you think, and anytime it notices that you could use a different algorithm, so differ, for instance, you could spell that with a not equal to prior. Prior is what they call map adjacent or what I call map adjacent in Jello. But if you type that, the algorithm advisor will just say, hey, just use differ here. Or if you use an and fold to do an all reduction, it'll say, hey, you can just use all instead of that. And you can note at the bottom too, one of the reasons I showed this is it just shows you that you can see a different arity chain here. You've got 1, 2, Q, 2, Q. All right, I think this brings us to our last language that we're going to look at, which is Wiwa. And so this uses operators plus stacks. So like I said, stacks kind of had an asterisk before because this isn't actually corresponding to the S combinator or the B combinator, but you get a lot of this stuff for free. So let's hop back to our browser, go to the Wiwa tab. And so once again, this is just another online editor that you can use, and we're going to build this up. So the first thing we're going to do is, once again, our modulus 2. So one of the interesting things, if I can type this correctly, is that all the other languages, I had to memorize keyboard shortcuts. And I just code in these languages enough that I kind of know them all, except for the case of BQN when I couldn't type the not equal to symbol. But here, we just type the start of the name of our function that we want. So here we want modulus. And as soon as the prefix of that function that you want turns a certain color, this turned blue, you can then just hit Control-Enter, and it converts that prefix string, the name of your symbol, into the symbol. So I actually don't need to memorize any of these keyboard shortcuts. And because of that, this language has actually gotten, in the array language space, quite popular quite quickly. This was only released in September of 2023. And anyway, so that's how you do 2 modulus. Once again, we don't have the n-wise reduction in Wiwa. We have to do the Windows trick. So if we do win for Windows 2, this is going to give a matrix where each row is 2 elements at a time, and then you move one by one. And then we want to do our not equal to reduction here. So we're going to do rows slash and then not equal to. Hit Control-Enter. It's going to turn these all into symbols. And then this does our sort of not equal to reductions across each of our rows. And then last but not least, we're going to do our all reduction, which you spell in Wiwa slash and then min, and then we're done. But once again, similar to the Jelly code, it's not apparent if there's any composition here, and there's not really. You can think of some of this as just kind of unary function composition, but the way that stack languages works are they just apply whatever function is at the top of the stack to the arguments that are on the argument stack. And anyways, it's food for thought because this is, this Wiwa language was inspired by BQN, but it gets a lot of the same functionality without actually having to reach for these combinators, which might be a good thing. So that is the Wiwa code, and that brings us to the summary of these 6 languages. And I sort of want to go through, once again, these different train models, chain models, stack models. So in the cap code at the top, we start off by forming a unary function. So this is just something in cap. Whenever you have a binary function with an argument on the left, that's called a left-bound function, and that just forms your unary function. And we get the same thing with the 2 not equal to slash, the 2i's reduction. And so we have a unary function followed by a unary function. And this is just the B combinator. And then the AND reduction, or just all, that's another unary function. So this is just the B combinator. So 2 B combinators because we have 3 unary functions in a row. And this is made possible by the fact that there's no 3 train. Whenever you have a 3 train, that AND would then want to interpret that the 2 equals 2 as a 3 train, and it's not going to work. So, or you need to put like the identity at the beginning, which then forms a 3 train, another 3 train, and then a B combinator, which is what you have to do with dialog APL. So this, I think, is actually a nicer model than the dialog APL one. In the second example, we start off with a 3 train. So that's the phi combinator. And then that forms a unary function, which with the 2 not equal to slash forms another 3 train, the phi combinator. And then the AND reduction is a unary function, so that's the B combinator. So this is almost identical to the cap code, but it's a lot more confusing in my opinion to understand. And that's because it has 3 trains. Weewa we just covered, and as I mentioned, like unary function, or it's technically the application of a partially applied binary function, which is a unary function, but you know, potato, potato. No one says potato, but and Windows 2, once again, another partially applied binary function, and then this is a unary function applied. This is a unary function applied, but like we don't need to use any combinators to get this kind of composition for free. So it's interesting. And note that because we've got the blue here, we need that because there's no n-wise reduction. So one of the points of this talk too is the algorithms that you're able to reach for and use affect the combinators that you need to use. BQN. Similar to dialog APL, we start off with a 3 train, which is a phi combinator, then another 3 train, which is the phi combinator. But in this case, because once again we don't have the n-wise reduction, we need to reach for the not equals to row-wise reduction, but that's a unary function, so this is a B combinator. But now, because we have a B combinator, you can never get 2 B combinators in a row without using something to disambiguate. So we have to put a B combinator here, but that nothing, we got this little devil emoji, this, in my opinion, I'm glad that BQN has it. It's just unfortunate that BQN has to have it in the times when you want to do stuff like this. The J code, 3 train, phi combinator, 3 train, phi combinator, 2 train, B combinator. But once again, we have to use this cap thing for a different reason than in BQN. BQN, we needed it because we had 2 B combinators in a row. In J, we needed it because the 2 train is not the B combinator. It's the S combinator. And so they have this thing called cap, which turns a 2 train from being S to B, which this is extremely confusing in my opinion. The fact that you have a special token to change the meaning of a train. Trains already are confusing, but the fact that you have a token that can change the 2 train from an S to a B, and I also think it's incredibly hard to read. I mean, most of you are probably thinking all of this is incredibly hard to read. But I think the fact that J uses multiple ASCII symbols. At least the other languages, they use single symbols to represent functions. But here you need to know that the asterisk dot, that represents and. You need to memorize basically when symbols end, which is, it's just extra things to learn. And then last but not least, the only language that reads left to right of these 6 is Jelly and Jello. So odd, unary function, differ, unary function, B combinator, all, unary function, B combinator. So similar to cap, just the opposite direction. And obviously the thing you can note about the Jello code is that this semantically it's identical to, other than the Weewa and BQN solutions, it's identical to what the other code is doing. But it's incredibly readable and really, really nice in my opinion. So this is a summary of across all the languages that we've looked at, which ones have access to which function composition strategies. And I think that brings us to the sort of conclusion of our talk, which is, look at that, doing great for time. I think this code is incredibly beautiful. However, beautiful code is a subjective thing. One person can look at the initial Python code and they say, oh, I prefer for loops and if statements. I think that's the most beautiful readable code because I don't need to learn anything extra. I don't need to go learn what's in the itertools library. Some C# developers would say that their code is more beautiful than the F# because of the same reason. I can understand for loops and if statements. I love this code. It speaks to me, but it is the essence of what I'm after. A lot of other languages require a bunch of ceremony, whereas these do not. And a lot of that is because of the function composition strategies that you have access to in these languages. One of my podcasts, it has the title Algorithms plus Data Structures equals Programs. This is a Nicholas Wirth book that was written. It's actually taught, the book teaches in Pascal. But in array languages, there's really only one data structure, and that's the array. There's no hash maps, there's no sets, it's just the arrays, and you can represent sort of the different data structures using this. So I'm starting to, my opinion of the title of this book, it's really scratch out the data structures and replace that with combinators, and scratch out the programs and replace that with beautiful code. And so the question is if you're in a language that has access to different data structures, what if you add the combinators, though? You can get even more elegant code, in my opinion. Like I said, we started off with this. Hopefully, you understand a little bit more of this. But the point is on your free time, if you want, go and check these out. Not because I want you to switch to programming in APL, but take these, compositions other than just the B combinator and see how you can fold those into your language. We've been coming back to the Python solution over and over again. We left it at this adjacent map, which we borrowed from Haskell. But what if we borrowed the differ, which was in Jelly? What do we end up with? We no longer have any combinators here, which is what I mentioned earlier. The algorithms that you have at your disposal, the things that you can reach for in libraries, affect the code that you can write. And a lot of the discovery of these types of algorithms come from my exploration of these languages and learning about the combination or the composition strategies. And if you look at this compared to what we had in the very beginning, I found it very hard to for anyone to argue that this isn't a simpler, more elegant. Sure, I need to know what differ means, but that's basically the only thing here that's not in your basic, idiomatic Python. Everyone in Python knows what a map is. They know what all is. I guess odd, but I think everyone knows what odd means technically. So be curious. Go and try and learn these languages. And on top of this, you might be thinking, why is a person from NVIDIA giving this talk? I do it because I'm really interested in these array languages. But differ and map, they're both maps. Differ is just an adjacent map, which can be implemented using a map. All, that's just a reduction. Reductions and maps, map reduce, heard of that? GPUs eat this stuff for breakfast. The for loop that we had in Python originally, it's hard to accelerate that kind of code. You can do it, but it's so much easier to accelerate this kind of code. And that's why CuPy exists. It's a CUDA accelerated NumPy, because NumPy is just a bunch of operations. And if you can go accelerate all these operations, it's so much easier to basically get accelerated code. So the point being is that there is actually some utility other than just, oh, look, I can write my code a lot shorter by having access to this different stuff. You can implement this stuff a lot faster at the end of the day. So last but not least, if you want to go try these languages out, as I mentioned, all of that stuff was in the browser. You can find this, the same content GitHub repository where I listed all my talks and podcasts. You can find the slide deck and links to all of this stuff if you want to go check this stuff out. If you don't want to go check that out and you are in one of these two languages, I have two different libraries that basically implement a lot of these combinators. I use them basically in all of my personal projects because whenever I have to write a Lambda that's doing some simple thing, a lot of the times there's a combinator for that. And with that, I will say head over to combinatorylogic.com to learn more, and thank you for your time. I'll be around for the rest of the conference if folks want to come and talk to me, because yeah.
Is it? Hello. Um, Thank you all for coming. If any of you were here yesterday and saw me struggle with some technical difficulties and came here today to see me struggle with the same technical difficulties, I'm sorry. We made it work. So I'm Tess. I work at Microsoft, and I've been working with LLMs for about the last year or so. And I'm sure that most of you probably have used an LLM. Everyone? Yeah, I would guess like at least 99% or something. And you probably know that LLMs are very good. By the way, the subtitle of this, if you don't know why you're here, is Ragging on RAG. We're going to be talking about RAGs. If you don't know what a RAG is, you'll be acutely aware after this session. If you don't know what ragging is, you'll also be very aware after this session what that means. But we all know that LLMs are very, very good at summarizing things, like summarizing a paper, or generating a story. So in this case, generating a story about a dog that gets on with a zebra and appropriate for age 5. Because this is what language models do. This is what language models have done before they were called large language models. They were kind of predicting the next word to put together in a sentence to make the sentence look good, and generally working with text. But they're not all that good at data. So when I ask it a question like, what are my hobbies, which it won't know because I haven't publicized them on the internet, it will make up a story, both about who I am and what my hobbies, or that it doesn't know my hobbies. But it will sometimes fabricate a little bit weirdly. So in this case, it says that I'm a Microsoft MVP, which I'm not. I worked at Microsoft for the last 25 years. But this is not a huge oversight. I mean, an MVP versus an employee is not that big. But I tried to ask it again, and it came up with this. Tess Ferrandes, who is a Microsoft employee and a software developer, passed away in 2014. So this startled me a little bit, actually, when I read it. I will say the reports of my death have been greatly exaggerated. I might have stopped blogging. Maybe that was my problem. But I'm very much here, and this is not a hologram. So obviously, it can come up with both things that are not correct and maybe also not very tonally correct. And also, if we give an example of math, and this is like a classic thing that everyone tries, give it some math problem. If you give it 1 + 1, it will obviously know, because statistically in the data that it has been trained on, that shows up a lot. But this random number that I'm putting, not so random actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, but this random number, it will just answer confidently that this is the product, but actually it's not. Close, but no cigar. And this is a little bit a problem of LLMs in general, that they are not actually proper databases. It's not like we're actually extracting facts from them. We're extracting, or we're predicting the next word that could come out that may or may not be factually correct. In reality, an LLM is a probabilistic database. And if you've never seen a probabilistic database before, this is about how they work. So let's say we have a list of companies and their industries. So this is just a table of companies and industries. And now you go through and you ask, what industry does Scandinavian Airline belong to? I think most of us in here think it's an airline company, flights, travel. But this database would think it's software, because statistically, 75% it would be software. And this is how a probabilistic database works, and this is also sort of, how LLMs work. It will take whatever is statistically reasonable as the answer. Now, probabilistic databases, they're used to clean data so that you don't put in sort of an age of 1902 or something like that, but they're not generally used for gathering, like for taking or asking data from. So what we've learned is that we can go through and we can give it some context. So I can tell the LLM in my query that I love pasta bolognese and cats. Can you give me some recipes? well, hopefully not of pastopolias and cats. And it gives me some recipes that kind of resonate with this. So we can ground it with some data, and we can get out some other information based on that data. So this is something that Patrick Lewis and his colleagues kind of took to it and created this thing called retrieval augmented generation. How many people in here know what retrieval augmented generation, or RAG, is? Yeah? So fewer than I thought, actually. But that's good, because we're actually going to go through what retrieval augmented generation is, and also how we can optimize it, and definitely when we shouldn't use it. So the rest of the session will be how to create models that can actually reason about data, and when you shouldn't do that. So retrieval augmented generation works a little bit like this. You have a question that comes from the user, and then based on that question, you go through and you ask a database for some appropriate data. So you will have a database with data that it can use to then generate an answer from. So essentially what I did before, where I said, hi, I'm Tess, I love pasta bolognese, we're going to tell the LLM basically all the data it needs to be able to answer the question that the user has. So we search the database, we get some data out, we create a prompt from the data, and the prompt may look very different depending on where you get it from or if you fabricate it yourself, but the prompt will look something like this. Use the provided context to answer the user's question. You may not answer the user's query unless it's specific, unless the specific context is in the following text. And if you don't know the answer or cannot answer, please reply with I don't know. So it doesn't just hallucinate and come up with its own answer. I'm using the word hallucinate because this is something that you'll hear a lot about LLMs, and hallucinate means basically making up a fact that didn't exist. And then we give it some data that we've gotten from the database, along with a question. And then the LLM will answer based on that. And as you saw with my pasta bolognese thing, it answered a lot more confident, like a lot better than if I would have just asked it what I wanted for lunch without context. So the way we do the searching is generally through something called embeddings. And I'm going to go through and talk about what embeddings are, because this is sort of like at the core of these RAG systems. And I would say RAG is currently probably like 75 of the applications that people do with LLMs are RAG systems. I think that will change over the next year because of the problems that we're seeing with RAG, but that is currently what we're using. And we're doing something called a semantic search using these embeddings. So embeddings are like the secret sauce of deep learning. So this is a convolutional neural network, and you don't have to worry about knowing what a convolution or a pool is or what this array is. But at the end, what happens is we will be able to determine if something is a chihuahua or a muffin, if we create a neural network, a convolutional neural network that figures this out. Convolutional neural networks are used for images. If this was a deep learning network that wasn't used for images, instead we wouldn't have convolutions, we would have like a bunch of nodes that we would teach. So this thing in the beginning, like the convolutions and the pooling, they're essentially extracting features. So they're learning filters to put on top of images. And they will find filters or features like this, lines or colors or putting together patterns. So something here, for example, we can see this looks like a little bit like a bird or a beehive or maybe a tire or something like that. And then depending on how much of this exists in the image, it then creates an array that might be, you choose the length basically, but each number in this array is between -1 and 1, and it kind of tells you how much of a tire exists in this, or how much of that beehive exists in this. So this, what we see down here, is the array, which is sort of like the embedding or the secret code or intermediate representation. This is the core of why we do deep learning. This is what we want to figure out, because this is going to help us identify if it's a chihuahua or a muffin. And the way this works is if we picture that we want to recommend a book, and I have a large number of books, and I have a daughter and a husband, and they might want a book recommendation from me. So now I say, okay, so in that case, I might sort them like this. Some are for older people, some are for younger people, and maybe my daughter wants something for the younger people, and my husband wants something for the older people. And maybe that's good, or maybe we want to kind of add another dimension to this and say, is it fiction or is it not fiction? And we can now see in this coordinate system that these books now get an array of numbers, or actually a coordinate in this two-dimensional coordinate system. So we can also see that books that are very close together, like Hunger Games, the Divergent, they end up very close in this coordinate system. And this is sort of the key to embeddings, that you can do similarity searches. Just based on where they are in the coordinate system, they will either be similar or not similar. So you can use them for recommendations or figuring out in a search. So obviously, these were just 2 dimensions, but in reality, we'll add a lot more dimensions, like math references, or if it's US-centric or shitlit, or funny, or sci-fi, or lawyers, or would Brad Pitt play a character in a movie? It could be any sort of thing. And in fact, we don't know what it is, because the deep learning networks will come up with features that are not humanly relatable. It's features that we would never come up with ourselves, but that the machine learning model or that the deep learning model learns. And this now becomes our embedding. So we also do this not only for images and items, but also for faces, for example. So this is an embedding of this picture of my face. And this is something that was used in FaceNet in 2015. So this is quite old, like this embedding thing where what you do is like you have the FaceNet model, you extract your embedding, you put your embedding in the database, and then you take another picture of yourself, and it checks which one is it closer to. And the person that, or the hit it finds that it's this image embedding is closest to, that's the person it thinks it is, if it's close enough, because you might also have determined that they should be within a limit close to each other. So here we can see, for example, I'm the cyan person up here, and you can see that all of my pictures neatly fit together in this 2-dimensional projection of 128 dimensional embedding. And we can also see that, for example, my features maybe are quite similar to Tom Cruise and Sandra Bullock, but not so much to Bill Clinton or Serena Williams. But this is something that's super useful for similarity searches. So we can do this with images, faces, but we can also do this with words. And the way it works with words is like this. And by the way, everyone who talks about word embeddings is going to talk about man and woman and king and queen, because this comes from a very old paper on embeddings, I think from 2013 or 2011. So what we can see from this image, if we extracted the embeddings for these words, we can also see something interesting happening, where if we look at the direction between man and woman, and uncle and aunt, and king and queen, the directions between these arrows are very, very similar. And this direction, or this vector between them, kind of explains female. You know, the longer you are along this vector, the more female the sentiment of the word probably is. It's not going to be exact. These dots are a little bit too exact because, you know, queen may or may not be female, and they may or may not be royal. But as far as like the statistical meaning of them, they're probably female. And same thing if we go for man and king, woman and queen, we can also see that we can extract the sentiment royal from it. So all of this is what the large language model learns, or like the embedding models learn. They learn to extract the semantic meaning of a word or of a piece of text. So we can basically enter any piece of text and it will extract things. It will extract all these features and tell you how much of each they are. So once we know what these embeddings are, the idea behind how the search happens is this. We bring in a number of documents. So this is like our core data that we want to feed to the LLM. And then we chunk them up, because LLMs don't necessarily have, you can't necessarily put the whole document in the prompt for the LLM, specifically if you have very long documents. So you might just want to put some very small chunks, very precise chunks of data that you pull out of the database. And then we take the embedding of this chunk, so the semantic meaning of this, and we store it in a vector database. So this is what we do as preparation. And then on the other end, we go through the whole thing where we take the question and we compare the question to the potential chunks in here. So let's see how this looks in an example. So here we have, and I'm sorry if you're not a Python person, but this is going to be Python. Hopefully you can still read it somewhat. So I'm using Python, and I'm using a framework called LangChain. There are multiple frameworks for building LLM applications and RAG systems, like semantic kernel or llama index, or a number of these. But LangChain is a very common one that's used for Python. So we read in the docs, and I'm actually also extracting some metadata. So the data that I'm looking at here is actually this. We have an engineering fundamentals repository where we write things about agile, or about things like automated testing. Let's see. Well, anyways, about automated testing and CI/CD and all sorts of things. And this is what I'm reading in. Here I have all of these files in markdown format. So if I go into something like machine learning, I have like ML data exploration and things. So I'm reading this, and I'm also checking the structure, and then I'm going through and I'm doing chunking. So this was the second part. So for this specific example, I'm using something called a markdown text splitter, and I'll go through what chunking, how that works in a second in a PowerPoint. But this basically then divides the documents up into parts, and then we go through and we embed the docs. So for embedding, we use an embedding model. In this case, I'm using an OpenAI embedding model, but there are many, many different embedding models used for different purposes. So I'm using this, and if we look at an embedding, for example, of just the sentence, hello world, it will then spit out an embedding, like an array that's 1,536 numbers long, and looks something like this. So we saw it similarly to when I was showing the embedding of my face. And then I'm adding all this to a vector database. And there are plenty of vector databases. Right now I'm using Azure AI Search, but you can use in-memory vector databases and all sorts of things. So they all work pretty much the same. They have a few different features depending on which. So this is what we do to sort of get the data into the system. And then if we look at something like I ask a query of this, like what are the agile ceremonies, it will then spit out the most, like the chunks that are most similar to the query, what are the agile ceremonies. In fact, if we go in and look here at this is the AI search database, and I ask it something like, what tests should I run on an ML model? It will then spit back, hopefully, a number of documents. Let's see if, so that contains something about model load predict. Let's see, I wanted to minimize this, but let's see if we can scroll down. I think because it's so big, I can't. Well, anyways, trust me that this document is probably from the ML testing document, and it will have sort of like 10, or depending on how many you want from your query, it will have 10 or 20 chunks that it can pull out from AI search. And then if we go back, so now we have the data in there, and then to query the data, we basically set up the same things. So we have the AI search and the similarity, and then we build something called here a conversation retrieval chain. This is something that exists in LangChain. You have similar things in the other framework models. And we put in the Azure AI search as a retriever. So the only thing we then, so this is essentially how you set up like the whole RAG chain. And it will automatically create the prompts and everything for you. And then if I search for what tests should we run on machine learning code, I get out an answer that looks like this, where now the LLM has synthesized all the information from the chunks that I used and given them back to me in sort of like a natural language format. I also like to do something a little bit, and this is something I do suggest that you use if you're working in Python with these LLM things. This is a tool called ChainBot. So ChainBot is a library in Python that allows you basically to create a user interface for your LLM experiments. And I've just added the exact same code that we just saw, but to Chainlit, just to show you really quick how Chainlit works. Basically, you just implement an on message. So when you get a message from the user, you just take it and send it off to the chain. And you get this whole user interface for free. So now if I say, what tests should we run on ML models? It now goes through and does the search and also synthesizing the results. I'm using the GPT-3.5 model for the results for this. And we see it came back with approximately the same thing that we saw in the notebook. And I'm also displaying like the source documents here, so we can see where it got all its information. But I find this is quite useful, is to have real users test the system. And you can actually use Chainlit in production if you want to as well. So that was our little RAG demo. And these were the tools. So now when we have the RAG demo, it's quite tempting to go from this seemingly really nice question and answer machine to artificial general intelligence. Like it's almost, yeah, there's no step between there at all. Or at least production, because, I mean, what else is there that we need to do? But it turns out that unlike sort of software projects where we create a POC and we know it can be super, super hard to figure out like how long it will take us from this POC to an actual production system. We know that there's a whole lot we need to do, but we at least have a general idea that if we can do it in a POC, we can probably also do it in real life. And we know that, yeah, setting up the real infra, setting up all the tests and everything, it will take some time, but we have a ballpark of how long time this will take. In this case, we have nothing like that. We don't even know from this small POC, which took us 5 minutes, to actually figuring out if this is even doable in production. And this is one of the problems that you kind of always have with machine learning and also with LLMs. Because the problem is that when we look at the real data, or when we look at the real sort of situation, it might turn out that the data that we had for this small POC was just, nice data. But if you went to Malte and Matilda's talk about Planprat yesterday, you saw that going through and wading through PDFs with tables, where all the tables look different in all the different documents, or they might have images or handwritten text and all that sort of stuff. It's a nightmare to even ingest the data or figuring out if the data you have will actually answer the questions that you want answered. Because if you're not giving it the proper data, it will never be able to answer the questions. And then chunking, which we'll look at in a bit, also matters a lot. How big the chunks are, and how you chunk them. And the embeddings matter a lot, and they depend a lot on both the size of the chunks and for example, if you don't have English language or things like if you have text that's maybe not general, maybe it's medical text or something like that, that's a problem. And then we need to think about, because we're now storing this data in a database, in a vector database, and this data might have come from a system that was safe and secure and had privacy, because we all are really good at both security and privacy, right? And now suddenly we're copying all the data into a new data store, and we're forgetting about all that. So maybe Anne can now get to Pete's data, or maybe people can get to data that they absolutely shouldn't be allowed to see. And not only that, but what if the data is continuously updated? How do you update this vector store with that sort of thing? So there are a lot of considerations around the data that you don't have to worry about in the demo that are very, very worrisome in real life. And then you have the question, because when you're creating this system, you're probably going to ask it some really neat and nice questions based on what you're thinking, but then a user comes in and they ask something completely different. So instead of asking some very precise questions about what tests should I run on machine learning models, they say, can you summarize all the problems I've had from between 2001 and 2018? And suddenly, there is no way that your system is built for that. It's no way your system is built for actually accessing all the chunks that you needed to answer that question. And also, you might have people that do adversarial queries. So they might go in and try to jailbreak the system in different ways. And then the retrieval, like this is a search problem that has existed since semantic search kind of started in 2013. It's not super trivial to do retrieval from a semantic database. It's not like it's going to give you 100% of all the documents that are relevant for this problem. And then we have the prompting. And the prompting, I'm sure you've heard the name prompt engineering. I think maybe not so much engineering, but prompt hacking, maybe. But it doesn't matter. Like even a word or two in your prompt creates completely different answers. And then we have the generation, which we already see how that can end up, telling people that they should have done more stuff since 2014. So all of this might seem like a ragtime nightmare. But there are things that we can do about it. So hopefully I'll introduce some good ways that you can optimize all of these things. But before we start optimizing anything, we need to talk about evaluation, because when you do experiments, a lot of people will do experiments and then evaluate them manually. And that is probably the worst thing that you can ever do, because there is no good way then to tell if chunking it this way or parsing it this way will actually make a difference for your whole system. So a long, long time ago, back in the day when we were just doing regular machine learning, like last year or something, we had these machine learning models that would do classification, for example. It would figure out if it was a cat or a dog. And we knew that if we got these answers, so it didn't realize that this was a rag doll, it thought it was a dog, we had 90% accuracy. And what we would worry about was if the test set was different enough from the training set, so we didn't leak data from the training set and the test set. So I'm not saying that it was always this easy to figure out what the accuracy was, but generally we had something called accuracy that we could deal with. But now we have something completely different, because now we're generating text. So if we're generating text about this image and the ground truth, assuming that we actually have ground truth, because that's a problem too. Like we have to evaluate something, we actually have to have someone write down a number of questions and a number of answers that they would like to have. So in this case, if I say this is a pic of a super cute kitten catching some C's, and that's the correct answer, but how good is this answer? An image of a sleeping feline raising her paws. Obviously, it's factually correct, assuming that it's assuming it's a her, but it might not be tonally correct. And you can see that the words are very different, so it might also be semantically correct, but we have no real way of telling, like, is this a correct thing? If this would have to fit in a book for a 5-year-old, this might not be the perfect answer here. It might be very incorrect. And oftentimes it's not even factually correct. So it's very hard to say what the accuracy is here. We have some attempts to do this. So, for example, prompt flow in Azure has a number of measurements that it can help you take. And same thing with like frameworks like Ragas that will help you evaluate different things. So on the retrieval side, it might evaluate context precision and context recall. So what this does is it basically say, given the question, context precision is the chunks that I got back, are they actually, like, do they fit the question? And context recall says, did I get all the chunks that were necessary to answer the question? So that's on the retrieval side. And then we have groundness or faithfulness on the generation side, which means, did the LLM use the context to generate the answer, or did it just come up with answers by itself? So out of the facts that it stated, how many of those were actually grounded in the context it was given? And finally, there is things like answer relevancy, which is, did the question or did the answer actually fit the question, and so on. So all of these, we can now see that we have 4 different measurements, and we all know that if we have 4 measurements and we try to tweak something, and that tweak fixes this, but doesn't fix this, then what did we do? How good was that fix? So it becomes harder and harder the more things you have. But the other problem with this also is that this is typically based on asking an LLM to give an answer, basically to tell it, was it factually correct, or was the context relevant? So we literally have an LLM watching an LLM. And if the LLM that we used to generate the answer was GPT-4, and the LLM that we're using to watching GPT-4 is also GPT-4, then do you think it will tell that it's correct or incorrect? So these are some problems that we have to wade through. It will be a little bit better if you have GPT-4, for example, watching GPT-3.5, because then you have a better LLM that can sort of tell you how factually correct the lower one was. But so these are all problems, but this is what we have. So at least we have something that we can use to test these things. So now that we have something to test, let's talk about like some of the optimizations we can make. So the first one is around data and data ingestion. And I think that in all machine learning projects, and the same thing with these LLM and RAG problems, this is the most important part of the problem, which is actually making sure you have the right data and making sure the data is ingestible, so that it's not out of date, that it's actually is complete, will answer the questions you need, and also like that when you extract it. So if you extract a table, deciding like how that will look, and you might have other problems in your PDFs, for example, with images or all sorts of things. So one thing we can use is document intelligence. So document intelligence is one of the tools that you can use to do a little bit better parsing than normal if you have PDFs. There is also Llama Parse, which is something that came out now from Llama Index. But there are definitely better parsers that you can often use, especially if you're working with PDFs. So I'm just bringing this up because this, before Llama Parse, or actually I think llama parse and document intelligence are kind of like on par, but this used to be the state of the art for extracting things from PDFs. It's not something that you use locally on your machine. It's actually an API that you have to go through with models in the background. And if we have multimodal data, multimodal meaning that we have images or we have tables or we have things that are not necessarily plain text, a couple of things that we can do are, for example, if you have an image in your PDF, you can either ignore it and say that I don't care about the images, but then you'll lose some data. Or you can do things like try to get a caption for the data and you store that with your text chunks instead. Or try to extract and summarize your tables or extract them as JSON or something. Or use a multimodal LLM. So now we have like ChatGPT 4v and 4o that know multiple modalities, so it knows images, etc. Now we get to the chunking. So the chunking basically means how we split up our data into smaller parts. And we want to make sure that we pick a chunking method that's fitting our data. So if you have a long novel, then the context that you need might be sort of like a whole chapter or something like that. Whereas if you have a Q&A document, you might want to chunk them up in just a question and answer. And that might be the correct chunking part. And you also have to think about, different embedding models have different sizes that they work well with and not, and different LLMs have different context windows, like how many chunks you can actually put in or how much text you can actually put in. And the other thing you want to do is also try to balance, because we're using, in the general case, which we'll see we can change, we're using the question, creating the embedding of that, and comparing that to the chunk. We want to make sure that they're approximately the same size. So if you try to embed something that's a page long, that contains a lot of different topics, then the embedding for that is not going to be very precise. It's going to be super general because it's going to have all of these semantic meanings. And it's going to be very hard to kind of compare that to a very crisp question. So chunking works like this. So this is the most naive type of chunking. And if you want to try out chunking, there's this site called ChunkWiz where you can test out how chunking would work for your documents. But this one basically says, chunk it up into 400 characters at a time. I don't care where that 400 characters take me. So you can see here between the blue and the yellow on top, it just stopped in the middle of a word. Obviously, if we send in that chunk to an LLM, it will be missing some context at the end of that sentence. It's like if you would just tell your friend half a sentence and then ask it to give you an answer based on that question, on that sentence. So a little bit more refined way of doing this is by doing a recursive sentence splitter or a recursive character splitter, and it will at least give you paragraphs, or it might look for sentences or things like that. So this is the typical thing that you'll see in most demos. It will use this recursive character text splitter. But I think we should go a little bit further and do something like this, which is a recursive text splitter, but with, in this case, since I'm using Markdown, it will know about Markdown, and I will say, pick out chunks that are like second-level headings. Those are the chunks that I want. And this recursive text splitter also has modes for HTML or for Python or for a lot of different things. So depending on the context, there's often like a splitter that will understand your type of content and be able to split a little bit more intelligently based on that. Or you can create your own splitting yourself, but basically try to be as content aware as possible. And then if we're talking about the embedding and indexing, I've already talked about how we want the chunks to be super small because the chunks are sort of like what we're going to be comparing to the question. So we want to have a crisp topic. We want to have a crisp embedding that basically is very specific to that chunk. But when we give the context might need to be a lot bigger for the LLM. So as an example, if we have this document, which is the plot of Oppenheimer, and we have a question that is, what was Oppenheimer's relationship with Einstein? It might have picked out this chunk, but this chunk might not tell the whole story. This was because this chunk contained Einstein and something like that. So we pick this out of the database, but we send the LLM this. So we send the LLM the chunks before or after. So this is a technique called small to big. And it's quite an easy technique that I think is well worth experimenting with. There is also another version of this where we do the same thing, but we're just sending back the whole document altogether. Or we might have a summary of the page that we use for indexing and then send back the whole page. And how much we send back depends on what LLM we're using, like how big its context window is, and how many chunks we might want to send back. So this particular one is called parent-child chunks retrieval. We also have a number of other techniques, and I will say that a lot of these techniques may or may not yield results in your specific case, but they are quite interesting to try out. So the next one is called HIDE. This is a paper that came out that talks about hypothetical document embeddings. So when we have the question, instead of trying to embed the question, what we do is we ask an LLM, can you give me a paragraph based on this question? And then we use an embedding of the paragraph instead. And the idea behind this is because you might have a question that goes, can you give me a passage from War and Peace? And then you want this, which actually has nothing to do with War and Peace. Like, it doesn't contain the text of War and Peace in any ways, but it might be very similar to a hypothetical chunk that the LLM spits out. But now we're kind of in the realm where we're asking an LLM to guess what an answer might be, and then try to retrieve something from a database on what that answer might be. The alternative, or the reverse of this, is that when we embed all the chunks, instead of embedding the chunks, we say, can you please give me a question that someone might ask about this chunk? So the LLM would then spit back a question, and instead of giving the embedding of the chunk in the index database, we give the embedding of the question that the LLM came up with. So now we're comparing questions and questions, because it's quite important when you look at embeddings that you're comparing apples and apples and oranges and oranges. So this is one technique. The other thing with embeddings is this. If we have a legal text, like in this case we have words like hereinafter, which, yeah, I've never used that word in real life actually, but or commencement date. Or if we have a medical text, it might be something like a wet lab or a solution. And solution in medical cases or in chemical cases is a lot different than a solution in general text. So now if we're using an embedding model that's built for general text, that might not find the sentiment of solution in this case. So we might want to just train and fine-tune. So fine-tuning means that you take a model that already exists, like an embedding model, and then you train it a little bit more with just a few more examples so that it learns what a solution means in your type of text. So you train it a little bit on your own data. Then we have the indexing and retrieval. So now we're going to get into some other techniques that we can use for that. So this one is one that I will say, if you do nothing else, and if you have the opportunity, this is one that you absolutely do want to try. Metadata filtering. So we can picture a number of queries that we might be able to ask on a number of sort of like if we have information or the plots of some movies. So we might want to say, I want to watch a movie rated higher than 8.5, or something that's directed by Greta Gerwig, or something like that, where in traditional means we would do filtering on this, but they're not giving us a filter. They're giving us sort of like the question in plain text with kind of hidden filtering and questions. Like, for example, has Greta Gerwig directed any movies about women? That's actually movies about women, director equals Greta Gerwig. That's how we probably would want the query to show up. So the way we do this is we can now bring out the same chunks, and if we have the metadata around them, and this might be, in this case, we have very good metadata, like what year or rating or genre or things like that. But you might have at least some metadata about where the PDF came from, what machine it was talking about, if it was talking about like how a machine works or something like that. So you can kind of like add metadata to your content, and then you can tell also the vector database, sorry, not the vector database, like you can specify the metadata fields, this is for the retriever, to say this is the description of the metadata fields. So when someone comes in and talks about genre, then this is what they might filter on. And these are the possible answers that you might have. And then you go through and you retrieve the content, and you get out sort of things filtered. So if we look at how this looks in real life, you'll see here, I've done the same thing here. And the prompt that it actually asked the LLM in order to do the filtering was, your goal is to structure the user's query to match the request schema below with a query and a filter, and it tells it how it should generate a filter. So basically we're asking the LLM to create a filter for us into the index database. And this works extremely well, actually, assuming that we have the metadata for the data we have. So another thing we can do, and when you're doing some of these things, you have to be a little bit aware that some of these things take an extra call to an LLM in order to be able to execute. And you will have to like consider if it's worth the cost and the time it takes to make that extra call. So this is query expansion. You have a question, and you ask a machine learning model or an LLM to say, give me 5 questions based on this question. And then I take all of these 5 questions, and I search the database, and then I pull together sort of like, I look at the unique chunks that I get back and re-rank them. So re-ranking you often do with a re-ranking model. And then you ask the LLM to synthesize the answer based on that. And the idea behind this is that the user might have asked like a very vague question, like maybe what are the approaches to task decomposition? But if we can expand this to these questions instead, it might have a better chance to actually retrieve the content from the vector database. Or it might even sort of create like sub-questions. So it might create, from one of these, it might create a number of sub-questions that together bring up all the data that we need to answer the question. And then we have hybrid search. Hybrid search basically means that you both do semantic search, but you do some more traditional search or n-gram search, where n-gram is basically more traditional NLP searching. So you can say, I want 25% of my results to come from this type of search and 75% from this. And you can mix and match however you want, and then take the chunks and reduce and re-rank and do this. So this is also something to try out, and most vector databases have this kind of capability. And then when it comes to re-ranking, you might think that if you've gotten something from a vector database, it should already be ranked nicely, like we get the best things first and the worst, like in diminishing order. But it's not necessarily always true. We might use a re-ranker that's better at actually the ranking portion. And we also might have a problem like is described in this paper, this called a lost in the middle problem. So it turns out that a lot of LLMs know things that are at the beginning and at the end of the prompt, but they don't know, like they kind of forget about things that are in the middle of the prompt. So you might want to re-rank and put the important stuff first and last, like Claude 2 kind of like often listens more to the things that are close to the questions. So it depends also what LLM you're using, how it's using the context and how it's doing this. And then when it comes to the generation, there are a couple of things that we can do. We can use something called agents. So I'll show here. We'll call this agent Mr. Anderson. So we saw from before that it wasn't very good at math. And it's also not good at actually searching for things or finding data that's very recent. So in this case, what I want to do is I want to say, how many more people live in Stockholm versus Oslo? So what this is going to do is it's going to go first out and do a web search, and then it's going to use a calculator to put things together. And before I show the answers, I'm just going to show you how this agent looks. So the only thing I've done here is I've created a set of tools. So one tool is a search, and one tool is a calculator. In this case, I've used a Bing search. The reason I used that was because I had the API key. And then I'm using OpenAI to kind of synthesize the answer once it's gotten the results of both of these. And then you can see this agent, what it does is it kind of uses the LLM to figure out how it should solve the problem based on what the question is. And one way it's doing this, then it took 5 steps. So first, it had a thought that it should use the search tool for the current population in Stockholm and Oslo. And it goes through and does the search, and then it used the results and it put them together, and it used the calculator tool, which the calculator tool is basically just a function like that can calculate. So this is not a guessing anymore, like the calculator tool is an actual calculator. And it returns the answer. And all of this took and then it comes together and creates an answer for us that we can use. And all of this took one step and all of that. That's a part of Chainlit, this user interface, that makes it also quite nice to work with these agents and things. Just because you can kind of like run a lot of queries and you can follow the whole train of thought and everything. So sometimes we can use these agents to figure out first, if you have very similar documents, let's say you have documents that talk about different machines and how you should operate them, then you might have document agents that know first which document you should run RAG on, and then use that instead of like having all the chunks together in one RAG system. And then finally, with all of these things, there is still something very scary going on. This is an LLM leaderboard. There is like a lot of benchmarking when it comes to LLMs. This is just one. I just picked one, the first one I could come up with when I searched for LLM benchmarking. But they will all show about the same things, that on data sets that it's trained on, it will find out the general accuracy of how well it answers something is around 65 to 85%, or 60 to 85%. And they're getting a little bit better. I think GPT-4o is a little bit over 85% in general. So we're kind of getting there. But right now, it sits at about 85%. So we know that generation then is definitely not a 100% thing, even given all the context in the correct order. And then we have the retrieval, which itself might have an accuracy of maybe 60 to 85%. Yes, ballparking here, but these are quite reasonable numbers for retrieval, and augmentation. And if we look at this, now we have two probabilistic systems that we compound. So we have 0.85 times 0.85, 0.72. So that means that on a good day, it will answer correctly 3 out of 4 questions. And that fourth question, it will also be very confidently incorrect, you know. So unlike something like where we return a bunch of search results and we give the user 10 search results, the user is quite used to that it will have to sift through the search results, and if it's a good search, then hopefully one of the 3 first things will be correct. But it will itself, like the user will themselves go through and say, not relevant to me, yeah, my question was probably not good enough to give me, like, but out of the maybe first 3 or first 5, it will find the answer. In this case, we're assuming that all of our 5 first guesses are correct, and we're using that as the facts for the LLM to generate the answer with. So what happens here is that we might create a system, and especially if this is a sensitive system, like we were experimenting with just a really rough experiment where we had a knowledge base, an HR knowledge base, and we wanted to create sort of like an FAQ on top of it. And it would confidently tell us that if your cat passed away, you had 3 days of vacation, or not vacation, but you could take 3 days of leave because of this. And when you're getting told this in natural language, that is fact. I mean, if you're asking an HR bot to give you an answer, you're going to trust what it says, especially if it's, well, you might trust it, but you're probably going to point to it and say, it told me this, I should get these 3 days. So if you have a sensitive use case where someone, like where what you're saying is legally binding, or what you're saying is actually going to affect someone on how they're going to process something, like let's say you have something that returns how you should operate a machine, and it forgets to tell you 1 or 2 steps, and those steps are quite crucial to how you should operate it, maybe turn the machine off before you clean it or something like that, that might cause some real actual problems in real life. So be very careful if you're using this sort of in a real sensitive use case. So that kind of post this paper says RAG does not work for enterprises. And actually one of my colleagues asked, did you co-author this? Because I've kind of been a little bit on the rant or rag for this. Yeah, no, she didn't. Yes. So what we can do here instead is basically take off the augmented generation in these sensitive, and by sensitive I mean sensitive in the widest sense of the word. Yes, do search, maybe add data in templates, or do highlighting of the search results when they come out instead of augmenting and actually generating an answer, in natural language. And finally, the last sort of thing that we need to take care of is guardrailing. So there is a lot of things that might happen where the user might have an adversarial question, or your LLM might answer something that it shouldn't answer, or maybe the tone is wrong and things like that. So from this very naive RAG system, we should add a lot of guardrails, like check if it contains PII, so we don't send PII to a language model that we don't want to send PII to, or if it's asking something that's completely off topic, we need to understand if we need to give answers that are appropriate, or if they do a jailbreak attempt, we need to stop that. And on the other side, also fix all the things that can come out from the generation, like hallucinations or bad tone, or if it's supposed to return a piece of code, testing that the code will actually work, things like that it doesn't return secrets, etc. So all of this together are things that we can do to make these better. But I want to just finish off with saying, rack carefully out there, friends, because this is, yeah, while it looks shiny when you first try it out, there's a lot of work that needs to be done before you're finished. So thank you so much for listening, and I'll be here for a while for questions.
Okay. I think we hit the 20 minutes of the 4 mark, so it's time to start. Good to see that you're all still around, hopefully enjoying the conference. Probably here for what's happening tonight, but in the next 50 plus minutes, we're going to talk about review NuGet packages easily, or for security easily with OpenSSF scorecards. First of all, who am I? My name is Niels Stanis, and I work as a security researcher for Veracode. Been doing .NET development since the first framework releases, and always kept an eye on security, and that was like one of my biggest interests. And in 2015, I moved to Veracode, where I'm right now focusing on everything what we do for static analysis with .NET, which is a lot of fun, programming a lot, looking into stuff, how it works, internals. Yeah, that's pretty cool. And I'm also doing a lot of Rust lately, which is, yeah, cool language. And a lot of public speaking, and that's the reason why I'm here. And I love to talk about like developing and using technologies in the most safest way, or at least make sure that the software that we all write gets more secure. So that's the goal. If you want to talk more about Veracode, come see me afterwards. I think I will mention Veracode twice, but it has to do with some, like we have some state of software that we talk about, like what the current industry is doing. Those are only like statistics, so, and the rest is all cut out. Because in the next part of the presentation, let's first focus on how we need to look at software. And I think everybody probably knows the XKCD ones, right? The cartoons that are drawn for different security issues. We have the one on SQL injection. This is one I'm literally using for every presentation I gave over the last 3 years. And in this picture you see, this is the old modern digital infrastructure, but we can just replace this with application architecture, right? It's the same. We will have a stack of blocks that we put on top of each other. And that's logical because we use software that's written by others, right? Open source libraries. Why would you create something on your own if you can reuse stuff that's already there? But then there's one problem with it, right? And that's the one small block on the right-hand side we see over here, which has been thanklessly maintained since 2003 by some random person in Nebraska. That's how they put it down, right? We put a lot of trust in open source. There's also a bit of a big difference if you have like commercial software that has people that do security full-time on it. It's different than a 5 group people that will just want to share what they've done with the wider audience, right? There is more risk to it. And in order to be more aware of the risk, we need to maybe look at our packages and the stuff that we use differently. And that's what we're going to cover this session. First, we're going to dig into some third-party risks in general, some different variants of stuff that happens with not only NuGet, we're also going to talk a bit about the Java ecosystem. There are a couple of good examples. Then I'm going to focus more on what OpenSSF scorecard brings us. There's a whole set of checks in it that will allow us to better understand how packages are built, and we can have a better understanding of like looking at the nutrition label, as you've seen in this generated image over here. Then I want to focus more a bit on some tooling that I wrote myself, but also on some improvements I think we can make, because scorecard in general is something that runs on Git repos, GitLab, GitHub, you can just run it. But there are certain areas within NuGet ecosystem or .NET ecosystem that we can focus on that will give us more value for it, right? And at the end, there will be conclusion QA, questions. All the slides that I'm showing here are in a repo. I've got some demos, I've got some scripts, you can find it all there, and I have links to the articles that I use as a source. So at the end, you will get it, and no need to worry about the things that I'm showing here. Another thing that I'm using a lot are code cartoons. This is one that's created by Lynn Clark. She's part of the Bytecode Alliance. She talks a lot about WebAssembly, but everything they draw in relation to security is something that we have at every technology stack, right? So I'm using this mostly to illustrate that if we write software, 20% of the things that we do are stuff that we write ourselves, and the other 80% is stuff that comes from others, the third-party libraries that we use. And there's different studies, different figures. You can also argue a bit like, hey, I'm using that library, but I'm only using a small portion of it, right? So is it really that difference? But we rely on others for this. And I think that's the key thing. And how does it then look? And this is the state of software security we published, and this is the version that we published in 2021, which focused on open source security, open source software. so we do a lot of static analysis, and we've got some metrics and some bigger data on it, so we can see how every industry is doing. In this case, we looked into open source, and what we concluded at the end is like close to 80% of the applications that are scanned will add a dependency. So let's say add a package, and it never gets updated, which is quite worrisome if you would think about that. I still need to project the last one. We have one that's published like I think last month, the version 14. I need to get the data, but I think it's quite similar. Hopefully it dropped a bit, but a lot of the libraries are not updated, right? And what happens? And I think if we then take one sidestep, as I said, we're going to look into the Java ecosystem. 2 years ago, last year, December, 2 years ago, there was the log4j incident, log4shell, right? So in essence, the problem was that log4j was having a vulnerability, and you could use code execution based on what's been written out by the logger. That's in essence what's happening. Last year, Chris Eng, Chief Research Officer of Verico, decided to look into some of the details and see, have we learned from this as an industry? He looked into almost 30,000 unique applications that are scanned, Java applications, and we concluded at the end like close to 3% is still vulnerable to this. So they haven't updated, or they hadn't done anything about it, or maybe they did other assessments and said like the risk is minimal, I don't know. But 3%. 4% did have the update done for the first log4j CVE, but it was a chain. They fixed it, and they didn't fix it, and we fixed it. So it was like a whole chain of updates you needed to do. So 4% are somewhere in between, so still vulnerable. And what's even more worrisome is that 32% uses a version that's out of date. It's not being updated anymore, right? So if it's running somewhere and it doesn't get updated, that's a big risk. And yeah, I think this illustrates that we need to do a better job in that. Because looking at the average code base, and another code cartoon, if we would say we have a package, we add a package to our .NET app that we created, let's say we add one, we always get a couple that come with it, right? It's a transitive thing. It's normally not one package, you will get like a whole tree of things. And looking at the .NET application, if you start it out on a machine, it will start a process, right? The bootstrap and the CLR starts. And it will have access to resources on that system, maybe access to stuff that's outside the network and so on. But by default, every package will have the same access because it's the same process, right? There's no distinction being made. So if some library underneath wants to access the files that are like somewhere on the system, you might be able to do it, unless you lock it down. That might be the trick. So this is a problem. This is how it works. And what happens? What if a module becomes malicious, right? It will get like a nice mask. It will be the villain in this case. And it says like, hey, I'm going to look into the file system and see if there's any files. That might happen, right? And do we have malicious packages in the NuGet system? Yes. So this is something that was published, I think, 2 years ago by JFrog. They had a bigger, 1 year ago by JFrog. They had like a big look into the ecosystem. And they saw there were some packages with malicious things in, and most of them targeted crypto wallets, like cryptocurrencies, and tried to steal them from the system. So yeah, if there's money to be made or something to be stolen, technology, right, and people will use it, that's for sure. Another thing that we saw is something that was published by a company called Reversing Labs. They looked into NuGet and saw that there's like a loophole for packages in how they can integrate with MS Build. And that was also widely misused for a lot of other things. I believe right now in NuGet, there are certain tasks you can define, and it will be visible if that's in, right? That makes sense. But this is definitely, if they can put it in, they will do it. Most of these two, the one that I mentioned before, and this one is also related to, let's say, typo squatting. So if you misspell a name of a package, that will then result in that version. And you might not notice it because it will still work the same, but there will be additional stuff included inside. That will be that kind of a problem. What else could happen? And that's something that was published by the University of Minnesota in 2021. They called the project Hypocrite Commits. And what they did is they started out contributing to one of the modules that belonged to the Linux kernel. And just like gain trust and so on. And then at the end they showed that they could become malicious, right? Because they have gained trust within the team. Being able to stuck something in a module that gets deployed on it, or like that gets released to every Linux kernel or something else, that's quite of a foothold, right? You have a lot of influence if you do it. People were not amused. They got themselves banned from the project, which is like, yeah, I can see that people are a bit like annoyed by it. But how realistic is this, right? What will happen? And that's something we saw in March of this year. So XZ is a compression library, which is, I think, also widely used within Linux. And it turned out that it was backdoored. But it was backdoored in such a way that I believe in total, like, you could question who's behind it, but the people who have targeted it decided like 3 years ago to start contributing to this project. They made sure that they were able to downgrade the way the security testing was done by changing some of the fuzzing that happened. We're going to touch fuzzing later on, but it's mostly like security testing of the thing itself. Because if you would build in a backdoor and if a fuzzer finds it, right, then you lose it. And then at the end, I think 1 month, they were able to have a backdoor inside, which had some conditions on how it executed. It's nicely tucked away. Nobody knew at this point in time. But there was one really, I would say, almost hero. One developer from Azure Postgres was running tests on his own machine and saw that the tests had increased in time. A couple of 100 milliseconds added to it. And he thought, like, this is not good. There's additional stuff happening, I don't know it. So then he digged into it, and then he found out that there was a backdoor, conditional backdoor. The thing that worries me the most is like, this is quite sophisticated, done on one specific library, and if you have access to it, you can probably get access to a lot of things. I cannot imagine this is the only one, right? Because would you put all your eggs in a single basket? Probably not, if that's your motivation. So I think we should definitely be more aware of what's inside and what do we expect, right? And there's also a balance between that. We have open source and people contribute to it, and we want to leverage that as well because that will get us like much further, right? That's the thing. So that's what we can see with malicious, and we're going to talk about it a little bit later on as well when we're digging into what OpenSSF can help us understanding. What else happens with packages, as we saw with the report before? Vulnerabilities are found. In this case, somebody could influence a module and say, like, hey, could you get more information or like a disclosure or whatever. And with .NET, this happens, right? These are security bulletins that are released. Now and then you can find the details on GitHub. This one is from November last year. We need to update. We need to update our dependencies. And of course, you can use a commercial tool. Maybe you need to use us or one of the competitors as compliance, right? But if you're doing .NET development, you've got your .NET CLI available. And you can just say, hey, list all the packages I have with this project and list all the ones that are vulnerable. And starting with .NET 8, a restore will do this by default. It might have annoyed you because it will break the build, even if it's like certain severities. You can configure it, right? So in this case, you would say, we're good. We didn't find anything. But as I said before, you add one package, you get a list of packages for free. So you need to look into transitive list. And in this case, this is a package I created, but it relies on iText7, which is some PDF generation. And if we then ask, can I get the vulnerabilities of this list? Then it will say like, yes, there is one. And there is some dangling Newton soft JSON version used somewhere lower that has an adversary you need to look into, right? So the key in this essence, it's the essence of making sure you have one single dependency, but there's always a tree. And I hope and I believe there are plans on doing the transitive things by default as well. That helps, right? Because if you do this when you're developing, that's the spot where you can fix it easily. So it's there, use it. And another thing, and I'm using another article of Reversing Labs again, is something like, do you know what's inside the package you get into your system? And in this article they dig into, if you look at NuGet packages, sometimes you can get a wrapper package that maybe does some unmanaged calls in a system. And one of the examples they gave is like WinSCP that copies files that rely on an unmanaged DLL that's inside it. They saw some versions which had vulnerabilities in it, but because it's not like a NuGet dependency that is part of our ecosystem, how we look into it, no, it's a hard-coded DLL that's inside of it. You don't know it's there, right? And it makes it harder to understand what's inside. The other example that they figured out was there was a version of gzip used also to do some compression, and that was nicely wrapped in a package. And gzip can only be built from source, and that version was used, and it was vulnerable since 2005. and the package is pretty new, doesn't show up in the thing like, hey, there's a problem, but yes, there is, because there's additional baggage, as they put it, right? There's additional things inside you're not aware of. So something to keep in mind. We're going to touch all of it later on once we look into scorecards, but this is these are the problem space. So what can we do about this? Wouldn't it be nice to have some kind of nutrition label, right? Nutrition labels are the example that they also use with like knowing what's inside. If you go to a supermarket and this is a bottle of Club Mate, which is like a caffeinated drink. If you go to a hackerspace somewhere, they will probably have this in one of the fridges. It has a lot of caffeine, but you can also look into the label and you see like, hey, there's per serving, which is a nice abstraction. So you need to see like, oh, the bottle is 2 servings. So with each serving, I will get 3 cubes of sugar, right? 16 grams of sugar. Do you want to drink it? Maybe not, right? Maybe I should not do it. But this is like 15 grams, right? So this will allow you to make better decisions. If you go to a grocery store, you grab something, you can see, hey, this has a lot of salt. So maybe it's not a good idea to eat this or not the whole package, right? But that's a decision making you can do because you have the information available. And wouldn't it be nice if we can do the same with software? And luckily, yes, we can, because this is where OpenSSF scorecard comes in. And it has the goal of making sure that you can quickly assess open source projects for risky practices, right, in general. If you go to the website, you will find all the descriptions. And the thing that they also wanted to achieve is like you need to do it in an automated way with a tool, right? And there are certain checks it will do. And in general, it will look into the supply chain of the package. And there are certain areas it will focus on. And then it will calculate a score. And there's a whole checklist and a whole thing how it calculates the score. But one thing to keep in mind, the outcome will be an aggregate score, which will be between 0 and 10. 10 is good, 0 is really bad. And based on the checks, and I'm going to go through the checks in a bit, there are certain risks associated with a thing. So we will see a license has a lower risk, so it will have less of a weight into the outcome compared to, let's say, dependencies or vulnerabilities that have a higher risk in the total. But that will be calculated and that will be added on to the end score. And there are certain areas that they focus on, which is code vulnerabilities. So are there any known vulnerabilities? Maintenance in case of like access and how well is it maintained, active people, contributors, that kind of thing. Continuous testing, not as underestimated as well, like how much testing is done. And then of course, because we deal with source, we have access to source and we build our software on build systems. And that adds up the whole holistic practice that they do with OpenSSF scorecard. First check it will do, I'm going to go through them a bit and I will explain like what the goal is. So OSV isn't a service you can just go to right now. If you go to OSV dev, you can look into like, hey, give me all the current vulnerabilities or problems in NuGet. You'll get a nice list. This is one I created yesterday. And it turns out that on Tuesday, there was a problem found with the storage movement client library that is part of Azure SDK. This is just a nice open database. Everybody can use it. So once it has a known vulnerability inside, this will add up high in the whole total score, right? If we have dependencies, we want to make sure we update them, right? We want to make sure that we have the latest version. So another check it checks for is, hey, do you do stuff with DependabOt or RenovateBot? Like, is there any automation in place that will update stuff to newer versions if needed? Because, as I said before, based on report, like out-of-date dependencies make a project vulnerable, right? If you don't know what's inside as well, and it's running somewhere on the infrastructure, it's better to have some automation in place. And that's a good practice. So that's the reason why this one is high. The other thing that they looked into, and that's more moving into the maintenance space, is security policy. Does it explain to you what you as a security researcher or maybe as a developer can do if you want to disclose stuff with them? So I've run into issues with libraries or like bigger software products, and it's nice to have a contact you can reach out to. I say like, hey, I found this. If you disclose this in this way, you might even be eligible for a bug bounty, right? That's how it works with Microsoft. There are certain rules you need to go to. But it will look for a markdown file that will explain to you what the process is. And I think that's visible, right? How in what way is it done, and is it good? Like to have a policy in place. I think that's the key thing. The other thing, as I mentioned before, a license. Does it even have a license published? Because if there's no license, that's also maybe a legal risk that your employer or the company you work for don't want to take, right? And also gives the explanation like how and what context can it be used or can it not be used. The other thing that they look into is in relation to maintenance has to do with CI/CD. And this is something like, as I said before, every check is automated. This one is allowing project maintainers to do self-attestation to get this badge. So they will have like a form to fill out, and then somebody from OpenSSF will review all the practices. It has to do with like how is your build organized, what type of things do you use inside. There's a whole list of tools. But people can then self-certify, and then you will have a badge, and that will add up, right? You're doing the good thing, you'll have a badge, but it will also help out understanding how well it's built, in what way. Moving into the continuous testing space, does it do any test runs before it maybe, like if pull requests are merged or if the stuff is being built? And it will check based on the last commits, and it will tell you like, hey, yes, there is testing done or not. And the other testing, as I mentioned before, is fuzzing. And fuzzing would mean that you would throw lots of unstructured data against the project to see how it behaves. And in the old days, it was used a lot to do stuff with, let's say, C++, browser plugins, right? If you can get remote code execution inside your browser. In the old days, you probably would be king. Fuzzing allows you to find it. And there are different projects it will identify, right? So be aware that all these checks are based on a Git-based repo. So it will either run on GitLab or GitHub, and I will show some later on once we do the demo. But you can configure those fuzzing projects. But then the question arises, like, would it make sense to do fuzzing on .NET projects? That's a question I'm going to keep open, because yes, but there are certain conditions we need to be aware of. But there's a real cool project I'm going to touch on later on once we talk about the improvements. But you would say managed language should be fine, right? That's not completely true. The same counts with static analysis, and that's the field I'm working in, right? It's does the project use any static analysis tool like CodeQL or SonarCloud? And I missed one name here, but as I said, there's room for improvement. But the other thing we need to be aware of is you can do static analysis in different ways. And I think like having a tool in place doesn't necessarily say something about how it tests. It's the same for fuzzing. There are constraints in that. I think there's room for improvement. I will touch that later on. Then we're going to end up like, does the project have any binary artifacts? This is the malicious, like hard-linked DLL that's inside of the project or inside of the package that you cannot have or that you cannot determine where it originates from, right? I can imagine that there might be a case for test executables or something else to be inside of a repo, and I think those are excluded. But the downside of binary artifacts is they cannot be reviewed, like what's inside. And there's definitely a need for reproducible builds, right? We should be able to grab source from any package or any open source library that we use, and then maybe have the package or the binary from the ecosystem it belongs to, and then build and do a byte-by-byte comparison of those two. Because if you cannot do it, like how would you have the guarantee that that source results in that binary? That's a hard problem. So this will check if there's any executables. If they are in, that's a high risk, right? As I said before, with the malicious or with the unmanaged things, we need to review that. We need to know what's inside. The same counts if you look at how it works, for example, with branches. And what it does for GitHub, it will check if there's any settings like restrictive, and that there are code reviews required, and also that there is no force push possible, because that will override a public branch totally, right? You will lose your historical data. That might be valuable as well. How could you then go back or correlate what happened? So that's the thing. And the other thing has to do with dangerous workflows. There are certain patterns and certain things that you should not do related to you. And you can say, I can fix this, and there's like a pull request. And then during the nightly things that the projects were doing, they ran certain executables, and there was a problem in the workflow, allowing the person to add some stuff to the output binaries that were created. This was nicely disclosed. I think the person even made some money out of it. That's cool, but because the dangerous workflow, based on the way that the issue was being dealt with, allowed somebody to influence the output, right? So that's some kind of a supply chain issue. And then looking at VS Code, tool that everybody uses to develop the software, that's another piece of the chain, right? We're going to touch VS Code in a bit as well, but this is definitely a critical risk if there's a dangerous workflow used in case of GitOps actions. Then at the other end is like, how is there any visible code flow, code reviews done? And is there like any implicit review done where the merger is not the same as the committer? So have an additional set of eyes looked into the code. Right? We built with a whole group of people. And like, if somebody reviewed somebody else's work, hopefully the risk is lower. And that also adds up to how many contributors are there on a project. And this is a bit of a double-edged sword, because at least a project should have multiple organizations involved. That will at least make it safe. Like if there's multiple interest in getting it into the right shape, or doing even maintenance on it, that's the thing. If you have a single contributor, then you have that single block piece I showed when we started out, right? That's a risk. But is a large list of contributors good as well? That's the other side. Getting back to VS Code, VS Code relies on Electron. You're probably not able to fully see this, but it's just a sense of graph and how much there is. If you go to NPM, you can get this view, NPM graph, that's the website. If you then search for Electron, you can say, show me all the dependencies. These are the whole list of transitive dependencies you get if you use Electron. That's used in VS Code, that's used in Slack. So a lot of systems have it. There's 98 maintainers touching this code base. There's 1,100 contributors touching all these modules, all this code that ends up in VS Code, right? Hopefully everybody keeps a close eye on what's happening, but that's the other side, right? If there's a lot of people working on it, and we need to trust, right? Otherwise we're not going to get anywhere. There's a risk, and I think so that's a bit of a twofold thing. But this will add to not like a big risk; it's low, but it will give you some sense of what's inside. And looking at build stuff, does the project pin dependencies, right? Because if you have a pin dependency to a certain version, you will get like a hash. You can do it with MS build, and then with that setting being set, you can grab the same project. That's part of the source control. You will grab the project in another system. You will use the same dependencies to build, right? So reproducibility, it will help out. This is something that's a good practice, right? You also want to update your dependencies. That's the other thing. And if you look at actions in general, if you do workflow actions, if you rely on versions, that's not a good practice. You should rely on a hash, because a version can just be replaced with another one. And I believe you should just take the hash. That's the better thing. So it will look into that as well. And we're getting close to the end, but looking into, of course, token permissions. If a build is being executed and uses a token to access stuff, we want least privilege, right? That's always a good thing. Even with a process that runs in the system, if it only needs access to its running folder, like why would it need read access on the whole system, right? This is the same if you're doing a build. Because if somebody obtains the tick token and could do malicious things with it, that's a bigger thing. The other thing with build is it needs to be part of an ecosystem or a package manager, right? If we develop for NuGet, we have the NuGet ecosystem that helps us out, that with the .NET CLI we can identify if there's new versions, if we need to update. But that's because it's part of a bigger system, and that's a big plus. And if it's not doing that, that can be a risk, right? Because you cannot easily update or uninstall, and the package manager will help you out with that. Now we're going to get to the last one, and we're going to move to the demo. The other thing that's important has to do with signed releases. Cryptographically signing a binary would at least give you some trust, right? There are examples from stuff that happens in the past, which is related to, for example, let's say SolarWinds. They had one of their build servers compromised, and the package that they created was nicely signed because the build server didn't care, right? He had access to the key to sign, and he would just do it. And people eventually figured it out that something was wrong when they looked into its internals, almost the same as the XE. So signing a package is a good thing because it at least can assure you that it was signed at a certain moment in time. You can use Sigstore. There's also trusted signing right now in Azure that you can use, which all makes it accessible, and I would encourage to look into it. And the other thing is build provenance. So I've been doing some talks on supply chain as well, and provenance within GitHub Actions can be signed, meaning that at the moment when it executes, it will have a list of stuff like, hey, this is the branch, it has been done by this trigger, or Niels triggered this build to be made, it runs on this commit, it runs on this agent. All that information will be put in a file, and that will be signed by the GitHub action, and it will go to Sigstore, for example, and it will at least give you the guarantee that that did happen by that GitHub action at that point in time. Doesn't say anything about the internals, but it will give you some trust and some root of trust where you can work your way down from if something bad happens. So this helps us, and as I said, it's not a solution, but it will give us some guarantees. And now, as I said, there was a whole list of checks. Now let's move into where we're going to see some stuff in action, because it almost feels like I'm talking too much. So I need to get out of the slides, and let me move to the code VS Code. I think everybody should be able to see this. You can install scorecard itself, and you can run checks locally, and that's what we're going to do right now. So let me open up a console, and let me copy the first command to make sure that I'm not making mistakes. I should get a tool for doing this. That would help out. If I run this in my system, I'm going to immediately stop it, because I want to briefly show you something that happens first. It will probably complain about some things. Hold on. No, it's not doing that. So if you don't have a GitHub token that has public read access to the Git repo, because we're going to go to Git right now, it will complain that it needs to do some throttling, because you cannot hammer the API of GitHub with all the information and all the stuff you need. Right now, my session still has a key in memory. I have put it in an environment variable. Otherwise, I would have done it right now, but that's not needed. So I can still run it. So let me restart it. And it will take like, hopefully 20-ish seconds. It should not take that long, but it will do all the checks we just saw before, right? Dangerous workflows. It will look into the contributors. It will see if there's any vulnerabilities in, are there any binary artifacts. And this is happening on the repo. That's the one that's used for Newtonsoft.json, right? Which is like, is it still on top of the list with NuGet, like mostly used thing. And then it produces a lot of output. And this is not like what we're going to dig into briefly, but we can see that it has executed, for example, to see if there's a dependency update tool installed, which is not the case, right? It checked into contributors. It has seen that there are 15 different organizations that are involved with this repo. That's a good score. If we go up, we will see that the aggregate score Newtonsoft.json gets is 3.1 out of 10, which is not as good, but it will give us some sense. And as I said, all the checks down will allow us to understand better and allow us to understand what's inside. But this tool right now does it on a Git repo. Wouldn't it be nice? We're working with NuGet packages here, right? We want to grab something for a NuGet package. So the CLI also allows us to do it for a NuGet package. Let me quickly go back to the demo script. This one will execute the same, and I will explicitly tell it to put it inside of a JSON file, because that's something we can store and we can use. So let's do that right now, and let's see it run. And for the people who probably have noticed, there's already a version in it. If the demos fail, you should always be prepared, right? But this should work out nicely. It will create a new file, and it will get the same scorecard generated for that matter. But if we need to do this for every project and every dependency we have into like our system, that will take a lot of things, right? That will take some time. So I moved it into another directory, but let me just quickly open it up here. You see that this is the file it created, and it's the same information from a document. We can scroll up, we can see all the checks with all the details, and if we go up fully, we will see like the score is 3.1, and it has done it on the latest commit of Newtonsoft.json. There's also, that's the thing that I'm not really happy about, because we have versions of packages, right? And this also explains it has used this version of scorecard to execute. Is this a way to use it inside your project? I don't think so. Wouldn't it be nice if we can just view stuff that's already there? And luckily, if I go back to the demo script once more, I'm sorry. because I was into the other directory. So let me just open up my code once more in the other folder to get the demo markdown. Don't save. We will see that it's also possible to open a viewer. And if you go to the website of OpenSSF, you can say, give me the scorecard for this Git repo. And this data is already there. And you can even just grab it by an API. And I think this might be doing deep linking. Or this is, no, this is the same. This is also, and this is maybe a bit hard to read, but this also shows all the checks. And it's just there. And the data is there. So we can use it. But as I said, the problem with this, the data that's online, doesn't do anything with versions. Luckily, there is another website, deps.dev, which is done by Google. And Google also indexes a lot of more ecosystems. And the cool thing is that they also take into account the scorecard data. So we can go, we can grab a specific version, and if we then scroll down to the right, we will see the scorecard being generated here as well. This one has an API, and we can get that data instantly. So in the demo script, you will see that there are some curl commands, but wouldn't it be nice if we have a tool that just does it based on a repo that you have on your system, right? Or a project that you're working on. And that's exactly where a tool call comes in that I created, which is called Fennec. So let me go to a GitHub repo that's related to dasblog, which is dasblog is like from the old days. I'm getting old, that's how it feels. But there was a blogging engine that was created, and somebody ported it to .NET Core, and this is a big repo. And that repo has a lot of, if we go to source, let me see if I can, if I'm not sure, I don't think if I open it in VS Code it will make any sense, but there's a lot of project here. There are solution files, right? How can you harvest these things easily? So let me quickly point it out to the tool and then run it. You will see Fennec CLI is a tool that I use to do API dumping. I've done talks on third-party risk, and it's good to have some understanding of what's inside, and we're going to touch that in a bit as well. But knowing what's inside the library, that's important. But you can also do scorecard gathering. And what I created is you can say, hey, this is the project, and let me just get the scorecard for it, and then run. And what it does, it will iterate, it will grab the solutions, it will go into each of the project files, and it will get all the scorecards for all the projects that you're using. That's step one. And it will put it into a folder. And if we open up that folder, we can see all the projects and all the dependencies that we're working with. For example, there's Coravel. And if we format the document, and I believe this one is at the bottom, we can see all the checks that are being done, so we can review it. And then there's a score at the bottom, which states this library has a 4.3, right, out of the things. And you can maybe say, hey, we care a lot about code reviews. We care a lot about if there's testing done. You can all see it, right? You can make your own decisions. This is at least a step that will allow you to get things for stuff that you're working on. If you go to my GitHub, there's a Fennec repo, and that's work in progress. I'm a bit picky. I'm getting close to the thing because I want to add a lot of other things as well in relation to reproducibility and some other stuff. But this will at least allow you to get the files. You can store them and use them for your own benefit, right? Getting back to the slides, and then let's continue. Hold on. Sure.
What is that? Is that like a seasonal vulnerability that string you showed?
Yeah. So this one over here, you mean this one? Or not? These are the identifiers that GitHub Security uses to identify something. Some stuff will get CVEs assigned later, or not at all, depending on how they deal with it. This will at least give you a thing to identify. Funny fact is that if you run this on a repo that has, let's say, multiple, if you have a NuGet component that will do some .NET managed stuff, it might also have some views or maybe some JavaScript files or other projects it includes. The nice thing about a scorecard running on a repo, it will identify those things as well. Most of the, I believe if you look into these are all NPM packages that are inside the UI parts of this package that are causing the issue. So, but it will at least give you a sense of like, I can review it, this counts for this version. There's definitely room for improvement. Let me move back to the slides and see where we're at right now. So you can run it. The Fennec CLI, it's available. Hopefully, I will release it after summer. Would be cool. OpenSSF, they also do an annual report, and they claim like, hey, we almost scan like 1 million open source project, right? Which is pretty cool. They do it on a weekly basis. Data gets updated. You saw that sometimes scorecards will fluctuate, right? Scores will drop a bit. Projects are being changed. That makes sense, but it should not be like a goal, right? But you at least have a way to identify if there's something wrong or if something really bad downhill. But as I said before, there might be areas that we can improve, especially with doing .NET. And when I was talking about checking for fuzzing, I said like, hey, there's definitely some things that we need to be aware of if we're fuzzing .NET. As I said before, it's about throwing loads of unstructured data, and it's definitely good in finding memory issues. But if we do it on .NET, will it make sense? And the answer to that is yes, because if you do something like structured fuzzing, there is a library called SharpFuzz, which is based on a fuzzing framework called AFL, or American Fuzz Lollipop. That is a fuzzer framework where you can put your binaries in and it will do all its magic. But it can do some like guided fuzzing to help out understanding the library and how it's used. And the person who created it did a blog post last year where he explained like, what did I find? And he found serious issues. There are a couple of CVEs published, which had to do with denial of service, right? Because that's if you have managed languages and if there's like a Stack Overflow exception or the resources are being stuffed for some reason, that's an issue. And that might still be a problem if you look at it from availability perspective. So is there value in doing this? I would love us to be able to understand for .NET related projects that this type of libraries are used to fuzz. And one example they also gave, if you look into the repo, there is a project that will fuzz the GLJSON parser, which is like a JSON parser, a package you can find on NuGet. And what it explains is like we need to have some kind of a skeleton, a test base to understand the package in order to fuzz it in the right way. You can throw it against the fuzz and say just put in the data, but if it's not a valid JSON document, like what are you testing? You want to test the JSON deserialization for this library in order to make sense out of it, right? So this is some kind of like a skeleton test bench we need. And then this takes a stream, and that stream will then be instrumented by SharpFuzz. And it has a JSON document which is well formed behind it. And that's the thing it uses to alter, right? And then we need to just generate a whole bunch of code and a whole bunch of test cases in order to get it right. And what can help out doing that is, of course, GenAI and LLM. And as I said before, I'm doing a lot of stuff with Rust. And this is Fuzzomatic. That's a project that's run by somebody within the Rust ecosystem. And this exactly says like, hey, I would love to be able to generate test cases like the benches where we put the libraries on in order to fuzz it in the right way. And I would love to see similar things for .NET as an extension of what I'm doing, or maybe somebody else can help out with that. But this is definitely good use of LLMs and GenAI to like create a test bench to put it in. Because the same thing counts for doing static code analysis. As I said before, it all depends on how you look at it. If we see this code, what's wrong with this code? Everybody can probably guess what you're getting flagged. And this is not something, even if you run this on, let's say there are Roslyn analyzers, which will also mention to you like, hey, what you're doing here, you're using SHA-1 to do a hashing thing, right? And maybe for for maybe indexing or doing some caches, it might make sense. It's good enough. There are collisions. But for passwords, you should definitely not use it, right? That's the whole context you see over here. We should have static analysis done on libraries in the way stuff is used, and not maybe looking at some kind of this method call is being used. No, we want to have a data flow coverage, right? And this is also what we do. If you have, let's say, a component that does reporting, and that gets exposed over an ASP.NET controller, the public argument or the argument to give into this generate customer report method has a string argument, and that will then be flown down to that read all bytes, right? And in this case, this is a path reversal issue. If somebody can just put in a ... and do something else with the customer ID, you can maybe open any arbitrary files, and you would say like, hey, what about the extension? But yes, there is a max length in path file names, right? You can do truncation. There's a lot of options. So this will make sense for the same way we want to fuzz in a way that a library is used. we also want to do static analysis in the full context of a library and how it's used. And I think we should focus on that. So the presence of static analysis, yes, but understanding how it's being tested, that will be a good improvement. And as I said before, looking at the thing that's called reproducibility, it's important to be able to reproduce. So you should be able to go to newtonsoft.json, do a clone on your own machine, and then say build this, and then compare it to the package that you got from NuGet. Luckily with .NET and with Roslyn, there is a deterministic output guarantee. There's a document that will explain to you what type of constraints are being used if a project is being built. Has to do with also SDKs and maybe even sequence, but it's pretty deterministic. Then the question you should ask yourself is like, how reproducible is a simple console app? So within the repo, there is a folder reproducible, and there's like a whole demo script, and I'm not going to run through it right now. Maybe I could do it at the end if I've got some time left. But we can do a simple console app, and you can build it, and you can see how it behaves, even if you do it. Let me quickly just show you the script, and I can maybe, that will be a better idea. Hold on. Don't save. GitHub, NDC, Oslo. We have that reproducibility, and I think I put in the newtonsoft.json there as well. Let me get rid of it. And open the current folder. And there's the script. This one. If you just take a .NET New console and you build it, right? So let me just do it right now here. Let me stay in the same folder. If I now say .NET New console, let's just copy it because I want to make sure that I'm not like doing any fat finger work. So I create a new console app, which in this case is console app. Let's say I'm going to move this folder. I'm going to say console app right now is console app 2. And then I'm going to do the same command again. I'm going to create a second one, which technically should be the same, right? If I then build both of the projects, which is not happening right now, let me go to console app and then say .NET build. And if we go to the other one as well, console app 2, and say .NET build, we can then do the diff at the end, and this is the one I'm interested in seeing. So this is on my Mac. Copy. It's hard to do, right? Copy this one. Let me just do it one folder up. Over here, it says binary files have been compared because that's what I'm doing. And they say they're different, right? But there's nothing different in the files that I generated. Turns out that there's a PE header inside your binaries that will point out to debug symbols. And that's different, right? So if you would look at it from a binary perspective, then those files do differ because that path is different. If you look at the IL and look inside what's inside, then they are completely the same. And that's also the improvement that I would like to see. And if you go to the Fennec repo that's in my GitHub, you will see that there's a diff, IL differ, that will do exactly that. So I would love us to be able to say, hey, I've cloned this repo, and on GitHub there's this version of this package, and compare this repo that I have right here, which might be a certain commit, and compare them and see if there's anything different. And if we then automate that, then we can have some guarantee of reproducibility for a package, right? But it's not as easy as it looks. It should be hopefully a tool that will land in Fennec, and it's called diff. And there's an IL diff if you look into it, and you will see, and you will find it there. The other thing I mentioned before, Fennec has got instrumentation in it, which will dump all APIs that are inside the library. And if you run it on a package, please be aware that you always need to comply with the license of a package. You're not allowed to do it with all of them. But Microsoft has released, I think it was 2 or 3 years ago, a thing called App Inspector. And what it did is it took a code base and it will explain to you what's inside. So in this case, it will show you like, hey, there is cryptography used, or I have data storage, or it will go out to the internet, that kind of thing, right? If you're able to understand what's inside, you know, like, hey, this is a library which should only generate documents. Why does it need advanced cryptography? Maybe it does stuff with signing, right? Or maybe that makes sense. But it will give us a better sense. I'm also working on getting that kind of a thing based on a package, and then you can say like certain characteristics, and then have a report based on saying like, hey, we're most confident that this package does these operations. And stuff that you don't expect to be here, then hopefully that will show up. And if a lot of people look into this, this is quite cool. It would also be nice if there is a way of more collectively reviewing stuff. And as I said, Rust ecosystem, I'm looking into it, there's a thing called Cargo Vet. And what they do with this is like Cargo is the ecosystem of Rust where crates come from. That's their modules, that's their packages that they use, their package system. And Cargo Vet allows you to get review data from others, saying like, hey, I've reviewed this package for security. And for example, Mozilla has published some of this data into there, and you can say like, hey, somebody at Mozilla really did a thorough review of this version, so there's more guarantees, right? We know what's inside. So from that perspective, it will help us review stuff more collectively, and I think that's pretty cool. Jumping into a bit of the conclusion, and hopefully there's enough time for questions. I would say scorecards will help us reviewing packages. We need to have a better understanding of what's inside, know what the risk is. I'm still figuring out what will be a good workflow, right? It's always like a hassle with security tools that produce data. You need to ingest, you need to make sense out of it. And for sure, as a scorecard should not be a goal on its own, right? It should help you out in order to make sure what you're doing. Funny fact is that if you go to NuGet and you go up to the designs, you will find that there's a thing called package scoring that they're also planning on working on. I'm not sure like how much progress there is being made right now, but they have some metrics as well about the package itself. And if they share it, that's nice. More data, we can do more cool stuff with it and visualize it, right? And as I said before, looking at the tool itself, it would be cool if we can get more diffs and insights in. And also a trust graph. Can you imagine, like, if you have that solution thing you created, that you see a whole transitive tree of all the dependencies with all scores of all packages, right? That will be cool, and I'm definitely keen on working on that. And maybe, and hopefully contribute back to OpenSSF to have better coverage for NuGet and .NET in general. So with that said, I'm going to open up for questions. This is once again a generated image for this slide, but I'm going to show you the links I mentioned to you. There's a GitHub repo, and the demos of scorecards or the URLs you can find over there. There's a folder with slides in it, and that has the notes version. You can always reach me on my email or stay afterwards, right? I'm on Mastodon, and Fennec itself, that's the tool, and the blog is the one that I post articles on, which I should do more often, but if you want to know more about it, then keep your eye on that for the release of the tool. Yeah, and with that said, with 6 minutes left, it's time for questions, if there are any. Yeah?
First of all, thank you very much. For me, it's the best session.
Cool, thank you.
One question, very technical, about the Fennec div tool.
Yeah.
Because you say you generated the same project,
Yeah.
and you could find some differences.
Yeah.
But I mean, we have always differences, timestamp or width or something like this.
Exactly.
Do you ignore it or?
Yeah, I believe it's funny. I think 2 years ago at Build, Mark Russinovich also talked about reproducibility on Windows, and timestamps is always an issue, right? And yeah, you should take them out of the equation, because like how much value is it? And that's why for at least this div, I would look into the IL, because that's the .NET bits that we execute. And if we can compare that, then most certain the stuff that's in the PE headers should not have any effect on that, right? But yeah, good point. Yeah, that's the hard thing. But Windows has stuff that they cannot reproduce anymore. So how could you have the guarantee it's the right thing? Only by reversing it then and looking into it, right? And that's a hard thing to do. Yeah.
Second question is like more high level. I mean, if Newton Jason did 3.1,
Yeah.
what should I expect from the others? How can I like sell it to business people?
Good question.
Continue, but this one has 1.8 out of 10.
Yeah.
Except Germany, because in Germany we prefer not lower.
It's the opposite. So the question is related to like how would you interpret the score and how could you sell it? Yeah, it should be a guidance. I think you should looking into packages like looking at your company. If you do security development lifecycle, you have certain risk assessments. There might be areas that are more heavyweight for the industry or the stuff that you're doing, and I would at least take that kind of thing out of the scorecards and just use it as a guidance. Like a low score is not as good, right? Maybe you have a minimal score, or maybe you say like this is good enough because we reviewed it in more details and we're happy with this, right? It at least will give you a conversation piece. So that's also scorecards itself is being developed right now, and there's stuff added. If you might have noticed, there's one check webhooks that's experimental. They put it in, but they don't use it in the score in the calculation right now. So expect it to flux. But good question. I need to think about it. Like what would be a good guideline? I would say the closer to 10 is good, but a 10 probably never will happen. But then you should focus on the areas that I think that are important. Thank you. Any other questions or not? Then I'm going to say thank you. Enjoy the rest of the conference, and I'm going to be here if there's any other questions. And see you around.
Good evening, everyone. Welcome to the last slot of day 2. We made it. I know you're probably all quite tired after a long 2 days of learning, so I'll try and make this a bit fun. And we've got the cocktail party afterwards, so I'll see if I can finish a bit early so we can get out of here and get to relaxing a bit sooner than usual. I think if everyone's here, we can lock the doors and start looking for clues on how to escape. My name is William Brander. I work for a company called Particular Software. We make N-Service Bus. If you're interested in learning about how to build distributed systems in .NET, N-Service Bus is a framework and corresponding set of libraries to help you build rock-solid distributed systems. But I'm not talking about that today. So if you do want to talk about that, come find me at the booth later or at the party, and I'm happy to talk about it with you. Instead today, we're here to talk about my crippling addiction to escape rooms. I spend a lot of time in escape rooms. In fact, anywhere I travel somewhere, I try and do an escape room with the people that I've traveled with. It is one of the things that I absolutely look forward to. I haven't organized one in Oslo yet. In fact, I live in Johannesburg, and there's probably only about 2 or 3 escape rooms in Johannesburg that I haven't completed yet. So I need to ration them out for special occasions. I look for excuses to do them, so I now need to kind of hold myself off. Of the 7 continents, I've done escape rooms on 5 of them. There are only 2 left. North America I will be doing in 2 weeks, so I can tick that one off, which just leaves Antarctica. I've got 2 plans for that. One more realistic than the other. The first is to blow up Antarctica. If I destroy it, I've done all the continents, right? The second option is to do a complete change in careers, become a research scientist, get stationed at one of the research stations, and once I'm there, find all of the access control mechanisms I can and throw them out during a snowstorm, thereby triggering a really fun escape room with my fellow research scientists. I'm sure they'll love it. I would, of course, do it at the Norwegian research station, not because I'm in Norway now. South Africa does have a research station there, but the Norwegian research station is known as the Troll Station. And I can't think of a better place to act like that than at something called the Troll Station. Another fun fact about the Norwegian research station in Antarctica, because date time zones don't mean much there, they've got their own time standard known as troll time, which again is the perfect time to do shenanigans like this. Now you might be finding yourself asking, William, why would you build an escape room? And that's an excellent question, because it was a lot of work. And I built it for these 2. These 2 are my daughters, and I absolutely adore them. And they know that I love doing escape rooms, so they asked me if they could go do an escape room with me. Now, unfortunately, in Johannesburg, there's no escape rooms that are at a suitable level of difficulty to engage young children. So I couldn't take them to an escape room, because they'd probably just get annoyed, they'd get bored after a few minutes, because they can't solve most of the puzzles that are there. I ended up thinking to myself, well, maybe what I can do is I can make an escape room for my kids so that they can go and invite their friends and have a similar experience with escape rooms as I do. Maybe they can start building memories with their friends in the same way that I do. And to do that, I had to think, well, what do I want out of an escape room? What do I enjoy? So I started listing a few things. The first thing that I look forward to in an escape room is the decor. Like, these are absolutely stereotypical kitsch decor escape rooms. The more immersive it is, the better. If you live in a room like this, please come and speak to me, because you must be one of the most interesting people in the world. But this type of decor is amazing for escape rooms. It really immerses me. You can see there's padlocks hidden around the room, some with little combination locks, some with keys that you have to find. There's pictures around the room that are probably clues. This picture on the left-hand side, or right-hand side, sorry, it says, "Hell hath no fury like a woman scorned." Again, if you have this hanging in your house, please speak to me. But this one is definitely a clue, because the hell in the first word is written strangely. In fact, it looks a bit like a backwards and upside down 4, backwards, upside down 3, backwards, upside down 1, 1. So I'm willing to bet that somewhere in this room there's a combination lock that will be opened by the numbers 1, 1, 3, 4. And that's the type of stuff that I love. I also really love when there's more than one room in the escape room. So if you finish the room and you get to the last door and you've solved all the clues and you're so happy and you open it and you're presented with an entire new room with new puzzles that you have to discover and explore, that is amazing. It's so great. You're getting double the value for your money. So when I ran the escape room for my kids, what I wanted to be able to run it in environments where there were lots of rooms, and I could use the keys for the doors in those rooms as part of the escape room. Because it was portable, I also wanted to be able to make it that if there weren't doors, there had to be lots of containers and chests that they had to open. So I needed to be able to lock a bunch of different types of things so that they could go and explore. Because when they get into a new room and they see a new set of puzzles, new things they have to solve, that's going to stimulate their imagination. Along the same line, the puzzles that I give them must be engaging. They must make them wonder, like, oh, that is so pretty, that's so cool. Why are there green bottles? Those look so pretty, but there's some in the lid. What do I do with that? They must be stimulated. Their imagination must be triggered by what they see and they engage with. And of course, escape rooms must also be finishable. And I don't know if that's a real word, but I'm claiming it now, so finishable is a real word, even if it isn't. And the thing with being finishable is I don't want them just to be finishable, as quickly as you can. If you finish an escape room in 20 minutes, that's probably too easy, and you haven't been fully engaged with the room. You haven't had your imagination stimulated yet. So for me, the sweet spot is somewhere between 45 minutes and 60 minutes. If you can finish an escape room in that time window, it is perfect. In fact, some of my favorite memories of escape rooms are the ones where you can see a big timer in the room and it's your impending doom. As you can see, you've only got 1 minute left and it ticks down and you suddenly solve that last puzzle and everybody sprints to the front entrance again. That is amazing. I love that in escape rooms. So that sort of gave me my list of requirements that I wanted. I wanted the escape room to have simple puzzles, and when I say simple, I don't mean easy. Simple just means they must be easy for the children to understand, because I don't want to have to sit and explain how the puzzles work. An example of what I mean by this is pushing a button is simple. It's also easy. But if you put that button behind laser tripwires that they have to climb through, it's still simple to push the button, but it's hard to be able to do it. I then wanted the escape room to be finishable. I wanted lots of different areas in the escape room. I wanted to be able to have it in different scenarios so that if there weren't lots of areas, they can open lots of things. And I wanted to give the children a sense of wonder when they engaged with the puzzles. They must be visually stimulating for the children. Those were my absolute must-have requirements. I had a few optional extras that I wanted as well. I wanted some replayability because I wasn't going to go through all of this effort and run the escape room once and be done with it. And to get replayability, I needed to be able to have some of the puzzles be reconfigured in different ways so that they do different things and behave differently so that the children can do them multiple times. Now, out of all of these requirements, the hardest one to achieve for me was the finishable, specifically within that 45 to 60-minute window. And the reason for this is that some children are really, really smart. They're absolutely gifted. And some children they haven't grown into their smartness yet. And designing an escape room for different types of children with different skill sets and different strengths so that they're all finished within that 45-minute to 60-minute window is really difficult. So what I eventually came up with is I needed a way to be able to take the difficulty of the puzzles in my escape room and change it, make it easier or harder as the children were working through the escape room. So if they were taking a really long time at the beginning, I wanted to make the puzzles later on a little bit easier. But of course, I didn't want the children to know I was doing this because that would be a real confidence destroyer. And that's not really what we're supposed to do with children. So let's take a look at some of the puzzles that I made. And how we can use those puzzles or change those puzzles to change the difficulty of the escape room. So the first one is a balance puzzle. It's essentially just a little sphere that's got lights around it, and inside there's a little digital spirit level, and they have to get it perfectly level for a few seconds before it triggers. You can also change this puzzle to have it that if you point it at specific targets, it triggers a success. So you could have numbers stuck up around the wall of the room, and if they pointed at the 9, then the 4, then the 2, the combination could be 9, 4, 2 for them. Now, the way I can change the difficulty of this puzzle is by changing how close it must be to the target. How perfectly flat must it be? How long must it be on the target before it registers a success? And the number of targets that you must use. So obviously this wouldn't work if you were using it to show a combination like 9, 3, 2. But if you had it that they had to point it at the sun, the moon, and then the window, you could decrease the number of things that it had to point at before it unlocked the next part of the room. And then of course you could change how the object is manipulated. So if you're holding it in your hand, it's really easy to get it to point exactly where you want. But if you're manipulating it like my kids did with strings, and they had to pull it up or down, it's really fun to watch because they get so annoyed with each other. If I was running this for older people, I might have it that there were pulleys that they had to use to manipulate it so it was even harder for them. That obviously you can't change on the fly, but you would choose that beforehand. Another puzzle that was quite interesting was something that I called a musical tone. So there's a button at the top where you push the button and it plays a little song, a tune. Mary had a little lamb or something like that. And then the keypad has buttons, and each button corresponds to a specific musical note, and they have to repeat the song that's played from the speaker. This one is really fun to watch children do because for a change, they're quiet. They're all standing around trying to listen to this thing that's making little noises. Peace and quiet is a wonderful thing with children around. Now you can change the difficulty of this by changing the length of the song. Mary Had a Little Lamb is easier than Mary Had a Little Lamb, its fleece was white as snow. The longer you make it, the more buttons have to push and get correct to get the password. You can also change the randomness of the song. So if it's a song that they know, Mary Had a Little Lamb, it's easier for them to remember that song and listen to it in their heads while they're pushing the buttons. But if it was, in the case where I ran it for my children, the Tetris theme song, they have no idea what that is, and they struggled a bit with that. We've also got the Simon Says puzzle, where there's a few boxes, somewhere between 1 and 5. I eventually made 5 of them, where there's 2 buttons and 2 LEDs on the boxes. And these boxes communicate with each other, and they show a pattern along the lights. So the pattern will be gray, red, yellow, blue, yellow, red, and the lights will flash across the different devices. And the children have to repeat that same combination by pushing the buttons on each device. Children have no chill with this, and as soon as someone got it wrong, there was amazing fights and screaming between them. It was great. You can change the difficulty of this by changing the number of devices that they have to work with. So there were 5 that I eventually made. To make it easier, you could reduce the number of devices that actually take part in this. If there's only 2, it's easier than if there were 5. You can also change the number of buttons. Now, I don't mean physically go and remove some of the buttons. That obviously wouldn't be possible. But when it shows the lights, you can make them only use, for instance, the left light. Because if they only have to remember 1 button on each device, it's substantially easier because they're just remembering their position in the order, not the position and the side that they have to push. And again, you can always change the length of the password. So if you make the pattern they have to repeat longer, it's substantially harder. There's a bunch of other puzzles that I made, but these are the ones that are of importance for us today. So I'm not going to, if you want to hear about some of the other ones, you're welcome to come and talk to me afterwards, but I'm not going to cover them in this presentation. But once you've solved a puzzle, you need a way of dispensing the next set of clues. So we've got a few of those. We've got just a box with a maglock in it, and once they solve something, the maglock releases, and whatever's inside falls out. This works really well if you put it high up so that when something falls, it makes a noise. Variation of that, a little treasure chest with a servo motor inside that opens as soon as they solve something. I can't tell you how many times the servo motors have been stripped open because I didn't tell the children beforehand, it'll open automatically, don't force it, because they always force it. We've got some really imaginative ones. So a sword that's kept in place with a maglock on the side, and as soon as the maglock releases, they can take the sword out and see whatever was on the side there. I can tell you my wife really loved this one. But she didn't love it nearly as much as I love the next one. This is, I think, the best way to dispense clues. I call it splinters in danger. And again, my wife says that I've got a very prototype aesthetic. I think she's been very kind because this looks like shit. There's a little servo motor at the bottom of the latch and it keeps a string under tension, and when the servo motor releases, it flips forward and it hits the plank in front, shooting off whatever you've put in the little contraption at the top. This is really great because it makes a lot of noise. And if you can put it somewhere where the players don't know that this is going to happen, and you have them solve the musical tone before, where everyone's listening very intently and they're trying to solve the scene, and suddenly, bam! It gives them a great fright, and this thing comes flying through the air. I like to think that by terrifying the children, I'm teaching them that progress is scary, and achieving your goals is something that they shouldn't work too hard towards. So all of these devices have something in common, and that's how I interact with them. You use ESP. This is an ESP 8266. Most of the devices I used ESP32s, some of them 8266s. You don't really have to know too much about the difference. Ultimately, what these are little programmable computers, like Arduinos with Wi-Fi. And you can turn them into portable web servers. So you can have some code that runs there and says, well, when I get an HTTP request on this endpoint, return this response, or do something like that. So you could send a request through that says, well, when I send, you can make a HTTP request to the device that will then cause the device to open the maglock, for instance. The problem with this is that the way that this works is that there's a server.handleClient method. So this little loop method gets called over and over and over and over and over again. And the server.handle client just goes and checks, well, do I have any waiting HTTP requests that I need to respond to? And this is single-threaded, which means that in the happy path, what happens is you get an HTTP request into the device, and the device says, oh, okay, sure, here's your response. But it's not always going to work like that, because sometimes you might have other devices connected. So this is a digital spirit level. It's an MPU 6050. You don't really need to know about that. But some of these devices have digital motion processing on the chip, and some of them don't. And if they don't have it on the chip, you have to do that calculation yourself manually. So if your device is busy calculating the angle, it might take a long time. And if it's taken a long time and you get an HTTP request coming into that device while it's busy calculating the angle, by the time it manages to work out what the response is and finish calculating the angle, that HTTP request could have timed out. And as far as the client is concerned, that device is no longer working. This is a form of temporal coupling, where you've got, if you make the request at the right time, you'll get the response, but if you make the request at the wrong time, you might not. So ideally, instead of having this type of coupling, the better way to do it would be you'd have your devices sitting there, they would calculate the angle for whatever they need to do, they would take whatever time they have to do to calculate that angle, they would get the response, and then afterwards they would go and check, well, what do I need to do next? Maybe there's a database somewhere that's got a list of things that they have to do. Oh, I've got the angle here, the angle is this, so now I need to go and open that maglock or something. Now, because I work for particular software, we do a lot of messaging, so naturally I went for MQTT, which is a messaging technology. Stands for Message Queue Transient Telemetry, I think. And it's a really nice way of using messaging with these IoT devices because it's lightweight, so these low-power devices can work quite easily with MQTT. It's reliable, so you can specify 3 different levels of quality of service. You can do at most once delivery, at least once delivery, and exactly once delivery, which is pretty cool. It's also standards-based, so if you're working with a MQTT broker and one day you want to move to, I don't know, Azure IoT Event Hubs, you can just change and everything should work in theory because it is standards-based. But even though it's got the word queue in the name, it's not actually a queue, so there's a few downsides here. The queue length of MQTT can only be 0 or 1. You can't ever have more messages in a queue, which is weird for a queue. And it's got a slightly smaller feature set. But we'll take a look a little bit later at how we can work around this. So for my system, I had all of these devices, and they were communicating via Mosquito. Mosquito is an instance of MQTT. And that's all of the context out of the way. So now we're going to start getting into the microservice stuff. And the things we're going to look at are how I monitored it, how I decided what the aggregate routes are for these different components, how I managed the flow of the escape room, how I was able to change the difficulty of the puzzles as people were playing, and how to work around the limitations of MQTT. So those are the 4 things we're going to cover in the rest of this talk. Monitoring the devices. So the first thing that I did when I monitored the devices is I wanted to know about failures. When something goes wrong, I want to know about it. But the thing with these devices is that they're not really that good at this. So what happens is, if something goes wrong, yes, you can write C++ or Python or JavaScript on these devices, and they all have try-catch mechanisms in them. But a lot of the times, the libraries that you use don't really follow good citizenship when it comes to how to deal with exceptions. So oftentimes, the devices just crash and reset. And when the device comes online, you need to go and check, well, okay, why are you coming online? Did you lose power? Was it a watchdog timer that you thought I was taking too long to do something, so you just reset? Was it a hardware fault? Was it an exception? So you need to monitor all of these things. So then I thought, okay, well, what I'll do is, instead of actually going and checking the failures, I'll just see if the devices are online. So I'll include some type of health check API. And I can do that because it's just a web service. I'll have a /API/heartbeat. And as soon as it gets a request, it just returns a response 200 OK. I mean, that's fine. That works. I also thought, well, maybe I could look at the queue length. And as I started getting down the rabbit hole of this, it kind of became familiar to me. There was a bit of nostalgia to this. And I thought, hold on. This is reminding me of the way I used to monitor systems in the mid-2000s, where you had an application server and a database server, maybe a web server as well if you were really fancy. And the way you monitored these systems is you just asked 3 questions. Is the web server up? Is the database up? And can the web server talk to the database server? This is a very naive way of monitoring systems, and this is kind of what it was feeling like when I was trying to do these health check APIs on these devices, because it's basic. It's not giving me any insight. But the thing with these devices is they're quite small. You might even say they're like micro, right? And they provide a service. They do some type of capability. So maybe they're micro capabilities, not microservices. That's a rude word. Now, I know about monitoring distributed systems or microservices because that's part of my day job. And when you monitor distributed systems, there's 3 things you need to think about for everything that you monitor. The first thing that you need to think about is the area that you're monitoring. So what do I mean by the area? Are you monitoring the infrastructure of your application, of your system, or are you monitoring the application of your system, or are you monitoring the actual capabilities that your application exposes? Some example questions of this is if you're monitoring the infrastructure, you might ask, well, are my devices online? For the application, you might ask, are my devices responding to publishers? Are they doing what they're supposed to do? And for the capability, a question might be, can my players solve the puzzles that I presented? Is that capability functional? So when you look at the monitoring area, you've got infrastructure, application, and capability that you can monitor. Next to that, you've also got the concern that you're monitoring. So by concern, what I mean is you could monitor the health of your system. Now, there's a many-to-many relationship between the areas and the concerns. You can monitor the health of your infrastructure, the health of your application, and the health of the capability. The same with the performance. You can monitor the performance of your infrastructure, the performance of your application, and the performance of your capability. And the same with the capacity. So those are the 3 concerns that you could monitor. And then the third thing with monitoring distributed systems is how you interact with those logs or those monitoring systems. Is it passive? Are you just looking at the log files every now and then? Or you just, okay, something's gone wrong, we need to look at the open telemetry for the system and see what went wrong. That's passive. You're looking at something after the fact. You could also do reactive monitoring, where maybe the monitoring system that you've got in place automatically detects, oh, this looks a little bit weird. I'm going to send a push notification to the ops team so that they can look at this before it becomes a potential problem. And then you've got proactive monitoring. So this is where the system would try and make changes to fix whatever might be potentially a problem. A good example here is auto-scaling. If the queue length is getting really long, maybe you automatically scale up other instances of your handlers so that you can bring that queue length down. So with this framework in place, let's take a look at what we were seeing with the IoT devices. So with the health check APIs, what I was monitoring was the health of my infrastructure, and I was doing it passively. Because I would just go and look, well, something's not working. Are they, oh yes, they're all up, it's fine. But if I was looking at the MQTT queue length, now, because the MQTT queue length can either only be 0 or 1, I know that if a queue length stays 1 for a really long time, it means that something isn't taking messages off of the queue. So again, I know that there's something wrong at an infrastructure level. The health of my infrastructure is suffering there. If I was looking at the failures, that would be, as soon as the device restarts, it goes and sends a message to say, hey, I failed because X. That is a reactive way of monitoring the infrastructure of the health of my infrastructure. Now, this is a lot of health infrastructure monitoring that I was doing. Am I getting new information from these 3 things? And the answer is not really, because there were times where the health check API was telling me that the devices were up and working, but the MQTT queue length wasn't changing, it wasn't ever decreasing. And what that tells me is that while the device is online and it's on the Wi-Fi network and it's responding to HTTP requests, it's not taking messages off of the queue. It's not processing messages. So the health check was actually a false positive. And with that information, I could then say, well, I don't actually care about the health check API anymore. Instead, what I can rather have is a dashboard or another tool that monitors all the queue lengths. And then I can immediately know if the devices are actually processing things. I could also have included canary devices. So maybe while the players are going through the escape room, I could sit and follow them and do a few decoy devices on the side to make sure that what was happening here would happen if they did it over there. And if I picked up a problem, potentially see maybe I need to turn the device off or non-reset it or something like that. That would be proactive monitoring of the capability that my application was providing. Let's take a look at some other examples, some non-IoT examples. So perhaps if you're monitoring queue length in a real application, that might be a good way to check the performance of your infrastructure. If the queue length is increasing, that means that the performance is potentially not enough and you need to scale up the endpoints. Or if the queue length is decreasing or staying constant, the performance is fine. Processing time. Processing time is how long it takes for a message to be processed once it gets taken off of the queue, so how long it takes your application to do something with that. That's monitoring the performance of your application. But of course, messages don't just exist as they're being processed, they exist in the queue as well. So combining queue length and processing time, we can get a metric known as critical time. And a critical time says, well, as soon as I send this message, the critical time of this message is however long it takes until it is processed completely. So that means it includes how long the processing time is, as well as how long it spends in flight, in the queue, waiting to get picked up. And you can use that to look at the capacity of your application, because that's a more important metric than just queue length. Queue length doesn't tell you how long things are staying in the queue. It just tells you how many things are in the queue, which is potentially maybe a problem, maybe it's not. If the oldest message in your queue is only there for 10 seconds, maybe not a problem. But if you've got a queue length of 5 and the oldest message in the queue has been there for an hour, potentially something you need to respond to. You can also use queue length to trigger scaling, and in this case, you would be doing proactive monitoring of the performance of your infrastructure. Like I said, it might be better to use a metric like the critical time or the processing time to be able to do that scaling, because you don't always just want to scale a queue that's got a lot of entries in it. So that's how you monitor distributed systems. You take the area, the concern, and the interaction type, and you can use that to see if you've got duplicate things, duplicate bits of information that you're getting. Because if you've got a large distributed system, there's a lot of monitoring information that can be presented at you, and you don't necessarily have to pay attention to all of it. So by categorizing which of these attributes you're monitoring and why, you can use that to potentially exclude noise from your monitoring systems, and then use that noise when you need to actually dig into what went wrong. So that's monitoring the IoT system. Let's take a look at the aggregate routes. I like using the musical tone as an example of an aggregate route because it is self-contained. It's a box on its own. Everything that you need to do is within that box, and it's a physical one. So for instance, all of the logic is self-contained. I can completely change the way that that musical tone puzzle works and is solved. Nobody else, no other puzzle in the entire escape room needs to know about that. The only thing it needs to do is that when the puzzle has been solved, it must publish an event that says, hey, I've been solved. That's all it needs to do. That's its only promise to the outside world. The only thing it needs to know from the outside world is when the difficulty changes, I need to change my difficulty either easier or harder, depending on what that is. So in this case, while it's a physical device, the service boundary, the aggregate route, is very well defined around this device. It's not quite so with something like Simon Says. So with Simon Says, where there were 3 boxes or 5 boxes or 2 boxes involved, what would happen is if we had another component that would have to change the difficulty of the puzzle, when it went to go and publish a message to say, well, we need to change the difficulty to 5, whatever that means, it sends a message to Mosquito, and then the devices go, okay, I can't make that decision on my own. I need to know what the other devices in Simon Says are doing. So we need to communicate together to be able to say, well, what do we do with that difficulty change? Which means that the boundary of consistency cannot be at this physical device level. It has to include all of them. So what we could do then is we could have a notion of a primary device. And the primary device would have secondary devices. Once they all start up, they would create a peer-to-peer network between each other, and only the primary has to talk to Mosquito, or MQTT. Then when the difficulty messages come through, that difficulty message goes straight to the primary device, and the primary device says, okay, everyone, we're only using the left button now, and the pattern is going to be me, you, me, you. And the other devices go, oh, okay, cool, got it, thanks, move on. If something goes wrong with the primary device, maybe the battery runs flat and it disconnects, well, one of the secondary devices can take over, create a peer-to-peer network between the other devices that are remaining, and then subscribe to Mosquito, MQTT. So in this case, what this means is that the boundary of consistency of these devices, the aggregate route that we've got, is around all of them. Logically, there's only one instance of the devices, but physically they're deployed in multiple places. And the boundary of consistency has to be around all 3 of them. With all three of them in place, it means that the logic is self-contained, even if it is distributed across multiple devices. The logic within the service boundary can change completely. All they need to do is publish an event when the puzzle has been solved and subscribe to an event when the difficulty changes. So the service boundary is well defined around the three of these. Let's take a look at some more real-world examples. So maybe we've got a stock service, and a user is trying to delete an item from the stock system. And it says, okay, well, I want to delete this item, so the stock service will go to the authorization service and say, does the user have access to delete this record? And the authorization service will say, yes, they do. Go ahead, delete. The stock service has had to go outside of its service boundary to ask for information before it can do what it needs to do. It means that the logic is not self-contained within the stock service. It also means that the stock service needs input from the user service to be able to make a decision on what it needs to do. The service boundaries here, the aggregate root, is poorly defined. Another example, maybe if you're working in the insurance space, is anybody doing insurance? Maybe you've got a claims processing system, and the claims processing system would ask the payment system, hey, has the user paid all of their premiums? Again, it's going outside of its own system to ask for additional information. Or maybe you've got an order service, and the order service has to ask the stock service, hey, do we have stock of this item that I want to actually send to the customer? All of these are examples of where you're going outside of your boundary of consistency and you're asking for additional information. So the fix is easy, right? Well, all you do is if you need more information, just make your service boundaries bigger, right? And include all of those new things in your service boundary. Except sometimes that is the right answer, but ironically, a lot of the time you can make smaller service boundaries and get those boundaries of consistency even easier. For instance, if instead of a stock service that handled removing, you had a stock removal service that only did removal of stock items. The only thing this service does is remove items from the database. We don't have to worry about whether the user has the correct access to use this thing, because at a permission level, we can say, well, if you can publish a message to this topic, you by default have permissions to be able to remove items. It becomes an infrastructure concern, not a business rule check that we have to follow. So if someone can access that particular topic and publish messages to it, it means we don't need to ask, does the user have permission? And the important thing here is that we're doing something, we're not a something. So we're doing the removal of stock items. We're not doing stock service. Stock service isn't a thing. It's when users interact with your system, they're doing things. They are verbing your system, not nouning it. So in this case, the stock removal system only needs to know what it has to know. It doesn't need to know anything outside of just removal. It just needs to know, okay, the user wants to remove this thing, great. But what if you had slightly more complex business rules? So everyone can delete items from the stock service, or everyone can delete stock items, but only if they're below $1,000 in value. If it's more than $1,000, you need approval. Okay, well, you still have your stock removal service, and when the user removes an item, it publishes an event to the approved stock removal service. And that one approves it. So if the item being deleted is less than $1,000, it automatically approves it. Otherwise, it appears in someone's inbox, and they have to then go and approve that. Again, that service is only approving the removal of stock items. By making the service boundaries smaller and narrower, it's easier to get consistency boundaries, or boundaries of consistency. And the key thing here is that service boundaries are business rules. And by just hiding them away in stock service or policy service, you lose a lot of the richness of those business rules that you can use to make your systems easier to work with. The question might then comes up, well, if they're so small, if you're making these service boundaries so small, doesn't that limit you in terms of the workflow that you can do? We'll get to that next. So we've taken a look at aggregate roots. Let's say we've got all of our devices here, and we want to control the difficulty of the escape room. We want to make the room a little bit harder or a little bit easier as the players go through. Now, when I started with the escape room, I only had a couple puzzles. So it was easy. I could say, well, when they start this thing, just have a little timer that says, how long have they been working on this? Oh, it's been this long, so I need to change the difficulty and make it a little bit easier. Great, that was fine, until I started adding more puzzles. Because then what happened is, each puzzle has to keep its own record of, well, how long have they been doing this? Do I need to keep track of this? Which room have they finished? Which puzzles have they finished? Have they finished you? And the devices have to start knowing about each other, and they have to start asking, well, where are we? What can we do? And as you add more and more devices, it becomes harder and harder to do this and keep track of how things are working together. So I introduced the concept of an escape room run. And an escape room run is a state machine. So the way that this works is the players start the escape room. And immediately, as soon as they start, they are on schedule. The state of the escape room run is on schedule. They solve some puzzles, some time passes, and they're still on schedule for a while. Eventually, enough minutes pass that they are behind schedule. So the state has changed from on track to behind schedule. And at that state transition, my escape room run can start taking messages and publish them off to say, okay, now we need to make the room a little bit easier. Actually, I'm going to not have that puzzle in the room at all. They solve some more puzzles, they solve some more, and eventually they get back on schedule again. Maybe it's still too easy, or maybe we've left it too easy, so they eventually solve enough puzzles that they are ahead of schedule. So again, this is another state transition. So in this new state, we will again publish more messages to say, let's make the escape room a little bit harder. And eventually they solve more puzzles, time passes, and they get back on schedule. And the state transitions happens over and over again as they go faster and as they go slower around the escape room. And eventually they can complete the escape room from either of the states, either ahead, behind, or on schedule. So at a conceptual level, the escape room run is a state machine that does a few things. The first is it tracks how long the players are spending in the entire room, not on specific puzzles, although it can. And it adjusts the difficulty of the following puzzles based off of how much time they've spent already. And it can change the entire flow of the room, so it can completely take some puzzles out and say, well, we're not going to do those ones anymore at all. Or if they're going really quickly through, maybe reintroduce some of the previous puzzles that they did. But the key thing here is that the puzzles don't need to know anything about any of the other devices. All of the complexity around managing the flow is encapsulated within this state machine. The puzzles don't need to know that, oh, I'm suddenly not part of the thing anymore. They just don't become part of the room. It's kind of like an orchestra conductor. Someone who's sitting there and standing there, usually, and they're conducting the orchestra. They don't have to play the individual instruments, but they would say, I need more strings, I need less percussion over there. Harp, you're scratchy, get off, you're not playing for a while. And then as they start seeing how the audience is responding to their symphony, they might then bring the percussion back up, bring the strings down, put the harp back in. They control the entire flow and the pace of the orchestra. But the violin player doesn't need to know what the percussion people are doing. The violin player has just got their sheet music in front of them, their algorithm, and the cues that they get from the orchestra conductor. Now, while the orchestra conductor can probably play a lot of the instruments in the orchestra, they're also not doing that. They're just controlling how everything comes together. In code, there's 3 patterns we can use to accomplish this. There's the process manager pattern, and if we're in the .NET space, we typically call those sagas. There's the actor model, which you can also use, and there's the route and slip pattern. Now, the route and slip pattern is probably going to be a little bit harder to do than the other 2, simply because as you send that first message out to start your escape room, you have to have the full compensating flow included in that original message. But the key thing, or the fun thing here, is that the aggregate routes remain simple. The violin player doesn't need to know anything about anything else. The puzzles only need to know about their own little world. So those consistency boundaries stay the same. But because you've got this process manager, you can build some really complex workflow into your escape room. And the complexity is encapsulated, which means that it can be tested. It can be unit tested quite easily. You've got all of this complexity sitting in one class that just says, well, state transition. What happens when I transition to this state? What do I need to do? What do I expect to happen? Has it happened? Yes. Very easily testable. In a more maybe real-world scenario, you might have the claim capture service that publishes an event to say, hey, the claim process has started. A user has submitted a claim. That would go both to the Saga as well as to an assessor feedback service. And the Saga says, well, okay, I need something else to carry on with this claim, though. I need to know whether the assessor says that this is a valid claim. I need to know from the payment service that they've paid up to date. I need a whole bunch of information. So the assessor feedback service would go and say, well, the feedback has been captured. And maybe this is enough for the Saga to go and say, okay, cool, well, that means that the claim has been approved or rejected or something like that. So the claim capture service and the assessor feedback service only know their thing, but the Saga, the orchestrator, knows more and is able to piece those pieces together and send those messages off. which means that I've got my devices, and then to control the room, I introduced a escape room run, which is an implementation of the process manager pattern. And that then allows me to have the super small boundaries of consistency while keeping complex logic flow within my system. Now, in order to do this, I needed to work around some of the limitations of MQTT. So as we said, MQTT is not actually a queue, and it's got a slightly smaller feature set. The things that were problematic specifically for what I was trying to do was that there's no support for delayed delivery in MQTT. So delayed delivery is where you say, I want this message to only be sent or delivered to the endpoint in a month's time. For the escape room, it was going to be matters of minutes, not months. But there was no support for delayed delivery at all. There's also no support for time to be received, which means that if you get a message after it's expired, you want to be able to discard that message, where MQTT doesn't have support for that out of the box. And most problematically, you can't queue up messages. And because there's lots of things going on all at once in the system, there's a high probability that a lot of messages will go to my process manager, and it will lose messages because they'll be overwritten by other messages. And strangely, for something that's so ubiquitous, MQTT is surprisingly hard to monitor, which I found a little bit odd. What I would have liked is if I could have all of my devices talking to a broker that they were really good at talking to, and I could have my application logic, my complexity, talking to a broker that it was really good at talking to, and then maybe there was something in the middle that allowed the two to talk to each other. And this is where you implement the messaging bridge pattern. So the messaging bridge pattern allows you to have different endpoints on different queuing technologies, and it takes care of shuttling the messages backwards and forwards to where they need to go. And the two sides of the transport don't need to know anything about each other. So for instance, if I added another service that collected stats about my catapult, that wouldn't have to change any of the code on the devices side. All it would do is say, okay, well, I want to subscribe to that message in RabbitMQ, and the bridge would take care of saying, oh, that means I need to subscribe on MQTT and forward messages through. It's a super powerful technique. Now, the way that it works is that it would take all of your physical endpoints, so it would replace the sword with a logical sword, the essence of a sword, if you will. It would replace a treasure chest with a logical treasure chest, and it would go through all of the devices and change them. It would do the same with the application parts, and then the transports would also just be replaced with transport 1 and transport 2. So we're dealing with logical things. The bridge is the only one that knows, okay, transport 1 is MQTT, transport 2 is RabbitMQ, which means that when my Saga needs to send a message, it publishes an event to a topic on transport 2. The bridge knows, oh, hold on, that must actually go to the catapult. So it takes the message off of RabbitMQ, goes to MQTT and says, well, how do I transform this logical endpoint into a physical address? Okay, now I send it over there. Which also means that you can add additional functionality without changing the previous system. So you can add a new logical sword, and when your Saga publishes an event that the sword is interested in, the first one will go via RabbitMQ, and the second one will go via RabbitMQ MQTT to the original sword. This is a super powerful technique for doing things like modernizing legacy applications. If you've got a system that's talking MSMQ, first of all, my commiserations, that must be very hard on you. Second of all, if you've got the concept of, or an implementation of a messaging bridge, you can then, instead of having to make changes to your MSMQ system, deploy the bridge and start using newer, cooler technology, such as AWS SQS with Lambdas. And the MSMQ system doesn't need to know anything about the new technology. The new technology doesn't actually need to know anything about MSMQ. All of that routing logic sits within the bridge component and is able to take messages from one to the other. So if you were modernizing existing systems, what that would mean is you could slowly start taking bits of that system, moving them to newer technology, and the older parts wouldn't have to change. So you can use this to do step-by-step modernization of legacy systems. Super powerful technique. Right, so we've taken a look at how to monitor it. We've taken a look at aggregate routes, how we manage the flow of the escape room, and how you can work around limitations of technology. The question then becomes, well, how did it go? Well, here's good news. So it took a long time to get the whole thing assembled. Here is a picture of me assembling the balance puzzle. This was probably about the 5th or 6th iteration, and at this point I was convinced that I had all the kinks worked out, which is why I was using a new strip of LEDs on this one. It wasn't until a few minutes after this picture that I realized I forgot to re-include the holes into it so that I could get the electronics coming through the back. So we then moved on to iteration 7. The musical tone puzzle, I really wanted to have a little small profile, but I couldn't get the print strong enough, so I printed I don't know how many different versions of it, and eventually that's why it's now this big bulky thing that looks like it's a phone from the 1990s that my children have to use. I cut myself a lot on not just the sword, on lots of things. You'll also note in this picture that under the censored parts, that's where the fresh blood is, I have a plaster on, which means that wasn't the first time today that I had cut myself doing this. I'm not good at soldering things, so these 2 buttons need to go into these 2 holes, except you may notice that they're already soldered together, so I had to unsolder them. It was a lot of fun doing that because not only did I burn myself with a soldering iron many times, not only did I make many mistakes like this, I also melted the cable of the soldering iron with the soldering iron. And for those of you that like your clicky-clacky keyboards, I apologize, but I also melted 2 holes into my keyboard. It was not good. I am not good at soldering. But anyway, eventually I got all these pieces assembled and ready to go, and I thought, okay, now I'm excited. Let's get this. We'll get all my children's friends together, and we'll run this escape room. And it was exciting. You build something like this, and you think, well, this is going to be great. It's going to be like the Colosseum. There's going to be these amazing Greek warriors coming in, and it's going to be great. Maybe it'll be like the movie The Goonies, where the children work together and they solidify their friendship, and they come out better for it at the end. I didn't get that. I got this. They broke everything, absolutely everything. For the first attempt, it was painful, but I was happy with this. It was okay. It was a learning experience. The second attempt was the exact same thing. The third attempt was the same. Eventually, on the 4th attempt, this is a picture of me sitting outside afterwards in absolute despair. My dog is excited that I'm there with him, but I could not care at all for that poor animal at that point in time. And I distinctly remember after this picture was taken, one of my daughter's friends, she's an absolutely tiny little girl. She looks like she's about 3 or 4, but she's 5 or 6, and she's very sweet. And she comes up to me while I'm sitting there outside, and she puts a little hand on my shoulder, and she looks at me. And children are kind. Like, I don't know what it is about as we grow up. We lose a lot of that innate kindness. And this little girl, she puts her hand on my shoulder, she looks at me, and she says, maybe you should have tried harder. And the kindness stung for a long time, but eventually I did try harder, and we got all the pieces working together. So there's a few pictures of the kids doing some of the more physical puzzles. I included a lot of the physical puzzles at the beginning of the escape room so that at the end I could have more leeway with changing the IoT ones. So they solved the thing, they eventually managed to get it, and they opened the final crate and got their reward out at the end. And it was a lot of fun. But there's a few things that I remember from this experience. The first being that monitoring complex systems, even if it seems simple, must be intentional. These devices, it didn't seem like it was going to be a big system, but by thinking about monitoring it as a real production system, it was easier for me to identify what was important when I was monitoring it and what I could ignore. Service boundaries are business rules, and if you just ignore that, you lose a lot of value, and a lot of simplicity gets introduced when you embrace those business rules as part of your service boundaries. And distributing state allows you to keep the simplicity within the devices. Polyglot messaging can be super useful. Greg Young has a talk about polyglot databases. I suppose this is polyglot messaging, which is quite fun. But for me, the most important thing that I got out of this, and that will stick with me for a very long time, is what it did to my children. My daughter on the left here is building her own little escape room at my parents' house. And it was because she had so much fun eventually doing the escape room that I did for her. My daughter on the right, one of the other puzzles involved a magnifying glass. So from magnifying glasses, we got to binoculars, and binoculars then became telescopes. And now she makes me take her to stargazing camps so she can look at the stars in the skies. The experiences that I've created for these children was more than what I initially anticipated. So when you go through the rest of NDC Oslo tomorrow, don't just sit, or obviously sit and absorb some of the learnings and the technologies and the techniques for the rest of the conference, but also think about what else could this potentially unlock for me in the future. Thank you very much. I do have time for questions, but I'd rather just meet you outside and you can chat to me there. If you want to come to the particular booth tomorrow, you'll see a few of the escape room puzzles sitting running there, so you can also give them a bit of a go if you'd like. Thank you.